Good morning, everyone. I hope you're all doing fantastic. I hope you all had a great weekend. I know I did. So let's share this out with everyone. Trying to go slowly to solve the problem. Well, okay. So yesterday, or no, not yesterday. We rushed a lot yesterday, and that led to an unsuccessful adding of a spotlight at last time I streamed. I keep saying yesterday. Apologies. And that's what I'm going to try to avoid today. Well, we're actually going to be very careful with this, and we're going to try and solve this problem of adding different lights other than spotlights into the scene without rushing. And hopefully we end up getting somewhere today. I'm not too concerned with the actual light itself. What I'm more concerned with right now, at least, is understanding how lighting works. Right, the theory, the mathematics behind it, the attenuation between how light works and stuff like that. That is gonna help me in the long run, rather than worrying about like how to get a basic spotlight in the scene implemented. We need to get this attenuation factor with these two different inner and outer angles between the spotlight working, so we can have physically accurate lights. Even for punctual lights like this, it's important that I at least have the lighting. Let's turn that down a bit for you guys. I at least have the lighting is physically accurate. This is so that the materials that we work with are actually going to be represented well with light, and that means we can, let's just say I go from a spotlight to a point light to, I don't know, a directional light. All these lights that we end up using throughout the game engine are going to be, as realistic as in real life. So there's no weird, this kind of looks like a Unity game from 2013 spotlight, right? We want to make sure that all our lights are correct. I have control over the lights. I can make the lights look good, and I need to make sure that I hold myself to the standard of making sure that the lights are accurate. But this requires, unfortunately, more maths, and so we're going to be poring over this when it comes. Hello, how you doing, dude? Thank you for joining us. Andrea. We're going to be poring over the maths. We're going to make sure that we get this completely right, so we understand the attenuation and the other factors involved with punctual lights. Then we might get, if I get up filament as well, let me just bring this up for you. Working while listening to you. Fantastic. I do the same thing, so, very much appreciated you turning up, and I'm glad I could have, I could be your virtual co-worker today. I very much enjoy doing it myself. So thank you for picking me out of all the people you could have picked. So we are so we might end up doing depending on how well things go today. Photometric lights, which we have this kind of stage lighting effects, I believe, or like lamps. But we'll see. It's more important that we get through this code today, understand exactly what we're trying to do to make sure things are physically accurate as possible. The only thing that keeps my brain working and unslopped. Yeah, I know what you mean. It's good to keep you focused, having a nice virtual co-worker. Like I said, I do it all the time myself. Oops. Getting attacked by a fly. Yes. Right, okay, so how are we going to tackle this today? So the first thing I'm going to do is just do a bit of revision on the maths that we talked about, and yes, so we're going to go from top to bottom. I'm going to read this out loud, so you're not just hearing me, read in my head. And we're really going to drill into parts. What I think's happened throughout studying this, due to the fact that I was rushing yesterday especially, I've probably missed something that I'm not understanding. So that's what we're going to try and target today. Then we're going to try and implement the the code that Ratchet gave us and the code from this the Filament game engine, and we'll try and get this looking nice. So let's just show you where we're up to anyway with the scene. Currently it currently doesn't work, which is that could be fixed though. Typically that means I've lost a easy to find variable. I've usually commented it out. So let's just see where light intensity is living today. Okay, so we just have some random variable that needs to be assigned. Light intensity is the actual value. Okay, so if I add that there, and I think that should run. So what have we got? Okay, so I have reduced the scene size. I've made everything green. To get back into the flow of things, let's pick a color that's a bit more appropriate, I think, for the background. I don't think we need green light at all. I think that's kind of silly. So I am going to quickly go into GIMP and pick a color that would suit kind of the vibe of the, what is it called, the background a bit better. So yeah, let's do that. So it's a bit of a light orange. Hello Mabdo, how you doing, dude? Just picking a new color. So I think a dark, no, I think it needs to be a bit lighter, right? So HTML, is there a way to, whoops. Yes, I would like to clamp it to 0 to 1. Let's just say we got 100. So, okay, so we just need to divide it by 0. That's fine. Okay, so I'm going to go with a 0.45, something like that, right? If that looks rubbish, then we'll just go with something else. All right, okay, so we just changed it to 0, and we should get rid of the greenness of our light. So it should be quite dark. I hope you're solving that problem that you've got. Okay, so it's very red. So we need to reduce the dark. So make it a little. Let's make it a little less. So yeah, just this is just getting back into the flow a little bit. So let's bring up the. So we got 16, 0.16. There's 0.69, I guess. And whoops, my bad. Excuse me. We have 47. So I decided to bring up the brightness. Looks like inside of gods. Yeah. That's a bit too green. Let me reduce the green, and I think we should be good then. Obviously, this light is way too bright for the actual scene, but I want to at least kind of match the kind of environment. Let me turn that down just a touch. The problem with these playlists is different music is. So I'm going to bring that down to 0.2, and all right. So like one more. Let's see. Okay, so that if I obviously it's way too bright, but that's what we're going to be working on today. All right. So if I disable that, that kind of fits the environment, I think. Right. Kind of, right? Kind of. Everything's specular lit to. I think the specular quality of this lighting source is too much. Anyway, so I was just getting back into the flow of things. Let's just start my timer. Now we've finished that. All right. So like I said, let's dive into the actual mathematics. Looks inside the old gods. Indeed, it almost reminds me of the city of the lost city of Atlantis. Those rocks or something like that. You know, kind of odd looking rocks. Anyway, okay, so we have. Okay, so I'm just going to read this out loud. This is my source notes. So we're just going to go through all the maths again, and then we're probably gonna. I'm gonna find different resources to figure out how attenuation works over lumens and lumosity and all that kind of stuff. So it's a good idea to have lights. It's good to have lights. That doesn't make any sense. It's good to have lights that have coherent lighting units that all follow the same system. You have two different lighting types, direct lights and indirect lighting. Alright, so too many H's in there. Photometric terms, so we have luminous power, lumens, luminous intensity, candel, and candel / LM over SR. So there's things like this that I need to look up, right? What's the SR unit? Things like that I haven't looked up, and I think it's starting to hold me back. Illuminance, E, lux, or I think this is lumens over meters per squared, so that's the inverse square law. So illuminance and luminance. Nit, which is again candel, which I think is this, over. So that's the intensity over meter squared, and this is the power over meter squared. That's the difference. So that's good to remember. So radiance power, which is watts, and luminous efficacy, which is eta, I believe, yes. Which is lumens divided by watts, which is the radiant power. And then the luminous efficiency, which is the percentage. Okay, fantastic. Okay, so illuminance is the total. That's not even how you spell it. Luminous flux incident on a surface per unit area. This is why we measure this with a LM divided by meters squared, because it's per unit area. I see. So it's not distance, it's unit area, of course, because we're interested in the surface area of how it's distributed. Makes sense. Luminance is a measure of the luminance intensity per unit area traveling in a given direction. Okay, that I think that's redundant, but that's fine. That's also why we are doing candel divided by meters squared, which is per unit versus traveled. Right, okay, so is that okay? So we might look into that and change that in a minute. So it's a good idea to make sure that your lights map to real world light units. Here's a table of common lights and the units you should try to use. So yes, we need illuminance for directional lights, and we're only interested in these 3 at the moment. Maybe there's 4. So we got the intensity, which is the, what is that? You got to remember without looking at my notes. So these are the lumens, which is fine, and the candel unit is like how far, the intensity over distance, I think. But again, we're going to look into this. So let's dig into luminance. Yes, so I need to know this. Candela, sorry, I keep saying candel. It's definitely candela. So we're just going to Google that on the internet. So yes, we're not leaving any room for misunderstanding today. So candela CD is a standard unit for luminous intensity. It measures the luminance per unit solid angle emitted in a particular direction. A common wax candle has a luminous intensity of roughly 1 candela. The world's first candela is okay. So we don't. Okay, so what does that mean exactly? It measures the luminous power per unit. So let's just quickly look at what solid angle means, and it's probably not that difficult to understand. In geometry, a solid angle, omega, is the measure of the amount of It's the measure of the amount of the field of view from some particular point that a given object covers. So if we had a candela that we care about a particular point and how well it radiates out from that particular point. Okay, so that's what it means. Let's write that down. Because these are the things I don't quite understand, you see, and if we're measuring in candela units, and I don't understand that it's like a solid angle thing or whatever, we end up in a bad situation overall. As this is very mathematically heavy. If you don't understand stuff in the previous part of maths that builds on, because maths builds up on itself extremely. It's like the most. I don't know if there's any other topic on planet Earth that builds on itself like maths does. Meaning that if you don't understand some basic arithmetic, for example, it's going to be very difficult for you to understand and get through algebra. And this is the same thing with this kind of deal. It never stops. Even if you're in the programming field, sometimes you need maths, some foundational maths, which is okay. Anyway, so this is why we're doing this. So it's a standard unit that cares about the luminous power over a solid angle from a given light source, right? A solid angle can be thought of as a cone where the apex of the cone starts at the light source. And I'll just grab the picture because that's quite important. It's a nice visual representation of a solid angle. Throw this in here. Yo. I need to add more of this music to this. Okay, so I actually shouldn't be editing this. This should be in, because I actually have this already. So just give me a moment. Nope, we have this twice. We need to go back to graphics theory, which is listed here, and I need to copy this into the actual notes, the smaller version, which I believe I have in, nope, lighting theory, nope, where have I put this? Oh, here it will be. Yes, so this for this particular thing I need it in here because I'll often not refer to that in the future. Anyway, so next is, okay, so that's the, so SR, what does SR mean? So I understand why it's luminous over something, but I assume SR is solid angle or something. Yes. Okay, so we at least understand the definition, but I don't understand the unit. So if I see that... right. Okay, so that's what that means. Okay, so... Right, fantastic. Okay, so we have dimensional unit called... Right, so I'm going to grab this just to... I'm not going to copy it. I'm just going to paste it in my notes and then rewrite it. Yeah, this is important. Okay, so the... a solid angle is expressed in a dimensional... Right, fantastic. Because this has been confusing me since day one. Called... Really? Hang on. I thought it was an I. Or a square radiant. Right, okay, so... Right. So this is not what I thought it was. Okay, interesting. Let's keep moving. One thing at a time. Right, I'm going to have to look up the pronunciation of that word, because that's new. But yeah, this is how we're going to do this today. We're going to tackle this extremely thoroughly. So we absolutely know exactly what we're doing for the future, because it's important, like I said, that we get through this, and not only that, that we understand this for the future, for all streams coming, and infinitum, right? So we can't sit here and just assume things. Right. How to say? If there's a solid angle, there's a liquid angle. Yeah, exactly. Oh, that's funny that. They'll one day have an epic fight. So hopefully this has a
Steradian.
Steradian. Okay, so Steradian. Okay, so that's going to be a new word. I'm probably going to mess it up a couple of times, but you know, hopefully you can forgive me on that one. Steradian makes sense. It's radian. Steradian. I like it. And SR unit. Hence the a CD equal to lumens. So frac. So yes, Ratchet, we're going to be looking at your code today, 100%. But today we're going to be trying to dig into this and filling in the gaps that I missed over the spotlight and stuff. Betting on Bose Einstein condensate angle. Oh wow, there's another term. I assume that's some that sounds like some quantum level stuff. That so LM divided by SR for working out the luminous. So it actually makes sense why the power over a solid angle. Why we are measuring in this for a different light, for the photometric light later on. Fantastic. Okay, so do I need to figure out exactly what steradians are? Exactly. Let's just make sure that that's intuitively understood. That's a real state of matter, by the way. Interesting. Okay. So steradian square radian is a unit of a solid angle. Okay, so this is a unit of a solid angle. So get rid of this. If we were to measure solid angles, we would use steradians. Steradians makes sense. Again, a lot of the maths, I never learnt maths in school really, in comparison to what we actually need for this. So it is a three-dimensional, it is used in three-dimensional geometry, and it's an analog for radians, which is a planar angle. Okay, so the solid angle in form, circular cone, where from its center the delineated sphere cap intersects with a sphere. Okay, so I may or may not write that down. So it's like the picture above. I'll just write a quick note to myself. I guess it's like the picture above, where the way I like to think about it is steradians is a sphere, is to a sphere what a radian is to a circle. That's actually a really nice way of putting it. Think about it as steradian. I'm going to write that down instead. Steradian is to a sphere what a radius is to a circle. Fantastic. Okay, so that's going to make a lot more sense. Right, so we got candela units down, I think. Sorry, candela. So we got luminance, which is over. So then luminance, which I'm going to put below, because that is the next level to understand luminance, it is the power distributed over a solid angle, I think. Luminance is a measure of luminance intensity per unit area of light traveled given a certain direction using a solid angle. Oops, angle. That's why it's candela divided by meter squared versus, okay, so over a solid angle. So it's not, okay, that's all I needed to add. Radian, oh, did I write radius? Yes, I did. Yes, that was just my hands typing faster than my brain was thinking. There we go. Okay. Fantastic. Okay, so this is a good idea to make all your lights map to real world. Yes, here's a common table. Okay, so we use illuminance, which is see if I can remember this. This is the power over a unit's meters squared is surface area. What do I call it? I've been calling it something else. Per unit area. Okay. Point light is lumens, and then candela, which is light traveled over a solid angle. Photometric light, which is lumens, and then image-based lighting, which is luminance, which is what we just worked out. So that would be the how much intensity per unit squared over a, wrong way around. So that'd be candela units, which would be the power over a solid angle divided by the light distributed on a per unit area. Nice. And that would be the power. Okay, so fantastic. Let me just grab a bit of water. It's going to be, we've got a heat wave hitting the UK. So it's very important that I hit the water more than I usually do. Otherwise I'll be melting. Anyway, so I hope everyone else in Europe is okay if you're in Europe. I know the heat wave that's been hitting Europe is basically hitting the UK now, so we're a bit behind everyone when it comes to the heat. But Thursday looks like the hottest day. But well, so we got no excuse there. We've got to keep grinding with this stuff. Anyway, so if we want to use watts to work with light brightness, you can use this formula to go from lumens over watts to just lumens. Okay, so that's that, which is just a multiplication of, so lumens over watts times by watts, and then that just gets us back to watts. Oh no, it gets us back to so I'm gonna write this out just so it's super obvious what the heck this all means. I hope you can bear with me just a moment. Which is equal to, I'm going to write this in terms of watts, basically. So this would be watts, and let's see, where is it? Lumens divided by watts. So yeah, like I said today, this is going to be very, like, we're going to be very not slow, but very deliberate. We are not skipping anything. We're not going to try and do this as fast as possible. We're going to do the opposite of what we did yesterday. So I've been using candelas for point and spotlight, and lux for directional light. Looks like it's good. You've got like filament is probably just picking units arbitrarily. I doubt it's got, or arbitrarily. It's probably wrong. It's probably picking. It has probably a good reason, but I doubt other units for measuring lights. It's like, what I'm trying to say is that I don't think this is necessarily the absolute correct way, and I think any light system would work as long as they are physically accurate, so you can get physically based results based on your good units and stuff. Artist likes to use watts for some reason. Okay, that's good to know. I'll write that in, actually. Artists for some reason, like to use watts. Okay, so I was wondering why that's there, because I was like, I'm just going to use lumens. Why would I use watts? But no, okay. Okay, so eta is lumens efficacy of light expressed in lumens per watt. The maximum possible lumens efficacy is 683 times by lumens divided by watts. We can also just use V, also called the luminous. That's not right. So just going to throw that in there. Uncapitalize that. Luminous coefficient, as this is a power using the number of photons per watt. Interesting. Okay. Yeah, Blender does watts as input to. Ah, okay. So that's probably why they use it then. If their tools are using watts, then they get familiar with it. Never mind. Okay, so final thing. Look online to learn specific lighting lumens efficacy or luminous efficiency if you're trying to use a coherent lighting system. What reasoning model is your brain based on, mate? Reasoning model. Maybe a really scuffed version of the scientific method, I guess, would be my reasoning model. Where I try to at least challenge my assumptions and not just dive into problems. I do have this issue where I kind of dive into the problems and I end up going down garden paths, as this saying goes. So anyway, but the artist in my renderer. So I use actual units without any conversion. Yes, that makes a lot of sense. I'm gonna if what I use what GLTF does, which is lux divided by candela, because why not? Interesting. What is that? So that would be the luminous. Let me look at my units again. Try and just try to remember these correctly. So, oops. Oh, I actually do need to finish that. That's important. So I'm gonna leave that there. Let's bring up graphics theory again, and so that would be candela. So, oh, I see. So, right, lux or candela, not the. I was like, what the heck's that unit? Okay, that makes sense. Okay, great. I was gonna say that's a really interesting lighting unit. Yeah, thanks for clearing that up. Measuring basics. Okay, one advantage of using physical light is that we have the ability to validate our equations. When we are talking about measuring luminous, we are measuring candela per units squared, which intersects on a plane with a stridian. Okay, this all makes a lot more sense now, which is an angle in 3D. So what I'm going to do here is link, and instead of that, we're going to use link a pair. I shouldn't have closed that. We lighting units or something. Units. If I type in units, hopefully it'll come up. If I can spell it. Units? No? Light? Oh, for goodness sake. Okay. One thing. Just bear with me while I grab what I need in lighting. Yeah, light units. Why didn't I see. Light units, not units. Fair enough. Fantastic. Okay. Get rid of this. Get rid of this. Of 5 degrees in this picture. Okay, so right. So candela divided by meter squared, which which is the intensity of. Sorry, I'm gonna have to go through this a couple of times. So I hope you can bear with me. Candela, which that would be the light that comes out of a stridian, and we are interested in how the power gets distributed over a surface area, which would be per unit squared, right? Yeah. Yeah, I don't know what that would mean. Yeah, that would be stridient, yeah, divided by unit per surface area. That would be nothing to do with light. I have no idea if that's even remotely useful to anyone, but there we go. Maybe a toy maths question, perhaps. So with this, we can work out the intensity of light when using the inverse of the inverse, square law of light, if we know the difference. What? Distance. Right, fantastic. This might not be as important as just matching the real light to get nice accurate lighting. Real world lights. That makes sense. Okay. Direct lighting. Let's get rid of that H because I keep, for some reason, typing heighting. So there we go. Even if we have measured carefully all the lighting units, you still need to be able to convert. You still need to be able to convert things to make sense for different light equations. Okay, when we are computing lighting, say direct lighting, because this is true for direct lighting. We are computing the luminance value in our shaders for any given point. Yep. Say pixel. Nah, point's fine because it's 3D at that point. The luminous. The lumens. Yeah, lumens. You can see there's a lot of this rushing going on here. The lumens depend on illuminance E, and the, right, I'm going to say the final light. The final light of that point depends on the illuminance and the BRDF/BSDF, which is what that is. Okay, fantastic. Okay, so that makes sense. I think what I'm also going to do as well is tile these notes together as well, so they're all connected. So I fully get all my knowledge working. Okay, so directional lights. The point of directional lights is to simulate the environment, outdoors. Simulate the environment outdoors, like outdoors, I think, from the sun and the moon. So light source far, so light source lights. So light source slash far, from far away. No, how about this? If a light source is far enough away and bright enough to turn the light basically turns into into a directional light where the light rays are parallel. Fantastic. Okay. It's a good idea to use lux, which again, I'm just going to make sure I understand this exactly. Lux is illuminance, which is, okay, so yeah, lumens per unit squared. Fantastic. Okay. Going to leave that open for reference. Because it's easy to get, the reason we do this is because it's easy to get values online yourself, okay? This also simplifies the luminance equation in direct lighting, for direct lighting. Right, fantastic. Okay, so in this simplified equation, E, I'm not sure what that means. How to read it. I'm going to say E bottom is the illuminance of the light source for a surface perpendicular to said light source. Right, so say illuminance of the light source perpendicular to the light source. If this is simulating the sun, E bottom is the illuminance of the sun for the surface perpendicular to the sun. Alright, so here's a reference. So for reference, this table displays things in illuminance, units, don't need to say light, units lux, for a clear day in March, California. Alright, some values there. Okay, so directional lights are particularly cheap to evaluate at runtime. So we just take the direction, which is, yeah, we just reverse the vector. So the lighting calculation makes sense when we do an n.l, clamp that to 0 and 1, and then we just get the direction, and then once we've got the illuminance, which is the lux value, then we multiply that by the BRDF, and then we get something out. Lovely. We already know this. This is quite basic. The next couple, the reason I went too slow again is just to make sure that that is drilled in my brain without any issue. And now, where we started to struggle, which is all this stuff, should now come easier. So punctual lights, spot and punctual lights don't follow the inverse square law and can be infinitesimally small. If we care about performance, it's good to use infinitesimally small punctual lights when possible. Although I feel like recently that's not as true as it used to be, especially not on Android. I was reading a book, for example, which was using image-based lighting techniques that was basically building a ray tracer for mapping between different probes, and these probes were stored in a texture for a given scene, and somehow they were sampling one sample per pixel when they were doing the ray tracing. So it just seems a bit... Okay, this is a bit loud for me. Hopefully it's not too loud for you guys, but all of a sudden realized how loud that was getting. Anyway, regardless, that's not important. Let's keep going. We can solve the first issue by making sure that the inverse square law has the E term in the equation of... Okay, so we need to make sure this is... I see, okay. Makes sense. Using what we expressed, using L out equals BRDF times by illuminance. Using this, we express this idea with this equation, which is the I, again, which is so the candela units divided by distance squared, which would give us, if we end up doing that, luminance. That gives us the luminance value, which is luminance is a measure of the intensity per unit area of light travel. Okay, so that's just the candela units and how much power that gives per surface area. Okay. Okay. N.L. Okay, so the difference between a spotlight, the difference between a point and a spotlight lies in how the illuminance is computed. and in particular how luminance intensity I is computed from the luminous power phi. Okay, so we have two things here. So I think the base equation that we have to deal with. Okay, so when we are looking at the equation above, if you're creating a spotlight meaning when we are looking at the equation above, if you're creating a spotlight, I'm going to say punctual light, punctual lights, the starting point is, so this makes sense as the starting point. This is, I think, the first step of something I didn't understand yesterday, or at least over the past couple of days. I didn't do much on Father's Day, which was yesterday, because it would have been extremely irritating, I think, if I was streaming the whole time for people who were trying to see my dad. But anyway, so this is why I didn't do this yesterday, meaning that we are looking at the equation above. Is the starting point before you begin writing anything else, which is just which I don't think is a unit, is it? We don't have a candela divided by distance squared, which is different. Yeah, I'm going to say write that down as well. Yeah, that is not luminance. That's a mistake I made just then, which is good. I note this value is not. Let's bold that. Not luminance. Luminance, as that would be per meters per unit area, and not distance squared. Right, so that's my future self, to make sure I don't make that mistake. Right, I'm going to throw this in here. L is like a bit of a demonstration to myself. That's what I'm talking about, the L unit. Otherwise, it's going to be potentially a little confusing. Okay, so point lights, fantastic. Yeah, point lights. The point light is defined only by its position in space. Fantastic. Yep. So there's the distance. Position. And here we have, okay, so we have luminance. The luminance power, phi, lumens, of a point light is calculated by integrating the luminance intensity, I, which is the, candela, divided by the steradian, over the light's solid angle. Yes, over the light's solid angle. So, as shown here. Let's break this down a bit. Okay, so phi of the point light is calculated by integrating the lumen over solid angle, as shown here. Okay, so interestingly enough, we have two angles to deal with here. Are we integrating over 2 angles? Is that what it's like when we integrate over Stridian? Right, I'm just going to say, yeah, because that might clear some things up in my maths, because I don't quite understand this as well. Integrate, because this might be like 3D, right? I think I'm correct. Because you know, 2D, like a one-dimensional function, two-dimensional function, three-dimensional functions. Right. Steradian. So, I would need like a toy example here. Is there a way to a solid angle, orientated surface S of subtended at point P is equal to the solid angle of the projection of the surface S to a unit sphere P, which can be integrated with the surface integral. So let's just look at this. Surface integral. So double integral, because we're doing over a... So yes, that's the fundamental theorem of calculus. It can be thought of as a double integral. Right, okay, so an line integral is just this one-dimensional version. Which I assume is... Right, okay, fantastic. This seems to be just getting back to yeah, so it's seeing this is applications in like what is it? Blah, 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 like a vector field or something. But I don't think it's that important that we dive into vector calculus for a bit. Okay, so what basically all I needed to know here is that yes, we need to integrate over both. To integrate properly over Steradian, we basically need double integral, effectively. Yes. That's all I need to care about right now. I don't think it's that important what we're integrating over exactly. So, right, I'm going to make a second paragraph. Kind of split this up. When we are integrating over a Steradian, yes, bear with me on that word. Steradian. It's a double integral because of the third dimension ality of Steradians even. Alright, we can simply derive, oops, I just spell that word again, derive. Again, nothing is being led to ambiguity today. Yes, okay, so simply derive the value over a set Steradian and use that instead. Right, fantastic. Okay, so instead of doing an integration. Fantastic. Okay. So in this case, the I, which is the luminous intensity, which is LM divided by surface area of the thingy, is phi divided by 4 pi. Remember, we are trying to add lighting to our BRDF by multiplying the luminous intensity, which is, I believe, luminous intensity is not the same, which is that right? Hang on. I thought it was E. Or E is what we get out. Hang on. No, E is what we get out. Okay, so divided by distance squared d distance squared. Right, fantastic. So with that in mind, and I'm just going to throw in the soon-to-be note punctual lights here. Yes, this doesn't link to anything at the moment, but it will do in the future. So with that in mind, actually I might grab all of this, throw in a bar. No, I don't know how well this is going to work, but hopefully we can have LaTeX in here that's clickable. No. I will therefore remove that, which is quite straightforward. That's fine. Put that there. So luminous intensity divided by distance squared space. So that's good to know about LaTeX. So with that in mind, we and we threw in our lighting equation, throwing in our lighting equation plus the BRDF plus the direction, we get this. Okay, so basically we have illuminance. What is the equation? Luminance. Interesting. So what I don't quite understand is why isn't it illuminance times by lumens? Do they cancel out? Let me just do a bit of maths here. Okay, so if we throw in so this is just to add some scraps. So frac LM and then SR C dot backslash, come on. We have, so that's luminous intensity by lumens, which would be LM. So that would be frac, again, just very simple. So 1 over, this would be 1. So I assume that would be equal to LM, so frac LM squared, as far as I'm aware, to SR. Right, so that's what I'm thinking the equation should be in what we just did earlier. So let's just take this and just kind of throw it in here, which is important to get right. So when we're doing this, we have lumens, which is for pi. Hang on. This might be... hang on. Let's convert... lighting units again. What I'm trying to do here is figure out exactly the... How does the algebra work? Because I'm going to have to write this algebra in a minute in GLSL, so I really need to understand this. So we have luminous intensity, which is... candela. And every punctual light effectively has this equation to it, which is luminous intensity divided by pi. Now, if I say that the luminous intensity is instead of hang on, I think I know what's going on here. So if the luminous intensity of a spotlight is I over 4, this would be a right, so I'm just going to write this in like another fraction, so bear with me here. This would be 1, right? And then can I write another fraction here, like frac? Okay, cool. No, I need this to be... Hang on, let me just pull this out. 1. There we go. 1, and then this would be another fraction. I'm trying to... It's kind of awkward to write it out, but... so this would be phi. 4 pi. Sorry about the tiny little font here, but hopefully you can see what I'm trying to do here. I'm just trying to really simplify this equation down. By just being extremely explicit. So then this would equal... No, I don't think that's right. Let me try in Paint. This might be easier to do in Paint. Just bear with me. Okay, so we have... yeah, I think it's going to be easier to do. So we have I is equal to phi over 4 pi, right? Oops. And we're trying to work out the luminous intensity for... and we have this formula here where we have F with R... sorry, not R. Visible slash L, which would be the BRDF, times by 1 phi over distance squared. I think I get it now. I think I get it. Multiplied by V dots. I think I understand this a bit better. L. So yeah, these are vectors. Like that, right? So, when we work out the luminance, it's not like... we are taking this formula and multiply it. So we're not doing this, as far as I can tell. We're not doing distance squared x, you know, multiply, I guess, times, you know, standard multiplication by phi divided by 4 pi. We just need to add in the distance squared into our BRDF function. So this just converts. So that's not right. So I'm going to say... I don't know, let's just put a, no, okay, so like a line through it, right? What we're actually trying to do here is just say that This is the formula that we need to work out. Every single thing needs to be this. So this, using this and this, I guess, this would become a, so F, V, comma, L, these are vectors. And instead of doing this, this is the luminous, right? So this would be lumens, line, through, and then divided by 4 pi. And because we need this distance squared, because this is how the formula needs to look, we throw this at the bottom. We don't do any multiplication here. We're not trying to multiply phi by, lumens by luminance intensity. That would not work. And then again, we just do V dot L. I think it's V dot L. It might be N dot L, actually. But anyway, this is the unimportant part anyway of the equation. We don't actually need this. Is it V dot L? Or is it N dot L? It is N dot L, so that would be the normal, not. So, normal, hang on. Let's write a different color, so it's like normal, and this would be normal, right? Kind of looks like a weird, you get the idea, right? So that's how this works. We take this and we stick it here. We don't multiply anything together. So when we actually work out the when we work out the luminous intensity, we actually just put the distance squared at the bottom, and that's how we do it. Cool. Fantastic. Let's write that down. So we're not doing any of this. Okay. So. Come on. How this works is that we aren't multiplying frac frac, so I what is it, d squared, so it'd be d squared by, excuse me, I've got a hair in my keyboard, slash frac frac so this would be phi divided by 4 pi, like that. We need to add the we are saying that the formula, or equation, I guess, equation in we are saying that the equation needs to follow the pattern of this fella. Just going to throw this in here. So when we work out the illuminance, I think, is it illuminance? No, luminance intensity. We are just missing the distance. Let's just grab that. Let's make it not a big one. Let's make it a small one. Luminous intensity. We were just missing adding the distance to the equation. Right. Okay. As this needs to be 1, and I think if I was to multiply the distance, 1 over distance, That would make sense. Yeah, because that'd be, yeah, 1 over distance, I think. But anyway, I think that's good. I'm just going to hit the loo real quick. I hope you guys are enjoying me really dig into this a little deeper than I did last time, to fill in the gaps of my understanding. Feel free to correct me, by the way, if you're seeing like I'm making a math mistake or something's a misunderstanding. Always welcome. But I understand that sometimes this isn't the most accessible for people who aren't that interested in doing lighting themselves. So feel free to just chill and enjoy. Your job in stream, most importantly, is to have fun in any way that as long as you're following the rules, that's the most important thing. So anyway, yeah, I'll head to the loo and I'll be right back. All right. Let me just pause the timer. So we've been at that for an hour. And I think we've covered a lot of ground in our understanding, which is great. Anyway, right, see you in a minute. I'm back. Next, I think the biggest issue is going to be really understanding attenuation over a... You know what might be worth doing is like actually implementing a spotlight from first principles, perhaps? I mean, a point light. If we understand that that is what we actually need to do. Because I've seen my code, right? Let's look at my code for a bit. I've seen my spotlight code in my old shader. Let's just see how this works in GLSL, because it would be nice to have the some application, some way working it, some theory basically, what am I trying to say? The opposite of theory, right? Excuse me, you know what I mean? Anti-theory. Some of the procedure of how this knowledge works. I'll go with that. Alright, so, yes. So it looks like we multiplied light intensity first. So yeah, this is the actual way of doing this. And if you look at the mass is actually much simpler. It's, just make sure it's d squared divided by phi, which is 4 pi, right? But when we look at this, it's like... Okay, so we have light range here, which I assume is how big the sphere is, which is, 4 to the power of whatever the light range is, minus 1, take the minimum value of these two, and then take the maximum of that, so it could be 0 here, and then divide it by the power squared, distance squared, which really shouldn't be I believe distance is a GLSL function. And obviously the distance is quite straightforward, which is just the light source minus the position. So that's the world position in this case. So my confusion here is largely there's two things. I don't understand the mass as well, which I do now. But also, how do we get to this from something like that, right? So I believe we do n.l later on. Yep, n.l. We have intensity, which is just so we just do the multiplication in the different order. You can think of this as BRDF. It's not quite BRDF, but it's more or less the same. But this max min 1 minus light range, all this kind of thing, is kind of like Right, okay. It does make a spotlight when I do this, I think, if I throw this into my new shader. Let's just throw it in and just see how well this works. So there's a lot of stuff here I might not end up using. Okay, so let's just say this is the spotlight code. This needs to be deleted if I'm not going to use it. This is the directional light. So directional light. I might write these in functions actually. That's probably wiser. Spider-Man lifts. I remember seeing you in a comment section. Like, I know this guy. I haven't seen you much, but you seem to be a nice, motivated British lad. Oh, thanks, Dad. Dad. What am I saying, Dad? Apologies. That's like calling the teacher mum, right? Oh dear. Yeah, no, I appreciate that, dude. I meant to say dude. Yeah, there we go. First time I've been spotted in the comment section. I have to be careful what I write, I guess. Yeah, I am pretty motivated. I think my general, what is it called? Feel when it comes to this kind of stuff is I need to be working really hard at this type of thing, just because because I'm doing things myself. It's going to require a lot of effort to get anywhere, and if I don't push myself, which doesn't have to be very hard, I don't have to be like super gung-ho about it, right? But if I don't decide to work hard at this, then you know things are going to go wrong, and I'll never get anything done effectively. So you know, I very much appreciate that type of comment. That's the reason I'm saying that is because I typically stream from 8 or 9 o'clock a.m. to 5 p.m., which is just a normal working day for most people. So, but yeah, that's my whole thing at the moment. Trying to work as hard as the regular people, and you know, on every day, including the weekends. But it's not always the case. I can do that. Anyway, so directional lights. This is quite straightforward. I think I've already written this down, so I'm just going to copy the code. Fantastic. Right, get this light direction. So I'm probably going to pass into a function, and let's see. Throw this in here, and we don't want the. What do we want here? We want to return the illuminance, which is completely chill. We don't want any of this. That's that, and return this. Oops. This is so we can just use this light later on. Maybe we won't have this function in the end, but it's good to just have it here so we don't have a bunch of commented out code, and just end up deleting it and breaking it basically. Oops. Vec3 light direction. So here we go, light direction. So that should be the. So we need nl.l. I'm going to pass in the clamped version. So float nol. And that should be everything that we care about. So if we're doing that, then it's the. We need to do n.l with the. Alright, so it looks like we're going to have to unfortunately pass in the normal and the normal vector, which is fine for the surface. Vec3 normal, and I will use that instead of n. It doesn't really matter, but yes, so it's the directional lights. We need the direction and the normal, and we should have a decent function. Let's put this like that. In fact, we don't need this assignment. We can just do a direct return. I don't know if this is. Okay, so I need to change the music. It's repeating itself. I'll do that momentarily. Okay, cool. Let's pick another track. Nothing in particular. Let's pick Nature's Crescendo because it's hot. And summary. Oops, I didn't restart the timer. This is more dev than study. Okay, why has it gone quiet? Right, fantastic. How's the game looking? Yeah, it's getting there. Well, getting there when I say that. We're just adding more lights in. At the moment, it's... I wonder if I can show you anything yet. Let's just see. I'll just run it and you can show me. Give me a preview of the game. Yeah, we'll do. Let me give me a moment, and I will try and fix my shader up because I'm in the middle of. Cannot normalize. What do you mean? Is this normalize instead of normalized? Right? Yes. Okay. I don't know why that's written. Yeah. Just I'll bear with me while I'm Why don't you vibe code, bro? Because I love coding too much, and I'd prefer to just do that myself. So light intensity, light intensity, and yeah, that's pretty much it. I've been coding since way before AI existed, and I would like to keep doing that in that way. Okay, so I can't guarantee that this is going to look very good, but I can at least show you what we're trying to do. Okay, so this is my game engine, and what we're trying to do at the moment, the reason that everything's so cramped, we have a little space game, and the asteroids are all close together, so I'm trying to test the lighting at the moment. As you can probably tell, this is probably not what space is supposed to look like when it comes to lighting. But yes, I'm slowly breaking down things. I'm trying to work with metals at the moment. That's why everything was kind of strange. So yeah, we have a broken... spotlight, which is something that comes out of a flashlight / torch if you're from the UK. So yes, I'm just trying to get this scene to look a little nicer. I'll eventually spread these back out. I've made the radius of where these can spawn really small so I can see the lighting. So the otherwise it's possible that the light that I'm pointing something at doesn't hit any of these asteroids. So yeah, that's what we're doing at the moment. It's currently in a very dev state, so I apologize for the lack of but if you use your imagination, you can imagine, you know, flying around, you know, let's just zoom out from the box, you know, you can fly around. Again, I'll fix the lighting so it doesn't look like everything's made of gold. Yeah, so that's what we're up to. Hopefully that's cool. But right now we're trying to understand lighting theory a bit better so we can actually fix these type of things in the future without having to consult the internet so aggressively. Right, so let's add a point light function. To remove the so we've removed the comments note code, and I want a point light function so we can use that in the future, which would be nice. Same deal as that. So yes, that's going to return the light intensity. That's the goal. The n.l, maybe I shouldn't. Hang on, let me just look at this for a bit longer. How do I do this? Okay, so let's turn that down. I feel like that song was really quiet, and now this is really loud. Okay, so cool. How long have you been coding? And I've been coding on and off since 2011, so that's a long time ago. But I really took it seriously in 2017, and I really took it seriously a bit later on from that, where I gave up all my hobbies just to get better at programming. So if you're worrying about, you know, if you want to start yourself and you're thinking, well, that sounds like a long time and it sounds like impossible to get good. No, you can get good a lot faster than I have, if you consider my level good at least. So yeah, don't sweat it. You can definitely crush it yourself. And what are your big projects? I've made a Minecraft clone, I guess. That would be a big project. A couple of other game engines that have made very small tech demos. One, I built a physics engine. That was a good one. It could only handle some convex geometry, but it was able to use you know, the separating axis theorem to deal with collision detection. And yeah, that's generally my biggest projects. This is my other big project, I guess. But I'm just trying to make this look pretty, so it's, you know, something you might be interested in playing in the future. Effectively, it's not going to be a big game. It's going to be quite arcadey at the very least, and maybe very simple. But you know, I can at least make it pretty, right? Because I have control over the graphics. So let's make the. I know gameplay is better than graphics, but you know, this is just mostly a demonstration that I can actually make a game in my own with my own technology, more than this is my magnum opus type of finishing project, right? So that's what we're on this anyway. So yeah, that's why we're studying the lighting theory, to try and get that effect in place. So we have some code here that works out a point light, and I'm going to rob this. I think I'm going to take all this, actually. Let's just take all this and throw this into a function, so we can use this for a point light, which is just a light where it radiates. The light radiates from one point. So point light, and I'm going to break this down a little bit once I've returned a value for the intensity. Obviously, I'm not going to have these in here. These are going to be passed in as variables. So we have a very wide radius and a very wide. So I think if I want to have this, I at least want range. So light range, sure, doesn't really matter. These can be variables because we can pass them in and get different sizes of lights and light intensity. Intensity. Let's go. Right, so we can get rid of these two. So distance might be worth throwing in distance as well. It's going to be quite a large function. So let's get rid of that. Because the distance might be different depending on... maybe not. Maybe not. I don't know. Yeah, because this distance is guaranteed basically to be wherever I decide the light position is. So this is an input variable from the shader that comes from the CPU. And this is the global position. Alright, I don't think it matters too much. Let's break up this thing a bit because it's a bit confusing. So we have light intensity. So yes, I'm going to break this up a little bit. So distance squared. It's not as elegant as people like to you know, distance squared, but I kind of like the visibility that this allows. So distance squared now, and do that. All right, so that's that done. I want to this power. I see. Okay, so this note this. Remember that a point light is defined only by its position in space. So this is why there's nothing else going on. So its power, so its light range is, so what I want to do here is take this out to make another variable, and let's see, what would this be? This would be the float light power, I think. This would be the lumens. Throw that in. So depending on the light lumens, it's either 1 or 0. So 1 is the lowest you can get. Oh no, it picks the minimum. Interesting. Light range. Huh. Do you think with AI it's worth getting into programming, like seriously? And what are the job opportunities? Right. Okay. So that's a decent question. It depends on what you're interested in when it comes to programming. The field of game development is probably the least. It's always been tough to get into. It's always the one that's underpaid. Typically, when it comes to other programming fields, there's a lot of jobs that people overlook when it comes to programming. When it comes to like applications, like I was offered a job a while ago where I was going to help people with archiving historical documents, and I was going to be writing software that would do that. So there's a lot of like fields that you've never heard of that require software engineers or C++ stuff, which is what I do. So you need to consider that. If you're interested, that's like where a lot of the job opportunities are in general. I would say as well, the best paid jobs are working in quants. So being a quantitative programmer in the financial stuff. So if you really want to pursue something that makes a lot of money, pursuing something like C++ and getting really good at that for quant and learning how quant trading games work, that is like a good path. The problem with all these though is they require a long time if you're starting from scratch and to get good. And it depends on one, where you live, and two, how much time you have to like get good at this stuff. You can definitely become a programmer, and I don't personally buy into the hype around AI that is coming from the CEOs that are trying to sell AI. You've got to remember that anything that the AI companies tell you is coming from a salesman's mouth, right? They are trying to get you to use AI because that's how the companies are making money. They're all losing money right now, so they're absolutely desperate to tell you that artificial intelligence and AI and AGI is 2 months down the road and coding is completely finished and no one needs to code anymore. Why they say that? You got to remember they're completely biased because they need to sell a product, and a lot of that is selling a product, a potential product to investors. They're talking to VCs and stuff like that. So I think engineering is you can get into it, but it is, unfortunately, AI has affected the CEOs more than anything. They believe that they can cut costs, and I think there's going to be a bit of a backlash when it comes to this type of stuff in the future. So I would ask yourself these questions, like what field do I want to get into? What am I really interested in? How much money am I in? How much time do I have? Is this something I want to do for money versus for the love of the game type stuff? So I wouldn't pick game development, for example, if you want to get into programming for money, and go from there. Hopefully that's some general advice that I can give. Did you do university and it pays well? But I'm not saying I'm starting from scratch. I'm a student at my final year of uni, and I will take a gap year to earn some money. I'm in Italy, so the opportunities should be there. Yes, sorry, excuse my ignorance, but a lot of the big Rome, isn't it? Rome is the capital, right? So you might end up having to move as well. That's the other thing when it comes to, like, for example, if I want to work in a quant job to earn 6 figures, I would need to move to London, for example. So if you're like pursuing money over everything, you might end up having to move. But yeah, it like I said, you need to make sure though that you can code without AI when it comes to getting paid, because the difficult jobs that exist out there require expertise, and for example, the AI can't do what I'm doing very well here, and I think that's true for like quant, for example. It's very sensitive to mistakes, and if you make a mistake, you could lose millions in seconds, right? Because the trading algorithm that you pushed to a server is all wrong, and that's happened before, by the way. Where I think it was like a company lost. There's a video on it, but basically there was a a server broke quietly in the background, and then that pushed an update to everything. Once someone rewrote some code, and that then the algorithm started buying and selling stocks all incorrectly, and it started to lose money like extremely fast. So you can't vibe code that kind of stuff because it's too sensitive to mistakes. So that requires you to be good as a programmer, and a lot of people don't want to do that. So if you want to do that, you'll start to be ahead of the pack just by the fact that you want to get good. So that's my general advice. It's again, it's all situational and based on you as an individual. So yeah, good luck with your good luck with. Oh, okay, yeah, I'll finish. I'll just pause this one moment while I keep talking about this particular thing. Yeah, that's my problem. I need to revise the basics again. I'm at my final year of college with like 13 classes, not in uni. I don't know. I really used AI too much during my last 2 years, and like did my assignments like that. I see. That's a big problem, unfortunately. Yeah. I don't know what language you're good at, but just take it one step at a time. And what I've done, this is personal. You don't have to follow what I've done, right? If you are missing knowledge, I think there's two things that you need to worry about. Conceptual knowledge, which is like the theory, which is all this math stuff here, and the procedural knowledge, which is how the procedure works, how you type it up, right? This is the actual code. A lot of the time, people skip ahead and try to get to the procedures before they understand the conceptual knowledge. Okay, that was just a crazy sandwich right there. Jump scare sandwich. That was my Windows noise, not you. So what I would do personally is do something like, if you're learning C++, I don't know any good platforms apart from that, so I'm just going to take you to this, for example. If you need to revise the basics, like if you go through this is like a textbook in C++. You can go through, and how I would go about it is I would personally use a note-taking app that allows you to do something like I've done, right? So if I take you to an index here, and this is my graphics theory knowledge, this is my Vulkan knowledge, right? And what I've done here is allowed, so if I click on a small note, it's like, what is the swap chain? I have this really small summary of what this is, but I also have connections to other notes, and this is my conceptual understanding of what a swap chain is. So I go from this, and I have some procedure stuff in here, like how my procedure is. So I would start with conceptual knowledge and build up your bank of knowledge so it looks something like this. This is what your brain would look like if you had expertise. You will have some expertise, but it's a building of network of knowledge over time, and this is like what my expertise is effectively. And then I can go into this and then kind of jump around. What is sampling? Anisotropic filtering versus repeat, mirror, clamp to edge, and border when it comes to building a sampler in Vulkan. And then I can go like how to create a sampler, right? So I would do that in Learn C++, and don't avoid AI. The transition of the knowledge from a website into your own notes is the learning process. So the struggle, you'll see me struggle on stream, is the learning process. So this is why I'm like learning this and struggling and not rushing. And then it would be like, okay, after that, then it would be like, okay, pick a project, and then that would be the application and turning the conceptual knowledge into a procedural knowledge. And I don't know what that would be for you specifically, but yeah, it would be picking something that's relevant for the field that you want to enter. So again, that's just what I do. You don't have to follow it, but that's what I would do personally if I was in your shoes, regardless of how behind I am relative to my peers. This is the only way to get good in any field is to practice, and I believe that is a good way of practicing. Conceptual knowledge, then procedural knowledge with a project. This app is called Obsidian. It's free. If you want to sync it between different computers, you need to have your own way of doing that. So you can put it on a Google Drive or a OneDrive, or I use Git. And yes, this is the like free note-taking app. The method I use is a second brain Zettelkasten. There is like a tutorial about how to do it my specific way, but if you just have notes that connect to each other, that builds up like basically what we saw earlier. This what is it? What is it called? graph, right, then it doesn't matter how you go about it. I just have an index and source nodes that then have small nodes attached to them. This is like a big one that goes on and on and on. And I made little versions of that that attach to it. So like, let's see, like this one, for example. It connects to this big guy, but it also connects to other small nodes as well. Yeah, so that's what I do. Again, this is just a way of studying. You don't have to study this way. But yes, again, you can do this without... there is hope for you outside of AI. Anyway, speaking of sampling textures, did you read the MIP section blog post I sent a while back? Oh, I actually don't know. Let's look at my is it Vulkan related? I don't remember. So if I go to my sampling, sample, okay, what are samplers? Create sampler, combined image sampler. So a lot of this is from the Vulkan tutorial from 2016. But what did I yap about this later on? No, I don't think I have. I have MIP maps, but maybe... yeah, I don't know, actually. Yeah, feel free to... it's graphics in general. I don't remember. Let me see my source notes. Hang on. It would have been an article. Vulkan synchronized... Texture mapping, no. Graphics, learn CBP, iterate is hard. Yeah, and anyone can learn this, by the way. I don't think this is like inaccessible knowledge. You just have to work hard. No, I don't think I have. I'll send it again. It's very interesting. It's very interesting. Yeah, please do. I see you've posted something in resource. Let's have a look. No, I definitely haven't gone through this. No, this will be useful to know. And at some point in time. Yes. So what I would do here, just to demonstrate again, I would type up my own version of these notes, break them, simplify them down in this, and then I would break them down again into little tiny snippets like this, because I'm not going to read a massive 4,000 words note to myself, right? I'm going to more likely read, something that's 436 words. So yes, I will, I'll bookmark this. And I'll be constantly reminded of this as it sits in my bar of things. Anyway, yeah, hopefully that helps you out. I wish you the best. And like I said, anyone can learn this stuff. So good luck on your journey to becoming cracked, my guy. And I will continue my own journey and try and write the spotlight code. Point light code, even. Alright, so I don't think this is lumens. Let me think. I think this might be... so this is light intensity divided by light intensity. What is this? This is super confusing. Let's throw in... So there's a lot of algebra that's kind of done ahead of me, if that makes sense. So what is this? This value comes out with something. So what I'm doing at the moment, Ratchet, if you were away for a minute, I'm just kind of like writing point light, directional light, and spotlight functions that return the light back to us. But I think this might be... so this is so I don't end up having a bunch of commented out code, but I'm also trying to make it make sense in my head. When it comes to the maths, going from the maths to the GLSO code, shader code. Alright. So spotlights I've done before, so it shouldn't be too difficult to work this out. So the sorry, point lights even. So it looks so easy here. So lumens divided by 4 pi distance squared. What have I got here? I've got some madness going on. So we have range, which is divided by distance, and that, we bring that to the power of 4. And then we subtract, that's subtracted from 1. So eventually this will always be 0. I don't think it's lumens. What is this? I'm gonna say so distance divided by range, I guess. Distance over range, but I don't exactly know what that represents in our function. So it's not lumens. So at the very least it's 1 always. We subtract this, so that this must be a really small value most of the time. Oh, my bad. That's not right. Get rid of this. There we go. Okay. And then we choose the biggest value divided by distance squared times by light intensity. So light intensity is lumens. Okay. Let's write that in. That's 100% lumens. Because that's actually literally what the definition of it. Light intensity. Whoops. Fantastic. Okay, so I feel like you're assigning units to things that are unitless. Maybe. But I think at least we got that right? Because that's the intensity, which is the power, divided by distance squared. So that will be... So this is the... According to the math, this is pi rate. Yeah, 4 pi... So, distance range, let me think. Vulkan hurts my peanut brain, not gonna lie. Setting a OpenGL renderer was hard enough for me, lol. Just a gamer tag. Welcome, by the way. Yeah, it's Vulkan's fun, but it is tough. It's an explicit API, so you have to use explicit language when you're using it. You know, lots of swear words, lots of cursing, and then you'll be okay. I feel like what I've got here is like a super not optimized, but like the algebra must be moved around all over the place or something. So that's the intensity. So I'm just gonna write. Maybe it was a bad idea to remove that. No, this is just the. No, we already know this, right? Alright, so let's just see if this works. So we want these 3. So this is going to be quite straightforward. It takes time to get used to. Yeah, that's pretty much it. The learning curve is steeper than OpenGL, for sure. But if my dumb brain can understand some Vulkan stuff, then I definitely think anyone can do it with enough practice. Vulkan 1.3. I know OpenGL is fine, by the way. I'm not trying to convert you to OpenGL. Sorry, to Vulkan. But Vulkan 1.3 is a lot nicer than Vulkan 1.0 when it comes to actually getting things to work. So its range is, let's just make it a small range, so like 10. It's lumens. Again, I probably won't want to do this, but lumens is... I'm going to have a high intensity, so maybe 150, based on that range is quite small. And then, yes, we're just going to take in light. Hang on. What am I doing? I'm trying to go all the way up to my this thing. Yeah, I need like a separate header. I think my shade is getting a bit cramped. Dot scene data dot light, and then minus a view position. Now I think view position is a vec4. I'm not exactly sure about you though as well. So let's see. You're a vec4, and we want a vec3. And what are you? Are you vec4? No, what? Oh, I spelled position wrong. Yeah, okay, so I just need this. That's chill. Let's grab this. Right, and then we get the intensity. So this would be power. Luminous power. Alright, cool. Throw that in there. Let's just see how this works. So we should have a point light. Okay. Oh, is it? Interesting. Float, float. Oh. Yeah. That needs to be back 3 to do anything. I think. Hang on. That would be the distance. No, that's not gonna... None of that makes any sense now. Yeah, right, give me a minute. I am, though. You will use Vulkan or John Kronos will get you. Yeah, Ratchet's gonna make sure that you use it. That's it. Yeah, watch out for John Kronos. He turns up when you least expect it. Makes you answer validation errors. Or he gets you. Oh, it's a length. Idiot, idiot, idiot. So yeah, turn this to a float. This was a float. Yeah, distance is a float. I mean, I could, it doesn't really matter. I don't know what the interface of this is going to be yet. I haven't really decided on it. But that should be it. No. Let's see. Nope, not there, please. N.L. And you've commented out that, apparently. No, I'm going to say NOL. I think that's going to be more appropriate for us. I think I've got NOL here. Yes. Okay. This is why I'm separating out functions, because it's getting a bit scruffy. And that looks good. It's very small though. So, oops. So I am. Oh, okay. I forgot. I am the point light. So, yeah. It's really small. Can increase the range by a lot. Let's see. Range. Let's, instead of 10, whatever that was. Let's go with 100, and I want the intensity a lot higher. Okay, so yeah. So this is a small point light. I think the intensity is still really small. Or the range, sorry. Let's increase the range again by a factor. So it has got a higher range, but okay, the intensities can't be that high. I don't know what the units are in my game engine really when it comes to distance. It's like we're dividing by. Hang on, whoops. Okay, looks like I'm gonna change it to 5,000. Oh, your scene's really big. Yeah. It's either one. I can't quite tell. Okay, we're getting there. It's almost as big as I want. The intensity's still really low. Oops. Let's turn on the intensity one more time. Let's bring this to right 5. It's got to be like 5,000 and 10,000 seems to be enough, right? Yeah. Okay. So that's it. Yeah, that's good enough. That is it. That is a point light as we get really close. Sorry, blinding you that right there. Yeah, that, I mean, that's okay. Still very dark. The angle's wrong though, I think. Ugh. What I'm going to do is just... Give me a minute. Give me a minute. I was messing around with the Fresnel term a little bit. If I just get rid of this for a minute, just to see. Oh, yeah, of course. I always forget that. I just feel like the specular's too high again. But anyway, because it just seems a bit silly that the point light is this big. So if I just add another one. Yeah, so... Alright, so one more. 0, maybe. Nearly 1,000,000 intensity. Yeah, I have a sneaking suspicion that something's wrong here. I think I actually do need this. I think that's the issue. There we go. That's what the issue was. All right. Yeah, I don't know what's going on. All right, that's like super bright as well. All right. Yeah, my lighting direction was all wrong. I might pass that in actually. As right. I've been working on a game as well, but not with a custom game engine. Hell yeah. I hope it's going well. We need more we need more good games in the world. Yeah, I also you're right. I don't have exposure instead. I think at the very least we do have a valid point light function. Now we just need to get the spotlight function working, which is much harder. All right. All right. Okay, right. Right, so spotlights. Good bloom also helps sell light intensity. Brilliant. That's good to know. I don't think that's too difficult. The editor for the game is with a custom UI. It still uses SDL2. Interesting. That should be okay. When it's finished, I like to have fun with Vulkan and rewrite it. But it's hard to justify. I know what you mean. Like I want to write a path tracer at some point in the future, which it's going to be difficult to justify when it comes to this kind of stuff. Anyway, so let's so yeah, I'll get into that ratchet. Thanks for the help with that, like how to sell the scene a bit better. So spotlight. So we do have a point light. So let's like I said, I'm going to be very slow when digging over this code because I need to understand it. So there's some knowledge I'm missing here. Spotlight is defined by a position in space and a direction vector and two cone angles, theta inner and outer. The two angles are defined are used to define the angular fall off of attenuation of the spotlight. So the light equation must take into account both the inverse square law and these two angles to properly evaluate luminance. Luminance. attenuation. Like my performance with SDL2 is already all right. Yeah, you should be fine then. But yeah, I do know what you mean. You kind of want to get better at stuff, and you kind of want to understand it yourself. Okay, so just like the spotlight theory, you can write. Oh, I hadn't done. Sorry, I completely forgot. An implementation of this might of a spotlight point light might look like this. Fantastic. So we've got to type in our code, which we just worked out. Right. Okay. Oh, did I put it in the wrong place? I put it in the wrong place. My bad. Cut. Stick this here. Okay. Since it's just 2D, it's parallax. It's the paradox of wanting to learn versus getting something done. Oh, I can empathize. Truly, with that. Okay, so we did that attenuation fall off, luminance attenuation. Okay, so spotlight theory, you can work with. You can do this without. I'll just read this. I'll just read this properly. Just like with the spotlight theory, you can work this equation out with the theta outer angle of the spotlight cone angle spotlight's cone range in the domain of 0 to pi. Okay, so yeah, this is just a derived function again. Because it's a steradian, we're doing double integrals here, and it looks like we get everything multiplied by again, I'm just gonna have to look. Yeah, I'm gonna say luminous intensity. I just want to make sure it's correct though. Luminous intensity equals this, and that means we need to multiply this, I believe, by distance. So yes, okay, so that would be the distance squared. So I got that right. So in my head, that's correct. Then we just need attenuation based on the attenuation factor of the angles. Which, if you don't know what attenuation is just as light travels, it needs to get weaker and weaker and weaker as it goes out. Hey, are the docs/notes you're currently showing available anywhere? Yes, they are. I will actually, every time someone asks, I usually have to push them. But I recommend making your own notes. I will. There are available. If you are interested. Git status. Where I'm getting these from, by the way, is Filament. If you want to actually read them yourself, I've just converted them into my own words and simplified things for myself. But my notes are on GitHub, if you actually do want to see my personal version. Oops, that's not my GitHub. So if I go to my GitHub, I'm going to Obsidian Notes. This Vertex F Obsidian Notes is my thing. If you do want to download these, you have to download this folder effectively, and then use this program called Obsidian. Point it at Volty, or this Obsidian Notes base folder, and it should then populate a whole list of things that you can look at. So yeah, if you're interested, but yes, if you, like I said, if you want to study what I'm studying exactly, yeah, go to Filament, which is type in Filament, and you'll see all the same maths you see that I've typed up myself for my own notes. But yeah, that should be what you want to do. Oh yes, let me push just to get you most up to date stuff. So Added some more lighting notes. So that should push. So there's a lot more lighting notes, BRDF stuff. So that should go up to the internet, no problem. I do have a question about my tile editor though. I want to add a zoom feature to the canvas. How do I do that and preserve the gaps in the tiles when scaling up to individual tiles? Last time I built a tiler engine was a long time ago. The only way I did that was with what I would do, I don't know if this is going to be relevant to you, but I would use a 3D perspective camera rather than orthographical. Oh no, wait, you can do this in orthographic. It's to do with your camera. If you work with an orthographical projection, I think there's a way of using a zoom factor that changes the projection based on an orthographical projection. So I would look into that. That would zoom in on your whole scene though, not individual tiles necessarily. But I had this ability where you could scroll in and out with the mouse in a 2D game engine that I made a long time ago. But yeah, look into that. Hello, Botred game. Yes, if you want to apply scale to individuals, you need to shift its position. You can multiply. Multiply things by factors and you should be good. We are trying to go through the maths very slowly to understand the spotlight stuff, which I'm about to go back to. So hopefully you guys are okay with me reading. Okay, so we have this function. I kind of understand this a bit better. So this equation. So with this equation, as you decrease the outer cone aperture, the illumination level increases. Okay. To fix this equation, you just have to make power over phi equal the illuminance intensity. This equation can also be considered physically based if the spotlight reflector is replaced with a matte diffuse mask that absorbs light perfectly. Okay. There are two equations. There are two equations, S. One with a light absorber and one with a light reflector. This is the thing. I don't quite get this, but what I'm fine with this for now. Okay, so we have a lambda function which is L.spot direction, which I assume is the same direction as. Oh, what would the direction be? Interesting. Angle. And the spot's attenuation factor. Okay, so the attenuation function. If I had a 3D camera there, still get gaps around the... Oh, rounding error is interesting. And I don't know. Yeah, the way I did my 2D game engine is I did a 3D engine. I did a 3D camera. I locked the Z value to a particular value. My 2D game engine basically was the Hazel game engine, if you're familiar with that. It was just a clone of that. Not very impressive, but it was still useful, I guess. And you lock the Z axis to a particular value, and then you can put things in front or behind. And all I then did was just multiplied that Z value by a factor when I scrolled the mouse. But that again assumes that you have access to the projection matrix or the orthographical matrix. I think there's. I'd have to look at my code for the actual maths, but I believe there is a way of doing that. Yeah. What is this app's name? It's called Obsidian. Feel free to download for free. If you want to sync it between devices, though, you have to find your own way of doing that, or paying Obsidian to do that for you. Outside of that, though, it's free to use. We can't use the standard mathematical equation. This is unfortunately unfortunately impractical implementation. But what am I saying? This is because it's impractical to implement. I think I just need to say that. Yeah, sorry I can't give you more concrete help there, but I don't exactly know. It's been a long time since I worked in 2D, but and made a tiler engine. Anyway, the division by the square distance can lead to division by 0 when the object touches the light source. The influence sphere of each light is infinite, and that is so with this distance is yeah, okay, so yes, okay, so with distance approaching that is asymptotic, it never reaches 0. Okay, yes, so which means that to correctly shade a pixel, we need to evaluate every light in the... What am I saying? Okay, so let me read that again. I feel like I've made a mistake here. These are like little mistakes that add up when you're actually doing this type of stuff. So I am going to get rid of that and this, so I can actually see what I'm doing. So what am I saying here? I'm saying that the influence sphere of each light is infinite. Is infinite. So 1 over d2 is asymptotic. It never reaches 0. Which means that to correctly shade a pixel, we need to evaluate every light in the world. Oh, okay, that was, I just typed it out one-to-one. Okay. Okay, I was a bit confused there. I think we can just keep going. The first issue, I was wondering like how to shade the pixels then. But anyway, this... there you go. Game filed. It seems to know more than I do. So yes, I don't know about individual STL render functions. Anyway, the first issue can be easily solved by making by setting... I wonder what... right. I think I know what this is. Right, I think this is to avoid making the point literally 0, to avoid a division. No, we potentially still get a division by 0. Here, the distance. Let's have a look. I'm kind of curious. If I get as close as I can to a surface. So we're going to see a lot of orange when I do this. Hopefully that's okay. And I can go even slower with controls. So orange. No, I don't think there's an issue. Oops. Obviously, you wouldn't want to see that in a video game, but I don't know. I don't think there's that much of an issue. Sorry, the division by 0 thing. Yeah, if you turn off that, this is what it looks like, I guess. Anyway, no, that's... I thought I was onto something there. I thought this was to stop a division by 0, but this distance over thing just picks between... Yeah, if the numerator of a division is 0, then it just becomes 0, which is fine. But the distance squared is Maybe I should make it so it never divides by 0. So like max, because this technically could go to 0 if the distance is so 0.001 or something, and that'll stop things going, stop a division by 0. I highly doubt it's going to change literally anything, so you know, it's because the CPU, the GPU is a lot less. It doesn't. It just sees data, so I'm just going to go make sure nothing's weird's happening when I actually. Yeah, we're fine. All right, but I think it's still a good idea for numerical precision issues. Sorry for like division by zeros are still not good. That's what I'm trying to say. Let's say yes. We're listening to the music. To not have a division by 0 on the GPU, despite the fact it won't complain. It might silently cause issues. Again, it's just like a. I don't know. I don't know what's going to happen. Okay. So our point light isn't infinitesimally small anymore, which is totally fine based on the distance, because a point light is defined by its position, and that's effectively the position. No, that's effectively the position of the thing, the light, relative to where it is. So anyway, let's keep going. So yeah, that's effectively what I've done here, right? The first issue can be solved by setting, making the assumption that we have a area light of 1 centimeter. The second function, the second issue, we need to introduce an influence radius for each light. This allows us to debug, to use debug spheres to show the influence. We also call we can also call lights S more aggressively using this extra piece of information. We also, in theory, okay. Say we also twice. You can with a influence sphere, you can manually tweak is fine, the radius of the light, which might help out artists. Okay. Mathematically, the illuminance of a light should smoothly reach 0 at the limit defined by the radius. Influence, yes. Okay, so this is the, okay, that makes sense. In this paper, we can take the inverse square and we use a function that allows the light's influence to remain unaffected. Alright, the first issue can be solved easily by setting, we can make the assumption, yeah, okay, so that's fair enough. This is the problem when you're reading and writing and trying to make the sentence make sense. Sorry, the first issue. Can be solved. Yeah, these are my rough notes. By making the assumption Yes, thank you for thank you, game filed. There we go. So at least the first issue can be solved by making the assumption that we have an area light with a small area of 1 centimeter. There we go. Right. So I just multiplied that here. Oh. Is that enough zero? I don't think it's enough zeros. There we go. Okie dokie, on we go. Mathematically, the illuminance of light. Okay, so we've read this. Yes. So in this paper, we take the inverse square function and use a function that allows the light influence to remain unaffected. We have this in the equation where the radius is r. Okay, so this is the okay. So so what I didn't understand at the time, I thought that was the spotlight equation. That's not. That's the influence sphere. So I'm just gonna write this underneath, and because I was rushing yesterday, on Saturday, trying to get this to work. You missed. What did I miss? Oh, in that sentence again. The first issue can be solved by making the assumption that we have an area light with a small centimeter. Okay, let's just read through this. The second issue. Yes, I'm dyslexic, so you'll often find these mistakes. This is not a thing. I don't mind being corrected too much, by the way, unless it distracts me too much. So it's fine. The second issue, and if I don't want to be corrected, I just won't correct it. I won't get mad or anything. You know what I mean? It is what it is. You're allowed to have fun in this chat. The second issue we need to introduce but I'm going to try and correct my English. A influence sphere for each light. I think that's better. This allows us to use an extra debug sphere. We can also cull light more aggressively using this extra piece of information. With an influence sphere, you can manually tweak the radius of the light, which might help our artists. Mathematically, the illuminance of a light should smoothly reach. Oh, in the first, okay. You missed that we. Oh, have I? The first issue. I see. That, yes, I see what you're saying. That we are having. We have, yeah. The first issue that we have can be solved. Yes, okay, thank you. Fantastic. Fantastic. Okay, so note this equation is purely for the spherical sphere of influence. Note this equation is purely for the sphere of influence, and it's nothing to do with a spotlight itself, right? Alright, so that means I need to move this code from here to the spotlight, which is above. So this is the theory of the spotlight and the application of it, but it doesn't quite work, as I just typed this out 1-to-1, and I got a weird result. So, okay. We do have someone in chat called Ratchet helped me out 2 days ago, and they sent me some code. We'll move on. My scuff notes will be fixed later on. Just because I want to get to other things rather than like getting my English 9,000% correct. You're gonna have to forgive my lack of, like I said, dyslexia sometimes gets in the way. But right now I am more interested in working out point lights. I hope you don't mind. Right, so we have like 2 different ways of working out the same thing. So the first thing I need to do is at least grab all this, uncomment it, and take it out. Put this in its own thing. I'd say spotlight, right? Float. Spotlight. Yeah, spotlight. Okay, so what do we want to have passed in? I think in my source note? No. Okay, so we need position to light. I'd love to see this implemented in someone's code base, if you know what I mean. It is a bit confusing, this. So we just care about the... Okay, so we have 2 things here. We want the light intensity, which is calculated where? I mean, this could be just a general variable, maybe. But the attenuation and the light intensity are different. I don't understand that. Let me just go back to the actual original source. Okay, so it basically throws you this right at the end. So light intensity just... So I believe that's the lambda function of the fall off. This is the actual attenuation of that, using that. The evaluate punctual light is... It has 2 variables I don't think exist in here. It has, as far as I can tell, light intensity and attenuation, right? So we have we have attenuation, obviously, but where's this come from? I mean, I could just randomly set a value, but I feel like... Isn't the whole point of working out intensity, which is... Where is it? Let me look through my notes again. So this is the square fall off function, the lambda. And because we multiply these 2 together, which is kind of what we're doing here. And oh, okay, so it looks like light intensity, attenuation. But what's this? Why is this here? Surely the... Okay, so no, both attenuation. Okay, let's look at the other code that I've been sent earlier. So that okay, so we have something that makes sense here. So this isn't my code, these 2 functions here, but we're going to kind of try and work these out backwards. And just see what we actually need here. Right, I'm gonna head to the loo once again. I feel like I drank a cup of tea and I feel like I didn't need to, and now I'm paying for it. So yeah, bear with me just for a moment. That's BRB, not CRC. Hopefully I didn't say a slur by accident right there. Alright, I will leave you guys just here with my excellent streamer setup of BRB. Just make sure this is paused as well. This is important. Alright. Be right back. I'm back. I'll be back. Alright. I think I got the 10-minute version of this, but I don't complain. This song is super good. Alright, so alright, so when I was rushing yesterday, I was trying to get the position, range, and fragment position, which I believe is the same as the world position versus the position of this. We do exactly the same thing here as the point lights, it looks like. No, it's a bit different, but it's similar. We then work out we multiply distance times by distance squared. We get the max one of these values. So this stops us being at 0, which is the... Yeah, I should probably do that instead. Which is probably more accurate. That gives us the attenuation. Yay. So I'm going to try and use these functions for a minute. Okay, so we want so I have to be aware that my scene is huge by the looks of things. Right. So we don't want luminous power right now. You duplicate this. No, sorry. I'm trying to think. I want to combine these two functions into a function. But I think that means we need 4 arguments, which is kind of awkward. So maybe it's best to do 2 functions. Yeah, I'm going to do 2. So the cone cutoff, we could probably just set these to some radian values. We have the direction, which we can set to anything, and we have the L, which is the light beginning point. And okay, cool. So yeah, let's take these two and try and work out what we need to do here. So we need to multiply intensity by thingamajiggy, attenuation, which we're going to grab next. So the reason I'm using these functions is because they're much easier to understand, which is totally fine by me. Yeah, so I'm going to actually duplicate this just because it's going to be simpler. Just comment it out. Right. And I'm going to put these two here. So, these return both a float attenuation equals this, and intensity intensity equals this. And now we need all these values to be sent in. So we do have L, And the distance is this. Oh, yeah. Let's get rid of this. As far as I can tell, that attenuation multiplied by intensity, or all the way around, doesn't really matter, is the illumination that we're going for. Right, okay, so we have position, which we could just set ourselves. We could set the range. I think the range has to be less than 1/2 radians. So that's fine. The frag position is just our V position. So I'm going to throw that in. The rest, so distance is this. And the cutoff of these are the two values. Alright, let's see the attenuation. So range. Let's go next. Alright, so range. This gives the distance divided by the distance. Power to the power 4. Does power 4 exist? I'm just going to compile this. Oh. So this is just power 2 to the comma of 4. So that should be good. N, we don't have capital N. 216. Sorry, 261. Oh, right, yeah, okay, so yeah, we're not doing this for a minute. We will probably not do that. Right, so let's build. See how that gives us. 372. Right, okay, so... Oh, yeah, okay, so we don't have everything in, which is fine. Alright, so the position is going to be... Do I want to do this, like set the world position? I am tempted to set the eye to be the position, maybe. And the range is going to be, I don't know. What would the range be for attenuation? Let's see, range. Okay, so we have, let's do this again. Range is... Right, I assume that's just like the range between the I want to make this very small, just for now. I don't want to make it really big. So I'm going to do like 0.1. That might be huge. I don't know. My scene is huge. You've got to remember that. So the light is... We do have an L, which is just the light. So we'll go with this lighting direction L, which I assume is normalized. Let's see if we double normalize it. Hang on. We take... No. Okay, so that... Yes, we normalize... Okay, so that's already normalized, I assume. And finally the vec2, which is just two cutoff values, which we want maybe pi pi divided by 4. I don't know which one's outer and inner, which we'll have to work out in a minute. Oh, we can't do this. This is C++ syntax. Vec2, we do it like this if you want to do it like that. Nope. Pi divided by, let's just say This one's the outer. I don't actually know which one's which. So calculate. So which one's inner? Inner's first. Okay, that's good. So I did the outer second. Okay, so alright, let's have a build of that and just see if it wants to play nice with what I've done. Syntax error on... I think that's the issue. Yeah. So we have no matching function for this fella. That's because we have... I might have sent in the distance as a float instead of a... Okay, it wants it in vec3. That's no problem. And the rest should be vec3. Alright. N.L. No. Ooh, yeah, this is going to be tricky if I... I have no idea how that's going to match with not... okay, so I'm going to just replace this with capital L. Because we passed that in. Let's pass that in as well. And let's just see. That should be good. So I'm going to just increase some variables and just see how that works. So I'm going to increase the range. I just like, I don't know what the range needs to be, so I'm just going to do the opposite of what I did. Turn off that for a minute. Spin around. No. No lights. Okay. Trying to think right now. Okay, so we have two vectors. We have... See, I don't know what the position needs to be, to be honest. Let's just set the distance to be a set distance. Yeah, let's simplify everything down. So 10f, 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 right? So that's the distance. The position is going to be 0, 0, 0. So vec3, 0, 0, 0. Okay, so attenuation, yeah, position and range. Again, I don't know exactly what that is. Oh, I see. That'll be the sphere of influence. I just realized. Okay, so that's fine, being huge. And then what's the last one? Frag position, which I believe is real world position. Which I think needs to stay the same. Let's just zoom out a bit. Maybe I should change the scene. Someone said I should change the scene yesterday, but it's kind of like tricky to do. That's going to take a big... It's doable. But I think we're just going to end up in the same situation again. It's possible that the spotlight is being missed. but I don't think so. Let's go with intense. Let's get off attenuation, right? No? No, don't think it's anywhere in particular. Let's change it to... hang on, am I multiplying this twice? Gotta be careful I don't do that. The position, what I'm looking for is the position. Yeah, I don't know. Okay. Let me think. This is kind of tricky. I just need to check something real quick. Hopefully guys okay. Hopefully you guys enjoying the stream so far. This is what I mean when I was saying you're gonna see me struggle later on in the stream. This is the you're seeing me struggle live part of the stream, which I'm totally chill with, to be honest. So yeah, it's this is how you learn, though, you know. I'm getting hungry though. That's one thing. It's yeah, because in their code they do something really strange, in my opinion. Which I don't understand at all. Let's see. Let's turn off this. Nope. Let's move my microphone. Right, so how I'm going to tackle this, because this is the... I could just look for like random code online, because their code is just like borderline incomprehensible to me personally, because I don't know what these values need to be or what they are, right? Like, what is light inverse radius? It's just like there's a bunch of code missing and I don't know exactly what it needs to be. Because the code for a point light was so different. And I don't know what like a good value would be for these two, apart from 55 or 50. You know, 55 would be a good outer angle. 55 degrees even. But I need to be able to do this because this is important. So now I'm just going to think about how to solve this type of problem. Yeah, because the thing I don't understand is the light intensity. We have attenuation for the inverse square fall off and the attenuation function. Sorry, the attenuation angle. Then we just have like an arbitrary light intensity. And yeah, I could fill these values in, which I did prior. But I don't know what they should be. I'm guessing the light inverse radius is the inverse of the light radius. Makes sense. It's just the inverse, yes. 1 over light radius. The thing is, I don't have a light radius. So I don't know what it wants when I do that. Like, do I just arbitrarily make a sphere of influence based on range? Ah, okay. I think that's what it is. It's the range, isn't it? I'm calling it range. They call it light. They call it light radius. And I think that's what's going on here. So when I wrote this spotlight, so I'm just going to comment out some stuff for a minute. I mean, it's an artistic parameter. Yes. Unfortunately, right now, I don't see any light at all. So that means, like, the artistic parameters are getting me confused. So let's throw this in here and just kind of work backwards then. So if I think the light radius is that, then the light radius is, the inverse is 1 over that. So that'd be like that. And yeah, this is the thing light intensity, just arbitrary light intensity, which is just, so this when I did this is what I did. Oops. I think that should just work, but I don't think it'll light up anything. I mean, let's just turn the light intensity to something insane, because we already established that the point light is so small that in the scene that it's possible the light is tiny. Whoa. Wait a minute. What's happening? What? Okay, so there is light. What the heck? Okay, that's it. That's a good sign, 'cause that's progress. But it's like close to a point light. Hey, what? What is happening? I think the n.l maybe is wrong. No? Oh, okay. What? Okay. Is that right? Oh. That seems correct, right? The range is a bit small. So if I made it massive. Whoa, okay. What the heck is going on? Does it not light up the other way? I'm confused. Huh. Does it change direction? Okay, so let's reduce the sphere of radius. That's obviously too big, and it only works in one direction. Oh, light direction. I see. That's why. That would change a lot. So light direction for us is just it's a vector 3. So this would be when I did the point light. I think I've deleted it, unfortunately. This is just. Yeah, gotta love the building. Yeah, it seems correct, exactly. Scene reference data dot scene data dot light dot RGB. No, yes, this is right. XYZ even minus V position XYZ. So that is the true direction, I think. Again, this is all kind of like, okay, so what? Hang on. Light direction. That's the position to light. Alright, so I'm just going to run thing. Obviously that's wrong, but... How do I get the direction? Oh, okay. Hang on. Does it go the other way? No. I mean, it is doing a spotlight thing, right? So if I increase this by 100, we should hopefully see something that's like has a little bit of like a big range, but it's yeah, okay. That seems like a spotlight attenuation at the edge of the screen, but it does not rotate with me at all. So I think we need the direction vector to be different from what would that be if I get the direction vector? So that would be my rotation, orientation in space, but I don't really pass that in. I mean, do I have the camera's view projection matrix? That might be possible to pull that out. But again, it's just like a... What is the direction vector? Right, just bear with me one minute. I'm going to sort something out in the real world, unfortunately. Sorry about the numerous distractions. I had just had so many flies flying around. I had to get rid of some of them. Hot day, you know what I mean? Had to get up and do something about it. I should have paused that, but that's fine. It's too much for faff right now. Okay, direction. How do I get the direction vector? I have the position vector, obviously, but I don't have the direction vector. And I think I need to pass that in if I have a torch, right? So, you know, if I just set the arbitrary direction, it is super confusing. I wonder if I just set it to the position of the light. But I think that's the translation, not the rotation. Yeah. That's just going to change relative to my position. Not when I do this. Oops. And obviously, like, we have a random value here originally. So what I'm going to probably have to do is edit some shader stuff and just get the direction in. So 1, 2, 3. I'm just going to make sure this is working, otherwise I'm not going to bother. Which direction would that be? Okay. And I'm going to reduce the angles. It just feels like it's way too big. Yeah, so let's reduce the sphere of influence to 50 again, and reduce the maybe by a factor, and let's make this 8 and I don't know. 16, that might be too little though. Okay. Oh, sorry, on the top of my screen. What I'm trying to see, actually, you know what I should do? Leave everything back to the way it was when it worked. Right. Figure out that direction and then just decrease the values, right? I think that's what I need. I think I decreased too many things at once. So if I go in, what is it? It's just straightforward, I think, yeah. Alright, so straightforward, fantastic. Then what I want to do is just go, alright, in angle 16, this is 8. So it's going to be hopefully a really tight angle, despite the sphere of influence being really large. I pray. Nope. It's too small. Let's move my screen so I get rid of glare. Nope. Nope. Definitely does not do anything at all. Alright, so maybe that's too small. Okay, so let's just go with 6 and 8. A bit smaller. So the outer angle is still bigger than the smaller angle. Right? Wait, why did it work? I'm so confused. I don't know what these values should be at all, honestly. I mean, I could just send them in, but it's just kind of confusing. Maybe I should do that. Hang on, let me think. So we have super high intensity. We have 3 different values here that we could just send in and then change via a button press. We also need the light direction, like I said. And the direction vector would be the camera's forward vector, as far as I can tell. Which I don't have at the moment. I have the... hang on. What is the forward vector for us? It might be the I vector. Hang on. Now, is that what we're looking at? Yeah, give me a minute. This worked with... No, 4 and 6. Formula for getting the direction is 2 positions. Yes. But I need to know the direction, not the distance. So I need to know, like, based on my rotation, what is the vector that's facing forward, I think. And I think I'm sending that as the eye of the camera. But I need to... No, let me think. So I'm just going to go back again until this worked. This worked at a particular point, right? This was 1, 2, 3, and if I've got to make sure this works in this specific case, and then... Right, does this light up again? Yes, okay, so this lights up. And then what I'm going to do is literally just change this to the camera's eye. And then just see if it does the same thing. No, eye. Yes. I'm trying to make a spotlight. I'm not sure if it's a VEC4. Nope. I'm not changing the camera in any direction. So I think I need something else other than eye. Let's see what eye is. So when I go into my code, hang on. So to get the direction vector, we have up, right, and eye. What is eye? Eye is eye. Thank you. Yeah, but what are you assigned to? Yes, you're assigned to that in game. But yes, but there must be an assignment here. What? Okay, so that was never going to work then, because that's just not what we needed. So we need camera, and we need to get our direction vector, which is so I believe if I go into here, this might be too deep. Okay, here we go. So I think that's what we need. We need the view. If we take the view matrix and we get the direction vector, I think we need the direction vector passed in to get which direction we're looking at, which is our forward vector. And I think that's going to tell us at least. So I don't know what I is. I think I is like completely not useful. So in fact, is this a vec 4 or vec 3? Oh, come there we go. Direction. Let's see. If I go to peak, it's vec 3. So that's going to be, yes. This is correct then. I was just hoping to avoid this triple access at runtime, but it's fine. Okay, so I is now hopefully what we're looking at. So if I go back into the shader and C, okay, so ooh. Okay, so at least it's updating, but it's not updating it's only updating in one direction. Interesting. But that's progress, I think. What about translation? Does that? If I press... Okay, so there's this... It feels like there's this sphere of influence I'm moving in and out. Q. No, E. Yeah. But yeah, I think we're starting to get the data in. That's the first piece of data. I think it's correct. That's gone in. The rest, I don't know. Okay, so I am going to throw in maybe the position to light. I don't know. What should this be? Position to lights. Okay, it's just L apparently, which looks like to me it's just a normalized of L. So this should be L. Ugh. Oops. Not what I thought it was. No. Does it still... Whoa, okay. That's like max intensity. Huh. And this doesn't work for any other direction. Okay, so we have L direction. And I'm going to turn down the intensity by a few orders of magnitude then. Let's see. Because it just lights up everything. Right, okay. Let's keep going. The inverse sphere of influence. So if we look at the code again, we have n.l. So position to light is literally well position minus that. Okay. Oh. I don't know if that makes a difference, but that's going to be important. I don't get what's going on, but that's fine. Just get these values correct, and we'll crack it. So look at this again. L. Oh, wrong. Okay, so L. Okay, that's not right. That should have been L. Sorry, I got that wrong. Let's get rid of this. That was never used for anything. Yeah, for the B. Okay. Okay, so light direction. Light direction, light direction, light direction. That, I still believe, is the rotational vector. The inner and outer theta... Oops. The inner and outer of these two are... There we go. There's the inner and outer angles. Yes. Light inverse radius. Position. So the position is not... okay, so that's the position. Which I think that is correct. Okay, so that goes in there then. And let's just see. Light is undefined. Where's light? Normalized light. Okay. Let's get rid of both of these. Okay. Swim around. Oop. Okay, it's trying to see if it's going to light up in any direction. Spin around. Oh, making accurate lights with attenuation is so annoying. At least do that. I guess I could turn up intensity again and sphere of influence. Just see if that's now shrank down again. Nope. It's annoying that we're getting nothing again. Yeah, we should get something with intensity, right? Yep. Okay, so that's just everything turned up with nuts. Like, none of the attenuation is happening. Nothing silly is happening. Okay, so the intensity is super, super high. And next I want to do is just... what I'm going to do is obviously multiply by attenuation again, but I'm going to get rid of a function, just see like how that affects things. Like, do we just get nothing as soon as we get rid of a function? So that should be a fall off based on, I assume, this sphere of radiance. I think we've literally made a point light. Yeah, we literally made a point light. That's kind of funny. Okay, so we've made a point light. That's super surprising to me. But I think we've got these two right then. Now, I have no idea what's going to happen now. So forgive me if this is just silly. I'm just going to make another variable and just see like how this is affected. by itself. No, so I think we just get like 0 here. Like, multiply everything by 0. Right? Yeah, if this gets wrong, if this value is wrong, then we just get multiplied by 0. Okay, so that's at least told me something. And lighting direction, inner and outer angle, and the L, right? So let's look at these functions. I think this is the problem child. I think we've already figured out that one of them's fine. Because if we've got full intensity, I don't know. So this is literally that function we saw at, no, it's inner. Never mind. So we have cosine, outer. So that must be the candela unit multiplied by spot scale. I wish I knew. I wish there's a breakpoint that I could put in, like, well, if statements or printfs, like when becomes 0. Because any of these multiplications become 0, then it's just, it's already over. So at some point in this multiplication series, we get a 0. Which is fine for some of the values, but if all of the values just turn out to be, like, if spotlight, offset, and scale are both 0, then this is just a complete not going to work ever. So now we've got to figure out if lighting direction, and if these end up being the same. No, we've seen this before. Hang on. Where was that used? Lighting direction. It's not normal, is it? I don't know if it needs to be normalized. That's the other question. So I'm going to normalize it. Don't think it's going to make any difference, but might improve anything. No, because I have a feeling that's going to have to be normalized, because we're doing a subtraction of a normalized function here, and I think this is expecting a normalized dot product to get the candela radiance. The next thing is, so what should L should be? So I think that's the lighting direction. And this, what is L? L is, yeah, distance minus position. I wonder if it's literally just, I don't know. I really don't know. Whoa. Okay, we'll normalize that. So that goes from 0 to 100, like, instantly. And I think that's because the sphere of influence is so large. But let's normalize that. Oh, my laptop's about to die. Yeah, the problem is if it doesn't have values the whole time, then it's... Then, like, for example, here we're getting 0. Yeah, it's just confusing. And I don't know what the heck these values change. If I change them both to pi, right, I don't think if the inner and outer angles are the same, it's going to change anything. I could be completely wrong with that. Like, it could be... So effectively we shouldn't get any attenuation, sorry, any fall off at all. Oh, interesting. Right. So if I take and multiply these two together, what do I get then? So I think I'm just getting a point light. Interesting. So that's as big as it can get. Okay, so that just does nothing. I think if they're both pi, they don't do anything. So let's go with the... Right, this is good. This is progress. So I'm going to set these to inner and outer again. So inner and outer. So that's the most extreme. So where it doesn't do any... Okay, so as far as I can tell, this does nothing, right? It's as intense as multiplying by just intensity. And if I get rid of this, I probably can confirm that very easily. Yeah, it's basically the same, right? Yeah. Alright, so put that back. So if the outer is pi, and this one is half a pi. So that's like, what, 90 degrees? So 180 versus 90 degrees. See, I don't understand this at all. Like, why does it go to 0 here? And if I re-add in the other attenuation based on that value. Is the sphere of influence, like, affected by this? So... yeah, sometimes I just get nothing at all. Like in this direction. Oh no, wait. Am I lying here? Yeah, going in this direction I just get... I don't know. I feel like I get more light in one direction and less light in another. Yeah, it's got to be different, that, versus this. Yeah, no, it's different. Yeah, it's so much darker. Alright, so attenuation 1 again. Now, first things first, does this although I'm gonna just do some sanity checks. This does a I don't know if this needs to be normalized. But it is a position to light, which would make kind of less sense if it was. So what I'm going to do is just use this attenuation factor and just see if the point light still works. When I do this, and just see how... so this should be fine. This should be a regular spotlight. But we get close and it gets all lit kind of like around. Then what I want to do is kind of normalize this and just see the difference, right? Obviously, not every vector needs to be normalized, and I don't think it always makes sense to. Actually, it definitely doesn't always make sense to. I don't know why I said that. Yeah, okay, so clearly that's not correct, which is fine. I just want to make a super obvious mistake. So therefore I don't... Right. Inner and outer angle, inner and outer angle. Okay, insane. Let's just check. This doesn't work at all. This should not work at all. We should basically get nothing ever. Yep. Ooh. Okay, yeah, I very much doubt this is correct, so... I don't know how to, like, learn this stuff, so I don't have to just fiddle around with the values over and over again. If you know what I mean. Like, what on earth should these values be? Shall I just write the math myself? Like, I don't know. What is this attenuation function referring to? I assume it's this. But this is literally just a point light. And this is like implementation of punctual lights, plural. So it's both. But yeah, what lighting direction, like L, which is just this position normalized. Oh. Okay, so let's just do that then. Okay, so insert. So the L value apparently is L is equal to normalize position to lights. Alright. And then n.l, which I assume is what it's doing. Wait, what? I'm so confused. Why is that there and then... Okay. I don't know. We're just going to see what this does. Oh, and it doesn't even change anything, but it changes the L maybe? Oh, wait. What? It's literally the opposite. I'm so confused. Why is it doing that? Have you ever heard of a dark light before? Okay, so let's get rid of this directional light normalized thing. You made a spot shadow. Yeah, spot shadow pog. There we go. Can't touch this. I don't know what I'm doing. What is happening, bro? Oh, it's doing literally the opposite of what I want, but it's kind of cool. This is definitely progress, by the way. We've actually... This is massive, for those who don't know. I just need to literally do the opposite of this. So attenuation, basic... It feels like attenuation needs to be, like, minus this. I don't know if this is going to make any sense, but effectively I need this. I assume, anyway. No, okay. That just broke everything. Nope, okay. Never mind. I thought I was just going to be easily just subtract that and just get a multiplication minus. Anyways, so, okay. 1 minus. Yes, that's probably... Let's do that, yeah. I obviously have got this wrong, but if we can see maybe like what's going on. Oh, nope. Okay, so okay. Let's do this. Let's do this. Originally, this was both of these multiplied together. Originally. But I don't really know why. So we'll just do that and see if that fixes it. I don't know why we do multiply a spotlight by a point light, but... Okay. No, it's just like super... It's just the same thing, but really, really... Yeah, you can see this is the same thing. But it's just really... No, okay, we're not doing that. Okay. The inner and the outer angles need to be reversed. I don't know. I'm just going to keep fiddling around with values. And hopefully we get something. We have at least a base truth that we can get returned to. No, I assume that was never going to work, but I'm just going to rule out the obvious stuff. Okay, so this is the inverse thing. If you don't want to see what you're looking at, I literally don't know how I've done that. Maybe this needs to be reverse. It's supposed to be reverse radius, but I don't know. Nope. That's just changed. Okay. Huh. We're very close. If we just get the right value change, then I think it's gonna work. But I don't. What has happened? Am I clamping the wrong way or something? Okay, so if I do this, this obviously is not going to light up anything because this is just attenuation, right? This is just attenuation. So, okay, yes, okay, that's good. So when we do this, we get attenuation backwards. Now these are float values, so it doesn't really matter which way you order them. We have a commutative and distributive properties that are basically the same. So these are all floats as far as I can tell. So vec3, okay, so that's not a vec3, but that's fine. That's a vec3, but these are floats, floats, and then another vector. I think vectors and floats, you can multiply them in any which way you want. Nothing happens. Isn't it, reverse? Again, I'm just kind of guessing. But I feel like we're just going to get the... Yeah, it's just going to be behind me now. Light direction. Inner angle is less than outer angle, which is correct. And then the L value, which is just light position. All multiplied by n dial. So cosine outer angle. And it really is not just reverse the intent. No. So he just went... Let's just look at his code. So when he's doing this together, he just does attenuation, light intensity, which he multiplies these two together for some reason, which was confusing me for ages. So L is just normalized point light, which is wrong, I believe. This needs to be moved to there. Like, this should be put at the top. Light direction, I believe I've got correct. Don't think that's wrong at all. Inner and outer angle. Because you can't have negative intensity or anything like that. I'm gonna crack this before I eat, so I might starve before we finish. Because it's so close. Let me just look at this again. So yeah, the direction vector's fine. I need to do what though? Something's got to be inverted, like the... So the sphere of influence is minus radius. Okay, so that... These... Position... okay, so these two are completely irrelevant, apart from this L value. When we do n.L, which is this, we get that, yes. N is just the normal vector. It's just, sorry, it's the normal matrix. Which is correct. If this was wrong, we would see things lit out of order, if that makes sense. We would get like, I'll show you what I mean. We wouldn't get a nice sphere in the middle. We wouldn't get this nice, well, nice. But we wouldn't get this like black spot. Like, things are being lit up uniformly relative to where they are, regardless of their orientation. So I don't think it's the N. So it's not the... I don't think it's this product. Let's reduce this size a little bit and just see how this affects things. So this would be, well, outer angle would be 2, and I'm going to change this to 4. So you've got a 90-degree cast out ray and a 45-degree... okay, so... What? I think it's too big. Wait, what? Hang on. I went smaller and it disappeared. Whoops. Okay, okay. So, this is 180 degrees, which means that this is as wide as it can get. If I reduce... this to like 3 and this to what, 2? They're quite close together now. Just... it disappears completely? Oh wait, the duck, did the duck light up then? No. No, it's just me flashing through stuff. No. Okay. Okay, that's really confusing. Oh, am I... hang on. Am I doing the inner and outer angle wrong? Am I getting confused here? Yeah, the inner angle's smaller. So this needs to be... I'm learning C# and Raylib. Newbie to game dev. I'm kind of a web dev. 1 junior. Oh, well, welcome. I hope you have a good time. Is your direction flipped? Maybe the light is behind you. Ah, that might be it. Yeah. Okay. Okay. So my inner angle is 2. Yeah, that would make sense, right? Okay, so now, assuming that it's behind me the whole time. Maybe now, if I reduce the size of these guys, it will make sense. So the outer angle is going to be like 10. And this is going to be what? I'm going to make it really small, so like 12. I don't really care that much. 12th of a... Ah, that was it the whole time. Oh my goodness. We did it. We have a spotlight. Thank you, Count Toshes. That literally was the answer. Yes, we were seeing the back of the spotlight. Now let's actually make this look nice, a little nicer. So, I don't know. Inner angle needs to be a lot less. So I'm gonna go 20. Obviously, it's in radians, so. And I'm gonna make the. Oh, it turned down the intensity. That's way too high. Okay, cool. Okay, that's a bit too low. 500 intensity. Hello, Kalia. We're getting close to spotlights working. If I turn this off. Look at that. You can actually see where you're going now. Just going to increase the radius of the outer one to like 6. Yeah, it's good. Just cracked a big part of the code base which has been causing an issue, which is the spotlight. And if I reduce the sphere of radius to like this, so I'm just messing with the values at the moment in the shader. Oh, okay, so does it ever not light up? Because I don't want it to light up literally everything forever. I want it to stop at some point. It's getting brighter, it's getting further away? Huh? I'm gonna keep moving back. Okay, so it's not... Yes, it's coming soon. I've got the fan on, I've got the windows open. There's not much else I can do, unfortunately. We don't have AC. So I'm going to be a cooked escape point, especially on Thursday. I'm not looking forward to this heat wave at all. Okay, so there's still not... Why is it lit up super bright on this side? Yeah, because it's weirdly dull on this side and then super bright there. Like, very bright. Oops. Okay, so if I turn this back to 50... And... Yeah. Yeah, weird. It's like dull on this side. And then blazingly bright over here. Like really bright. The intensity just keeps going up and up and up. Huh. Wow. Okay. Right. Let's see. What do I want to do? How do I want to... Okay, there's still more issues, but... I think I can at least claim some small victory. I'm going to change this to get rid of the white. I'm just going to get rid of the gold for a minute. Obsidian is very awesome. Oh, are you enjoying Obsidian? Yes, it's a fantastic A fantastic app. Okay, so that's the not colored version of the light. You can see it's like, yeah, so bright over here. It's like blowing everything out. I don't understand like why that goes on forever as well. Started using it. Yeah, it's I'm glad. It's funny how many people have converted to Obsidian over the live streams. I didn't realize that would be a thing that happened, but there we are. Yeah, it's very easy to follow. I like the connectiveness of all this. So yeah, being able to link papers, being able to write LaTeX, being able to generate notes and add pictures in very easily. It's quite nice. It's a quite nice piece of code. Well, note-taking app at least. I don't know how the code is. Okay, so I'm curious. If I multiply these two together, which just seem to add a point light and a spotlight together, so we basically got nothing. But do they need to be together? Ah, okay, that's the idea. Yes. Yeah, so that stops it going on forever. Migrating my notes to Obsidian. Hell yeah, bro. I hope it goes well, and hope you enjoy it. Eventually you'll have a... Well, you probably already do. Once you've converted, at least you'll have a... You'll have all this, you know, a big web of connected things, which will be your expertise on display right there. That makes a lot of sense why you need both, because now it doesn't go on forever. Okay, so now how do I make it go more than just like... My scene, I think, is massive. So does that change anything? No, it's almost just the opposite, where it's like impossible to see what's going on. Well, I think you need some kind of editor tool using IMGUI to help with debugging. But this is gonna take a not trivial amount of time. I think at some point, yes, we do need something like that. You'll definitely have that soon. So yeah, now I just need to make it so it's not so small. I don't exactly know. I'm gonna do a huge... I'm just gonna mess around with values here and just see. Now we've got the... okay, it's way smaller than I thought. Okay, so it's even less. So 1/2. Like, what is that then? Is that massive? I'm confused. Nope. That's doesn't seem to be affecting anything. I don't know. So position to lights. Light radius. Okay, so let's work off of this. So we got distance. So we do a dot product between these two. And when I look at this, it's not anything strange. It's not normalized. It's just a float. And what happens if I send in a negative number, like -1? Like, is that going to go on forever or break or what? What's that going to do? No. Is it not going to do anything? Okay, so I think this is even worse, yes. So, but if I send in a number like something silly, like, I don't know, 5 million, It doesn't seem to restrict it at all. You know, or 1. I don't know what this value needs to be to have. Again, it's just really, really small. Maybe the not intensity, but is this using anything else? No. I don't know. Let's see. We're getting there. We just need to figure out how to make this bigger, which is what I'm gonna do as well, just for sanity's sake. Now we know that we do have a spotlight. Now we just need to restrict it. I just want to make sure that the multiplication in, you know, is correct. Okay. Right. Okay. So it's just really, really small. And it doesn't matter what number. It seems like any number will work here. I can put in silly numbers. Like 888. You think, okay, yeah, that didn't seem to do anything. That made it worse. I can do like 0.9. I will eventually figure this out, but I've just got to reverse engineer it. So yes, that is just as small. It's even smaller in some cases, and you know, 1 over, you know, what, something silly like 888. You know what we did before. So that's a really small number. So that should be like a really big sphere of influence if it's the inverse. Oh wait, that is bigger, right? Yeah. That is lighting it up. Really? This needs to be that big? That can't be right. How big is my scene? Oh, okay, yeah, no, that is correct then. Even now it's too small, literally. I think I'm gonna... Oh, it can't be this. This is too much. Okay, so 1 over... This is, I'm gonna literally overflow at this point. Yeah, numerical limit. Like, this is ridiculous. The numerical limit is being hit, and this is how close I have to get. Okay, so it's got to be something else. That's just silly. So I'm gonna put this back over here and just kind of put this back to, like, I don't know, 500. That seems reasonably big instead of this value. I don't even want to know what that is. Okay, so position to light. It's possible that this value is wrong as well, so we'll just kind of work with it. So we do get some, like, something that's reasonable, right? Ish, but it's just so dim. And yes, we could increase the intensity by like an order of magnitude multiple times. Oh, okay, that helps. I feel like it's not. If I turn this off, how's that look? Right, so that's still huge. To be honest, this happened with the point lights. My point light was the same. It was like, it only got to a, yeah, okay, so it was just that. Right, okay, so now when I fly off in like a random direction, It's not light. Yeah, it's not lighting up the whole scene. So, okay, so I think we successfully got a spotlight. Yeah, we got a spotlight. That's victory. I'm calling it. I just didn't have the intensity high enough, and if I bring back I think I've unfortunately got rid of it. But if I get rid of attenuation for a minute, and I bring back our point light, I meant to say not spotlight, and I throw in the same values that we did before. The values to get the actual to get the values that I want for our point light. And the point L, for example, because I don't want to get confused. So point lights, multiply these two together, and we need, like, I believe something as equally as insane. So what I'm going to do is pass this in. Let's see. I should make sure these values are correct. Lumens, light range. Oh, light range first. I'm just surprised how big my scene is. I thought it was a lot smaller than this. Well, it's good to know, I guess. So lumens, okay, so we want the range to be like 5K, and then, yes, this is what I had earlier. Oops, no, why did I do that? That was a complete, what? No. Sorry, I literally went blind then. I ended up looking at the wrong thing. But if we take, yes, this, I think. Hello, how you doing, dude? Hope you're having a great day. Thank you for joining us, Warfare. I'm just comparing my original code. Sorry, my original point light with my spotlight. And it looks like my spotlights require so much intensity because they're so small. Is ray tracing important? Is ray tracing important? It depends on what you're going to implement. Kalia, I could say yes, and if you're interested in going into writing graphics code for movie studios, for example, they require good path tracing and ray tracing knowledge. If you want to make a game, no, until a certain point. I have got this book called I recently bought this book. I'll get it up. And I would have said no just straight off rip, like before. I'll just pause this for a minute. So I got Zen 3. I've recently got this book, this exact one. I've got it on my desk right now. This book it's got like cool stuff in, but I was looking over some of the stuff like in this image-based lighting, RDF, multiple importance sampling for stochastic screen space, indirects, blah 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 blah. And I was like, oh, okay, I'm just gonna read about image-based lighting and do the BRDF or whatever. And it has literally the same code that I was reading for an offline ray tracer in it. Like it has literally. So if I read this out loud, it has. Where is it actually? This would be chapter 10, so it's actually past everything that I'm reading. So I feel like, and also the one before it, the what is it? This one, I think, Cyberpunk. So number 7. That has ray tracing in it. Yeah, right here. So it was talking about. Obviously, I can't get the PDF up, but sampling theory, and that was literally, if you look at this, literally this. I'm looking at my book right now, and it has this same this same maths in. Literally. All this maths. It has, now, this book has got a subchapter called Advanced Rendering Techniques. Now, if you're starting out and you're just like learning Vulkan, don't, no. The answer is no. This is not important. But my original answer would have been, oh yeah, you never need to learn ray tracing if you're just going to do real-time graphics. My answer now is, it's going to get more important over time. So it has, no, not that one. It doesn't have that. It has, no, that's just a distribution function. Yeah, it also has, like all this in eventually. Where? But it has the, where's the weighted function? Wait. Weighted function. This one? Yes. Okay. So I'm also looking at my book, this book, and it has this in it as well. The so this is how you would deal with multiple sampling techniques with a weighted function, with a probability distribution function, to do ray tracing over a sample. Now, like I said, by the way, this is gonna, I think, gonna get more important as time goes on. It's not gonna be important right now at all. And Ratchet, who you've probably seen in chat, knows more about RT ray tracing. You would have to write this, like, this is like the maths behind the RT ray tracing. So if you're learning Vulkan, for example, and you don't know how to do the RT ray tracing, you don't know how to do the acceleration structures, this is not useful yet. But eventually it will be useful, more useful. I think as ray tracing hardware gets more advanced. But I don't think raster based rendering techniques like we're doing what we're doing with the lighting right now, for example, is going to go away anytime soon. So I'm just saying, like, when you get into the advanced technology, it seems like, as far as I can see, there are more ray tracers out there doing things. Again, there wasn't Cyberpunk, for example. This isn't the newest one, by the way. This is like, the other one had AI in it and didn't want, not AI written. Zen 4, if I take to Zen 4, it just, for me, I bought this book because it was more interesting to me personally because it had GPU driven rendering in it. But Zen 4 is the newest one, and that has it had some AI in it. I was like, ugh. But again, it has, like, there's more ray tracing in these. Where was the machine learning stuff? The stochastic machine learning. Maybe I looked at this too early, but yes, that the one I wanted the GPU driven rendering stuff anyway. So anyway, so with these, like, more advanced techniques, you do get ray tracing dropped in to your renderer as you get more advanced. But anyway, so I'd say no until later on. Then it'll start to get more and more used. So I know that's not a satisfying question. A satisfying answer. I can't give you a yes, you need to learn this, and no, you don't need to learn this. But what I'm saying is, it's not important. Hang on. Ugh. Just got to sort something out. It's not important until you get more advanced. Hopefully that clears stuff up. Honestly, as well, Kalia, ask other programmers as well, because I don't really have, like, a really good insight into like, what is the industry doing? You know, I'm just doing my own thing right now. So, you know, if the industry's all of a sudden like obsessed with ray tracing, I wouldn't see that, or they don't care at all, and it's just people's like hypothetical. I like ray tracing, so I decided to write about it, kind of thing. You know, like I don't know. I don't know what's happening in the industry. So yes, starting out. If you're interested in learning ray tracing, it won't be a wasted effort. I'm going to make a 3D game engine alongside a game. Yeah, in that case, you're fine not using ray tracing. Yeah, because some of the techniques I just described earlier in those books I just closed are like completely irrelevant. I haven't implemented any of them, by the way. So yeah. So yeah, that's hopefully what I'm trying. Yeah, all I'm trying to say is just the distance needs to be calculated differently. Okay, so I think I just take this. Yes, that's what we did last time. I remember now. Sorry, I had to solve something out and leave. But it's, again, I would recommend like reaching out to other people, because I don't know exactly. If you're making a game engine yourself, no, you don't need it. Like, let the game. If you're making a game engine yourself, I say this. I think I've said this multiple times, but let the game define the technology that you need. You know what I mean? So that's actually more important. Thinking about the game design and what type of game you want to make. Yeah, you can see the range is too small, I think. And the intensity is even too small here. So if I increase that to something insane. Is this your personal project? Yes. Yes, it is. If you want to look at my source code, it's in the description. Yeah, okay, so the point lights and the spotlights having a massive intensity value is actually normal for my scene, because it's so big. Okay, cool. That's actually good to know. I think I'm going to reduce that by 1, because I don't think I need that much energy. So yeah, you can look at my oh yes, source code and see what not to do in the description. Yeah, so I'm just going to make sure this is good still. Okay, so I broke it. Okay, so it's just interesting. Is that because the intensity's too low, or I'm just going to press Control Z. I got distracted, you see, from the. Okay, there we go. That should be good. I'm working on my old laptop that doesn't support advanced graphics likewise. Ray tracing. If it's important, it's not. No, it's really not important. Like I said, if you're making a game engine like me, let the game design drive the technology of what you need. So, for example, why am I interested in this? Right? Why am I doing a spotlight? Well, if you're driving around in a game in the middle of the pitch black in space, you need to be able to see what's in front of you. That's why I need a spotlight, right? I don't need a ray trace. What I'm saying is the wider industry might be more interested in ray traces, but for you, for making your own game, no. This is why I'm implementing lights, because the player needs to be able to see what they're doing. So that's very important to me. And you just need to think of the game, like what type of game are you making? A 3D game. What type of game? Like what effects do you need in your game? Etc. All those type of things, right? Okay. Cool. Yeah. And gamified, game filed. Yeah, I was tackling that from a bad point of view. I think I was tackling it from a, does the wider industry care about ray tracing? And the answer is probably it's getting more and more used in real time, but it's not But yeah, it's not something anyone really should be worrying about yet. Yeah, I'm gonna just play with some values, and then we're probably gonna take a break and watch a video. Hopefully that's chill. What's the sphere of influence do? Oh, okay, so that just allows it to be more... I see the difference, right? So it's more of a wider, rather than if I was to reduce it down to like something really low. We should see it like super like cone, like super thin by the looks of things. Yeah. And like not very far out. Okay, yes, I'm gonna pick a video. If you guys want to watch, because I'm gonna eat my food, I've got a pack lunch ready, so I'm not gonna be very far away from the stream. I don't have to make anything. So yeah, let's pick a video. Do you guys have a video that you want to watch that's like game related while I eat my food? This is just so something's on the screen, so it's not just me doing nothing for you guys. Should we watch this? You know what? I'm in the mood for Simon Dev, right? Who's up for that? These videos are great, and it's just about the same. How about when optimizations work, but for the wrong reasons? This is like a really cool video, but I haven't seen it in a while. We could watch maths. The math that you need. What's this? Most optimization advice misses the real problem. Also, he's got a... Oh, okay, let's watch that. Why am I not subscribed? I thought I was. Oh, well. Yeah, let's do a PBR. That'll be good for our... That'll be relevant for what we're doing. Let's see. So, let's type in... Hopefully it's just physics. Oops. It's PBR maybe? PBR. Yep. Oh. No. I'm just going to scroll through and just find it. So physically... That was my Windows noise. Why Quake almost didn't work. Grass, memory, the cost of JavaScript, trig, bloom, clouds, noise, rain marching. I actually don't know anything about rain marching. It's a bit short actually. Let's go with the longer one. I'm going to go with Quake. Let's go with Quake. I know it's not ideal, but I kind of... As soon as I saw it, I was going, ooh, I haven't seen this. I know it's not exactly what we're doing, but it's about as long as... It's the perfect length video, because we'll watch the whole thing, and I'll be able to eat my food at the same time, so... okay. Him having... yeah, no problem. What I'll do is I'll just adjust the audio for now, so you can hear him as well as me. I know this guy's quite quiet, so...
It helped inspire me to become a developer in my own right. One of the first books I ever got on coding was the Graphics Programming Black Book by Michael.
Okay. Right, so I'm going to go back and I'm going to grab my food and we'll have this playing while I do that. And we'll get back to... fixing the lighting up and adding notes, and then maybe going to photometric lighting next, because I'm pretty satisfied with that. We might do other things, but yeah, let me I'll worry about what we're going to do next after I've eaten. So yep, enjoy. And again, I'll go and push to talk so you don't hear me chew.
Growing up, Quake was one of those games that just blew me away with what a computer was capable of. It helped inspire me to become a developer in my own right. One of the first books I ever got on coding was the Graphics Programming Black Book by Michael Abrash, although I confess that most of it was over my head at the time. Released in 1997, this book isn't as relevant as it once was, but it holds stories and insider info about the development of one of the most groundbreaking games ever made. Today, I'd like to dive into one of those stories, but with fresh eyes after more than 20 years of additional experience. So, visibility determination isn't easy, even today, as I showed with my recent deep dive into current methods. It remains very much an area of active research and development. Rewinding the clock back to the mid-90s, and we go back to a time when this field was very much in its infancy, comparatively speaking. The Quake dev team faced this very problem. The game was unplayably slow, and since they were breaking new ground, there was no clear solution to turn to. When we talk about visibility determination, for the purposes of the video, we're talking about what goes into drawing a pixel on the screen. So you're down here, this is the camera, and you're looking off in this direction. So what we want to know is what's visible to you. In modern games, this mostly boils down to culling out what's off screen, which is called frustum culling, then doing some occlusion culling to figure out what objects are behind other objects so we can cull those as well. But back in the 90s, this was being done in software on a desktop computer that would choke on just playing a song today, something that we all take for granted as background work. Quake originally required a Pentium 75, which had a processing speed of approximately 126 MIPS, or million instructions per second, according to Google. Take note that this is instructions per second, not floating point operations per second, which is what you might see on more modern hardware. By comparison, the phone in my pocket is capable of somewhere in the realm of 1142 gigaflops, or 1.1 million megaflops, if I haven't messed up a decimal somewhere. So the gulf in computing power, even though this is a silly comparison, simultaneously, it's good for younger viewers to have a grasp of how much of a potato that thing was compared to anything you have now, not to take anything away from what it was in its day. The cost alone of simply rasterizing a triangle was high, so you needed to be fine-grained and only draw the polygons that were visible. There was also no GPU in any modern sense, as in a GPU that you could offload a significant amount of the work to. No depth buffer, no shaders, not even hardware TNL. Like, you had nothing. So you're working with a few more constraints than today when you're doing your visibility determination. You don't want to simply discard the objects that aren't visible, that's still way too much. You want to get even more granular than that. In an ideal world, you'd somehow know just the polygons that are visible that contribute actual pixels on the screen. In an ideal world. And of course, that magical test, whatever it is, has to be fast. Quake stored its levels in a BSP, or binary space partition, which is a data structure you don't run into much these days. Conceptually, they're not that difficult to grasp. Let's take a simple 2D example, and we'll build a little tree to illustrate what they do. So right now, the space, the level, whatever you want to call it, it's empty. We can add a wall, let's call that wall A, and the wall has an orientation, like this way is forward, and obviously the other way is backwards. The wall creates a splitting plane, so that forward, or in front of the wall, we'll call it empty space, while behind the wall, this is solid. This is an important thing to take note of, because it'll be very relevant throughout using the BSP. So we've defined the wall, let's define a node. In this case, the root of the BSP tree. We'll call it A. This node has two children. The left node represents what's in front of A, which is empty space, while the right is behind A, which we're calling solid. This represents the region behind the wall. One wall isn't terribly interesting, so let's add a second wall now, and for simplicity I'm just going to make it down here, like this. So this is wall B, it faces in this direction. We have to insert this wall into the BSP, so starting at A, we have to check, is this wall B in front of or behind A? We know it's in front of A, so we're going to go to A's child, the empty space node, and replace it with a B node. And this node, of course, has a left child of empty space and a right child of solid. This left child of B represents this region here. Notice how it's the region in front of A that's being split by B. The left child of B represents the region in front of B, while the right child represents the region behind B. Let's repeat the process now, but with a horizontal wall C on top, facing in this direction. So C is in front of A, and it's in front of B. So it gets inserted here, replacing B's left child. And so you have this new node C with a left empty child and a right solid child. And I'll leave it to you to do this on paper, but if I were to add this new wall D, which faces in this direction, then it'd end up here as a child of C. So we end up with this kind of boring BSP tree that's basically just a line of nodes descending to the left. But the really cool part of BSPs is they enable you to do fast operations. Let's bring in a slightly more complex BSP, just to make the tests a bit more interesting. This one is basically the same, but I've inserted a few more walls. If you're following along on paper, take special note that I just inserted them in alphabetical order, and notice how E is in front of D. But when I go to insert F, it's behind E, thus on the right. Now let's test whether a point is in empty space or in solid space. This point here, very obviously by looking at it, is in empty space. But we can confirm it with actual code, trivially. Starting at the root node, is this point in front of or behind the splitting plane? In front, obviously, so we move to the next node, and it's in front of that. So again, we move on. And we repeat that process over and over again until inevitably we end up in a leaf node, either a solid node or an empty node. In this case, an empty node, signifying that this point is in empty or free space. Or in other words, if that's a player, they're allowed to be there. So BSPs can accelerate these kinds of tests. They allow you to rapidly discard large sets of the world. But another interesting property is that each of these nodes here, each of these represents a portion of the space. They in fact split the space of their parent. So starting at the root node, this is all space. This node's left child is one half of the space, while the right child is the other half. When we look at this node B, it partitions this space here, meaning that its left child is this space in front of its splitting plane, while its right child is this space behind. And we can continue in this way. Looking at C, this node is splitting this highlighted region here along the plane that we provided, meaning the left child of C represents this space over here, while the right child of C represents this space over here. And likewise, we can continue on, and these nodes carve up the space into these ever finer convex subspaces. And we end up with these 3 convex subspaces that I've colored, which correspond to these empty leaves in the tree, which is kind of neat. That's one of the big takeaways. BSPs carve up space, and you can of course calculate bounding volumes for these subspaces if need be, and having bounds on these nodes allows you to rapidly discard entire portions of the world, making BSPs useful not only for rendering, but for other gameplay systems like physics. Lastly, BSP trees give you a natural ordering when you draw. They can be used to easily give you surfaces in front to back order, or back to front order. If we take a really simple BSP tree, we're just going to have a couple lines here, so you could follow along on paper if you wanted to, and we're going to place our eye here. Now the interesting thing with the BSP is, the direction doesn't matter, only the position of the eye. So to draw, the algorithm is pretty straightforward. You walk the tree, and at each node, decide to either draw the left or right child first. So you start at the root. If you're in front of the splitting plane, draw the back of the tree first, then this node, then the front. If you're behind the splitting plane, do the opposite. Then of course you recurse and do the same. So you go through nodes B, C, and D eventually. So that gives you immediately the order B, because that's behind, then A, because that's the node in question. Then you have to draw this subtree. So we recurse, we're in front of C, so we draw behind C, which is nothing. Then we draw C, then we recurse, which just ends up drawing D last. So we get easy back to front order by simply walking the tree. Easy peasy. So they give you quite a lot of advantages, but this isn't quite enough to draw effectively because of one major problem: overdraw. Overdraw is a problem that's still being tackled on modern hardware 30 years later, and in Quake, this was really serious. This was being done in software, and although they did implement a Z buffer, it had a performance impact and was limited to dynamic stuff. In some terrible cases, you may end up drawing and redrawing the same pixels over and over again. You could easily imagine cases where overdraw could be 10x or more. So this was the big problem to be tackled. How do you reduce or even eliminate overdraw? This part in the story was one of the most interesting to me, the sheer number of approaches Carmack took attempting to solve this. He attempted to use a beam tree to track visible fragments, a subdividing raycast approach, almost like binary search raycast, representing the world with planes rather than explicit vertices, a 1-bit draw buffer tracking whether or not a pixel had been drawn yet, rasterizing the polygons into spans and clipping using those, and an approach that involves tracking the portals between leaves and clipping further away geo and portals to those portals. I won't dive into all of them, but let's poke at the first couple of them. The first thing mentioned, the beam tree, is really interesting because finding information online was difficult. References are pretty sparse or result in dead links. There's some scattered references to some papers back in the mid-80s that you can read, which gave me a bit of context, and there's a very brief explanation in the book as well. From what I understand, they're in essence a special type of BSP tree, but instead of being built directly from the polygons of the world, you do something very different. If you're looking out at the world, your camera would be down here, and the viewing volume that you see is formed by 6 planes. You've got your planes on the left and right, you've got your planes on the top and bottom, and you've got your planes on the near and far. Now let's consider a single triangle out here in the world, and we have the camera looking at it. So if you take an edge of that triangle to begin with, and you form a new triangle using those vertices on the edge and the camera's position, from this you can form a plane that passes through the camera and the edges of the triangle, similar to the viewing volume. You can then repeat the process for each edge of the triangle, building another plane that passes through those 2 vertices and the origin. So this is called a beam, this kind of volume that's projected out from the origin to the triangle. And you insert this into the BSP. Not the whole thing, only the planes that you calculated, the side planes. So let's visualize this. So this is our screen, and you'd start the beam tree off by inserting 4 planes representing the bounds of the view frustum, the visible area or the edges of the screen. And you'd end up with a pretty basic tree, kind of similar to what we saw earlier. We'll color the drawable area green, so anything in the drawable area is good to go. So the basic idea is to use this secondary BSP to check what's been drawn on the screen. So let's say I want to draw this triangle here. You can tell from a glance that this whole triangle falls into the drawable area in the beam tree. What would actually happen is that you'd insert this triangle into the beam tree by inserting each of those planes of the triangle, which in 2D basically look like lines. So one by one, those would get inserted into the tree, and you'd end up with a tree more like the one on the right now. Those open leaves of the beam tree correspond to regions that are still drawable, which you can go test on paper if you like, but I'll leave that to you and we'll move on. Let's say now that I want to draw this second triangle. We know just by glancing at this that if we were to walk the BSP tree, we'd end up in this region here in front of F, which corresponds to this leaf on the BSP tree itself. As you prepare to draw this triangle, you walk the beam tree, and if it ends up in a visible area, you'd update the tree and draw the triangle. But if it doesn't, there's no tree changes, and thus the polygon isn't visible. That's my understanding of it anyway. In theory, a great approach, but as Abrash notes, the worst case was still terrible, and maintaining the beam tree wasn't free either. So in the end, they had to scrap the approach. Another interesting approach was to use ray casts, since the BSP is great at accelerating those. So by this point, you should be reasonably familiar with the idea of walking the tree to figure out whether a point is visible or not. It just involves descending and doing the plane tests until one reaches either an empty or a solid leaf. So a raycast isn't really all that different, except you're of course dealing with a line. If you were to say overlay the line over the BSP, you can clearly see where it would get cut by the splitting planes and chopped up. So you'd end up with a bunch of fragments of the original ray, each fragment lying in either a solid or an empty node. Of course, you don't need to chop it by every plane though, that's just wasteful. You can be smart and do the closest section first. You can see this section. If you were to walk it down the tree, it ends up in an empty node, and thus it never hits anything. So we go ahead and process the other side, and this part of the ray of course gets chopped by this plane here. So of course what you'll do is process that part first, so we can clearly see that it'll end up in an empty node, and thus hits nothing. This next part, behind the wall, well, we know that it hits something, like us the viewers, but we need to prove it in code. Well, the next node down the tree is this node here, with this splitting plane, so the ray gets lopped into 2 parts. And we'll take this part here and walk it down the tree, and of course it ends up in a solid node, so we're done. We know for a fact this intersects something. We know where it intersects. We know everything. So if you take a look at an example screen, the subdividing raycast idea, at least in my head given the description, kind of works like this. You divide the screen into some number of areas. They mention using an 8x8 grid, so 64 in total. And for each of those, you cast a ray, using the exact same raycast approach to clip the ray against the BSP. Let's take a look from the side. So here's a side view, here's the camera here, and we'll have some walls here to fill out the scene a little bit. So what you'd do is you'd fire out a bunch of rays at the world, which of course would get clipped against the BSP, as I showed before. Let's assume that every ray hits something, so each of these rays is being extended until they hit a surface. The question would then be, what did they hit? We'll color them with the color of the surface they touched. Now let's focus on these two rays. If two rays are adjacent and hit the same polygon, then you can simply interpolate the surface in between. So that's easy enough. That's a best case scenario. So now if we were to focus on another pair when they don't hit the same surface, so these neighboring raycasts hit different surfaces. So then you in essence have to do a binary search by firing a ray in the middle and repeating the process. Then it kind of follows that eventually, after repeating this process a bunch of times, that either all the adjacent rays will be on the same surface or they'll be at a pixel level, at which point you bail. I could easily imagine this working great in one of those old Quake levels where polys took up a lot of real estate on screen, and chances were pretty good that just a few iterations of this subdivided raycast approach could cover most of the screen. From the sounds of it, this ultimately failed due to dropouts, basically problems with tiny polygons. There were other approaches, as Abrash mentions. Some were merely kind of tossed around, while others saw actual implementations. I'm guessing based on the descriptions that the draw buffer and span buffer approaches, since they seem like iterations on existing techniques, were tried out, as well as the portal clipping, but the vertex-free surfaces idea, maybe that's something they just punted around. Who knows? Here's the point in the story where we have the miraculous turnaround. If this was an episode of House, you'd have him look at a bus going by or a leaf falling or something random and suddenly have an epiphany. According to Abrash, we'll just read his words here. When I came in on Monday, John had the look of a man who had broken through to the other side, and also the look of a man who hadn't had much sleep. And then he goes on to describe how Carmack figured it out. The solution being pre-calculating the visibility between leaves in the BSP. This would be called a PVS, or potentially visible set, which now, nearly 30 years later, how it works is widely known, but was a real game changer in its era. The general idea is that, let's say that we've got our level here. We'll just do a 2D version instead of a 3D version, and let's just quickly understand what we're looking at here. So each of these regions here, let's say these regions are leaves in a BSP. We're taking some liberties here, but let's run with it. Then each of these spaces is separated by these green lines. These would have been splitting planes, and you can figure out that where there's no polygons, these form a sort of border between adjacent spaces that are called portals. So given this shaded region here, of course any region that's immediately adjacent to it is, of course, visible right away. You can figure that out without a lot of effort using the BSP, since they basically share a portal. The trick is whether or not these further away regions are visible from that initial region. I mean, you could do something like cast a zillion rays from one portal to the next and see which other leaves they manage to hit, but that'll be really unreliable. Quake did this by erring on the side of being conservative. Secondary neighbors are usually visible. Not always, but pretty much most of the time. So we'll consider a neighbor of a neighbor to be visible right away. So the effort was mostly on leaves further out than this. The question now is whether or not section 4 here is visible from section 1. The approach they employed was using a separating plane. So they'd create a plane from each edge of the portal to the opposite side of the other portal. Here we have our separator plane, and the portal lies completely in front of it, so it's not eliminated yet. We'll do the separator plane for the other side, and lo and behold, the portal lies completely behind the plane, getting culled out. In a small way, this is just like the beam tree that we just talked about. If we were to say expand section 2 so that the portals end up a bit fatter, you can see that now the separating plane just catches the end of the portal from section 3 to 4, making section 4 visible from section 1. That's the general idea, and it extends pretty easily into 3D from there. In 2D, of course, we only needed the two separating planes, but in 3D, you would do this for each edge. As I said, it's a conservative approach, but works incredibly well. BSPs have since faded from their glory days. You don't really hear much about them anymore. Levels now are dynamic, requiring a degree of flexibility that's necessitated new approaches. The original Quake source code was released over 24 years ago at this point, and that, along with subsequent sequels, have been the source of some incredible gems. Perhaps most infamously, the fast inverse square root function, which is this abomination you see before you. This was a story that, for some reason or other, has stuck with me for over 20 years. I read this at a time when I was still struggling with basic concepts, and it shaped, at least in a small way, how I approach things today. I find that it's really easy to be enamored with a clever solution. I mean, we all appreciate an elegant answer to a problem. But it's also in the failures, the missteps and dead ends along the way, that we can find some really valuable insights. The final solution, at least to me, evolves naturally from the failed attempts that preceded it. Understanding the beam tree, the portal clipping ideas, a lot of the basic ingredients were there. I remember that I had just barely started learning to program and struggled hard with the sparse information Abrash provided. Looking back now, I actually appreciate how it pushed me to work harder, to really strive to understand the underlying concepts. If you think you'd like to learn more about game dev from an experienced graphics engineer, I have a wide variety of courses available, very suitable for beginners. So if, for example, you ever wondered if understanding quaternions was possible, check them out. Otherwise, if you'd still like to support me and help choose what topics I cover next, you can vote on my Patreon page. Cheers.
There we go. That's a really good insight, actually. I was gonna interject saying like, "Wow, isn't John Carmack cool and awesome or whatever?" But really, the team and including John, they spent a long time failing, and I didn't know all that. I mean, I was trying to implement binary spaces, partitioning trees in university. This was like way after they were even used anymore. So I actually tried to do some of the stuff, build that acceleration structure, and even then, that is not a straightforward thing to do when you're not trying to do rendering. So yeah, it's a really good. That was a really good video. I really enjoyed it. Yeah, that was my dissertation as well. It was using binary space partitioning trees for real-time collision detection, which was interesting. It didn't get good marks, really. Mostly because my writing wasn't very good. Yes, building the beveling planes was actually the hardest thing because I had to build up. I had to combine the separating axis theorem with with the binary space partitioning tree. But anyway, I will clean up. I need to clean up, so I'm gonna go and clean up, guys, and I'll be right back. I hope you enjoyed that video. I know I did. The other thing I need to do is make sure that you guys don't get blasted with some audio. So yeah, I'm just gonna make sure all the dishes are basically in an appropriate place, so I don't have to get covered in food trying to code or something silly. All right, and be right back. Okay. What? Oops. What I'm gonna do is clean up my shader code. So if I look at what, so I'm gonna go back to development. So if I look back at what we got, let's just have a look. Oh, I need to start some music, real quick. Let's just see how that loud that is. That's fine. I'll put it there. Let me know if it's too loud or you want it quieter. Anyway, so we have a super aggressive. What is it called? Torch, which is like super bright. Mostly because things get so far away that we need like that level of yeah. So what I'm gonna do is just make sure this is like, make sure this is like exactly how I want it, and then write this into a function, and we'll go from there after that. I think because what I need to do is, what I'm gonna do is like wrap all this into one function, and just say for now. This is enough, right? I'll throw this, and this in, you know, like pi. You know, these two will be fine. I just need to make sure that this radiance is this is good. Like that, yeah. That's effectively what I need. Probably because of that, I could probably turn down the intensity. Probably not by much. I'm going to change this to like 9. Because I want it like further distance, but not as blinding when you get close to stuff. Yeah, something like this. Again, I can always mess around with the values, but effectively you just need to be able to see what's in front of you. And I don't think it matters too much if you get like really close and it's like blown out like super white. Because, you know, I bet you the player won't be able to go through this rock. I can, because I've got the non-play camera. I've got the no-clip camera. Which, right. So yeah, what I'm going to do is throw these two into a function. And everything, I think, the other thing I want to do actually is the attenuation function, I think. So I'm tempted, honestly, to throw out this, because I have a feeling that we don't need it. What we need is, and we don't need these two either. We're going to have this here. What I want is this function to be renamed Spotlight, and then we can just like deal with that. Maybe that's a bad idea, but I don't know. It just feels like this is a spotlight, and you just have both. Like this, for example. Like this is a spotlight. Like 9,000% this is a spotlight. And all it's doing is just following my location. So what I'm going to do is get squared fall off attenuation. I'm just going to rename this function. We do have directional light as well. And then I think what I'm going to have to do, guys, is I'm going to have to make a second scene which uses Intel sponsor. Not Intel sponsor, Crytek sponsor. Just because the next section of lights are photometric lights. And you can see how these work, right? They're doing a lot more than I think my scene is going to be able to handle. And effectively, I just need to be able to... Oh, it's just an extra function. Interesting. Yeah. And then we can go back into the theory, and then I can really get into this. If you know what I'm saying, right? So, and then, yeah, because I really want to get to image-based lighting, which is a big deal. And obviously, after that, it's after image-based lighting, the problem is I need to be able to answer the question, what are you working on, streamer? If I just say I'm working on a space game without being able to show it, that's not very good, is it? Let me think. Okay, so this is the multi-scattering thing. There's some stuff I will never need. In this, so I'm just scrolling around to see what I need and what I don't need. Let's get a study for a minute. But effectively, yes, we need to have a scene. What do we want to do? It is weird that it's got normal mapping, like 5.7, like multiple layers down. Yeah, because I would like to have volumetric effects as well. But I don't know if I'm just going down a rabbit hole here. I've just got to be careful. So that's why I'm just taking my time. Because I don't have any post-processing effects. I don't have. This is a big one. What I want to do is clustered forward rendering. But I want maybe not that. I want to do clustered lighting with a G buffer. I'm not entirely sure if that's. This is a Crytek sponsor, by the way. So this is what we need. We need like a more. So I think at some point in the future we're going to have to move to something else. Or at least figure out if this is actually going to be useful. Anyway. Just scroll through. I don't think we need any of this though. It's just references this, I think. Yeah, okay. Yeah, because I need to know like lookup values for maybe like lookup tables. Sorry, I know I really should be typing out the code, but I don't know how far down the rabbit hole I should go with this. Let's scroll back up anyway. Yeah, because we have some simplifying the BRDF integration. Have we already done this? Anyway, I guess not. All right. Alright, scroll back up, scroll back up. I think color temperature is probably just more light theory. I might just read that out loud. But yeah, I think photometric lighting is going to be useful, and which just seems to be applied on top of our spotlight, which may or may not be useful in the long run, but I don't think it's going to be that much more complicated. Considering it just seems to be a bunch of like ways to mess around with a spotlight effectively. Punctual lights are extremely practical. Yeah, okay, so right, let's just make sure I'm happy with this. Am I happy with this? Yeah, I think this will do for now. Yeah, because this eventually will be. Let me zoom out. I put everything really close together on purpose here. So what I want is not scene radius. We want not debug scene. Yeah, this, right. This is what it was. Oops. Let's just have a look how this looks. Okay, this is bigger than I thought. Bigger than I remember. Was it really? Was it 1,000 or 2? I can't remember. Oh, it's 2K. Yeah, it's definitely 2K. So yeah, you're flying around. Yep. Do you see how noticeable everything is in the black? Yeah, in the worst case scenario. Yeah, it's incredibly obvious if it's right in front of you. I mean, you can't see that far ahead, but what I don't want you to be able to do is like crash into something you can't see or react too slow. I'm going very quick as well. I don't know how fast I'm going to let you go. But yeah, it's I don't think many things are going to be surprising. I'm going to be like, oh, what? I couldn't see. Unless we'll have directional light as well, just for people who are wondering. Like we'll have both. I just can't do both yet because I haven't finished the lighting yet. So we'll have something like this on top of the scene. So if I throw in the directional lights, I need the arguments really. I am kind of curious if I can just stack them, because that would be kind of interesting. This is like the super easiest function to do. This is just an arbitrary light direction, which will be like 1.0, 2.0, 3.0, doesn't really matter. The normal is N, and the light intensity is what you've been getting used to, which is the insane value that is that. As far as oops, what am I doing? Nope, stop that. Light, directional light. Now, if I do this twice and then add them together, is that how it works? Because you can add lights, right? So if I actually, it's going to be a bit. That's fine. Yeah, linearly add lights, because lights is, you can add lights linearly. I don't know if it literally means addition though. Okay, so the intensity is way too high for that. Let's turn that down. Where's the intensity? So that would be 1,000 maybe? Yeah. It's even less, I think. Maybe like 100, an order of magnitude less again. Yeah. So yeah, we can just add lights together. Let's do the reverse in the Z. They can multiply the color as well. I might change the color. Yeah. So yeah, we have directional lights. Okay, it's a bit dark actually. Let's turn up the intensity a little bit. Let's double it. Yep. Okay. It's still too dark. I don't know. Maybe I was right with 1,000. I kind of went too dark. I don't know. Yeah, I'll multiply a color as well, so it's like not complete white. No, it's too bright now. But then again, it's so dark the other direction, but I don't know what you expect here. I think what I need is a directional light facing the nebula. So like something like that. Then I can reduce this down to like 200 and then multiply this by, I don't know, some vec3 0. I need like if I go into, what's the color of the sun? What is the color of the sun? Yeah, but what I'm looking for is like it. Is it literally just not yellow? It's just white. Yeah, what? This might be like I don't know anything about science 101. Oh, go away, stupid thing. So it lights things up as white. It looks like. Right, that's fine. Fair enough. I'm still gonna change the color a little bit because I like let's open up GIMP and let's see. I'm gonna pick something that's a bit like kind of like this, like not a quite like a light orangey, just to kind of match the background. Yeah, something like washed out. Yeah, okay, so I'm going to go with, what, 100 reds. So that'd be 1 dot. What have we got? We got... completely forgot. 0.68. 86 even. And 64. Something like that, you know, not quite white. Did the multiplication in the wrong place. It's easily moved. All right. Let's see. Okay, so yeah, it's kind of good. Yeah, still I need the I need it black facing that way. That'd be perfect. I don't know what direction that is. Just as long as it's not for the most part I want it to be visible. Even in the darkest direction. No. No, whatever. It's not the end of the world. Yeah. Because we got like a good... we just have a really strong... Oh, there we go. That's fine. There's just no rocks in this direction. Yeah, I just need a stronger... more intense plus yeah, so even if we head off in the dark direction, I don't want things to get too bright, if that makes sense. Like I don't want it to be like "Roar," like everything's like hyper exposed. But yeah, I think it's generally okay. Yeah, because even this rock here that we couldn't see very well. Yeah, I don't think it's that bad. Alright. Yeah. And then, you know, obviously this is the way it's lit. Yeah. I think it's fine. Alright. Let's see. So we got some brightness down here, hang on. This one I'm worried about, you see, I don't want it too bright, so it's just like overblown. Hang on. I'm going to go with just lowering this by 50, just to see if that happens again. Okay, so I was like, where was that? They'll always be roughly in the same direction because the directional light hasn't changed. Yeah, I don't mind that like level of glintiness, but kind of looks weird. That looks like kind of looks like bird poo on an asteroid or something. It's just like too white. But I don't know. These aren't my final models. Well, I don't know if there will be or not. But yeah. All right. Oh yeah, here they are. Yeah, let's lower the intensity down. Another 100. I've increased the spotlight strength anyway, so even if we're like I said, flying in this direction and something's in the way, which it really almost never is. Yeah, so yeah, you can see that rock way before it becomes an issue. So yeah, I think that's generally good. I don't mind the temporal weirds. It just suggests that they've got a bunch of ice on them, which I'm fine with, to be honest. All right. What we need to do now is, I'm happy with the lighting so far. We have directional light, we have a spotlight, which was the biggest issue. We needed something for the player to see things in without crashing. Next is to make it so... Yeah, I think I might have to put the spotlight offset of a particular value. Because the problem is right now, anyway... yeah, the image-based lighting isn't in the scene. There's a lot of things isn't in the scene, but I also need to be careful what I work on. So I'm just trying to think what I should do and what I shouldn't do. This is important. Yeah, I was talking about, is ray tracing important earlier? Before I went on a break. And I watched a cool vid by Simon Dev. Should you do ray tracing? Well, now this is how I decide not to do ray tracing, right? Is it important for me right now? No. So I don't touch it. Is it important in the industry as a whole? Yes. For what techniques and how future-proof is it? I don't know. Is it going to get more important? Probably, right? But my goal is to try and get this in the hands of you guys. Obviously, it's not very fun right now. But yeah, it's this is the goal. And I don't know. I think adding photometric lights is not going to be that difficult at all. I'm just going to scroll through and just kind of see a little bit. I think I just need to make notes on this. We don't have area lights, sadly, documented here. We have color temperature, which is fine. Interesting. Is that really like the temperature or something? Like as it gets hotter and hotter? Like literally the temperature? Anyway. But then we have a bunch of like stuff I don't really think's necessary. A lot of the stuff I'm going to do is like going to be vibes based, where it's just going to be like, does it look nice? Okay, that's fine. I'm not going to be like, well, it needs to have perfect lighting, color lighting, otherwise it can't represent a flame properly. And image-based lighting, hang on, let's just see how in depth this goes. So I do really need this kind of stuff at some point, but let me just see. How far does this go? So I believe this is probably for see, I'm not entirely sure what's going on here, to be honest. Discrete domains. Is this image-based lighting still? I guess it is. Yeah, so Is this image-based lighting? No. Oh, maybe it is. Pre-integrate for multi-scattering. And okay, so I'm just seeing what I do and don't want. Summary. Clear coat, definitely not. Anisotropic, no. Okay, so there's a couple of things I don't care about at all, which is cloth, anisotropic, and so all I want to do is I'm targeting the regular BRDF. So those three other BRDFs that I don't care about, we're not going to implement. We're not going to do anything clear coats. Obviously, it would be nice to have, but yeah, okay, so we have MIP maps apparently. Specular BRDF. Okay, so we have. I wonder how you build this up. I actually don't know. Sorry, I'm being a bit scrolly and not committing to anything. I think. Okay, so again, I've just got to be careful here what I actually do. Like, obviously this would be good to know, but I just want to make sure if this is the actual relevant stuff. So we have a lot to go through here, and we have lots to test and lots to fix. The reason I'm like stalling and not just jumping into it is I've got to figure out exactly if I want to do this, right? Like, do I need to do this? Is the big question. Because you know, as someone who's making their own tech, one of the big benefits of making your own tech is that you can you know, cut corners, to implement stuff you don't do or do not want. And the problem is, you know, if I start implementing stuff I don't need, then I'm just going to waste my time. Because there's a big problem at the moment with my engine. Outside of a lot of different things, like there's no gameplay and there's no 2D renderer. Obviously, these things can be fixed with time, but it's like, what's the priority here? Do I want to make the lighting so good that, you know, you all want to play it? Like, let's just say hypothetically you're interested, or should I do something else? Instead of like working on image-based lighting, which will take like a couple of weeks probably. I don't know. Now the obvious solution is just work harder, bro, and you'll solve all your problems. But you know, it's I don't know. Like I need to like figure out like how far ahead should I get, because I've got, lighting wise, I've got the absolute fundamentals in. The absolute fundamentals that I needed, no matter what, was a spotlight and was a directional light. I needed both. Now I don't necessarily need indirect lighting. Image-based lighting. Image-based lighting just makes the scene fit nicer. You know. So, you know, when you're flying around, it kind of, everything kind of fits in. But, you know, I could pretty much do that myself by just adding the, like, changing the directional light color. You know? So, I don't know. what to do at the moment. All right, let's write down a list. I think I've got like I think I've got like a list of things that I need to do. Okay, so I usually no, let's not do that. Let's go my obsidian, and I do have a list. Let's think about this properly. I can't quite decide yet. You see, how much more lighting I should add. Now, obviously, I would like to have nice lighting, but should I work on the lighting after I've done this entity interaction? I fixed this. Everything is now not too dark, in theory, right? So I don't need to worry about this anymore. Now I need to think about the minimal viable product, get out the door. I also need to consider how... Yep. Okay, so the two major ones are... I started this when I realized there's other things I need to do. 2D renderer, which is its own thing. And we also need hit. After that, we need hit detection for 2D stuff.
Oh, excuse me.
So yeah, we need 2D mouse hit detection. And oops, let's put that back. More entity interaction, for example, if you crash into something, something needs to happen. Alright. Alright, so what I'm going to do actually is... I'm going to ignore lighting for now. Now, I originally had this idea of doing, like, really nice lighting effects. But I think the lighting effects can be added after the fact. If I have a spotlight and a directional light in the scene, I have enough. It's not obviously ideal, but I've got to be careful here of what I implement. So... the player needs to die/win. So I don't know what the game is even going to be, honestly. Gameplay wise, but I don't think it's going to be that complicated. Like, I might want to use particles. Like, do we need particle? Needs particles, like, for point hit detection, point collision detection. Detection. Okay, so I feel like this is more important than a 2D stuff, so I'm gonna put it above. The reason is, yes, 2D is important, but oh no. Like, let's just say you played a game, right, and it didn't have any menus, but the game is still good. It would still be fine, right? I need to think about the MVP. Yeah, I am currently at the moment. Yeah, and then how to release the game at the end of the day. Okay, so this I feel like is more important. It's currently half finished, and that's why I haven't pushed it to Linux in a while, and that's why the master branch is so far behind. It's because this is halfway through being written. And unfortunately, there is no, like, how to do an entity system without without you know, looking at other people's code when they often do it. Other people's engines. I'm not saying anyone's in particular, or yours, whoever may be watching. Like, they use ent and other entity component systems which are overkill. I don't need that level of support for the entity component system. And I don't want to use a library for this. Not because I need to invent an entity component system. It's more, they're too complicated and they do too much stuff that I do not want. Okay, so there's like 1,000 things to do, obviously, but yeah, I don't know. But this is the thing about doing something live. I've for like X amount, a lot of hours per day. I've also got a plan live. Okay. Yeah. Alright, so what we're going to do then is finish off what we were doing. The first thing I probably want to... oh, I haven't even done what I said I was going to do in the shader. Alright, let's commit this first. So this all needs to be in its own function for spotlights. And for now, I'm kind of happy with it. I can mess around with it later. We have a point light. We have a spotlight. I'll learn to do light clustering in a different day. And implement different things. So what do we need here? We need L, which would be the vec3 L, or L in this case, capital. Excuse me. And I am going to take the light intensity as well. Okay, so I'm going to take all this. All this out. And throw this in here. Obviously this is all kind of just... I'm just throwing it all together. Because I just want to be able to get the... I can do float attunement and then... attain. Okay, oops. Let's get this in here. What are we on, dev? Yep. We're still timing ourselves. Okay, so n.l. Do we need that? We even need L. Hang on. No, we just need n.l. And okay, so what's this used for? Oh, it's not used at all. We actually just need L. Actually, no, we don't. We just need to say this is vec3 L. Actually, what do we need to pass it in here? Oh, I think we might be good. Obviously, a lot of this is just thrown here. So that is what I want to do. We'll see if this compiles. Right, I'm going to get rid of this because that didn't ever really look nice. And I'm going to kind of comment here and say lights. So we do BRDF for both. Then we add them together. I feel like our music stopped. Okay. So let's build that. And we are missing lighting. It's undeclared. Where's that? Oh, yes. And this is called Spotlight. Spotlight. Intensity. 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 Alright, so let's give that a go. N.L N.L Yep, that's basically the same. Okay, I think that's good. I think we've got a nice... I'm gonna keep my BRDF, sorry, my old shader around because it's fine. It has a couple more extra things that mine doesn't at the moment, so I'm not completely done with this because we don't have admissive and stuff like that added. When I did that, actually got worse, the lighting. Like if I added the occlusion in, hang on. I think I did this and it didn't work, hang on. Right, I think I'm going to change the music. Okay, let's change the music. And... okay, so material lights. I think if I did this both for so again, this is really inefficient, obviously. Let's see if I can just hang on. No, we need the occlusion. So that's the intensity with the BRDF, so... And then emissive. So this will be Vec 3. Okay, material and material 1. Okay, so now we have emissive and we have emissive textures being used, which these rocks do have. I don't quite understand why, but and occlusion. Actually, this was really better. This is a lot nicer. Alright, cool. Right, I will commit that, and if I hate it, I'll rip it out later. I'm sure you can combine them rather than just doing 2 mixes, but whatever. I'm not that fussed right now. So let's commit this. So yeah, if you want to see my project, it's definitely... Hang on, just make sure everything's good. I just make sure other stuff that I... So we have specular factor, which we never use. We have IR. Alright, whatever. It's not that much of a big deal. We have a... What? Oh, specular sphere, yes. Yeah, collision shape. I think we just cleaned up everything here by moving it out, which is good. We don't delete things, I don't think, correctly. But it's fine. This is what probably going to work on next is... I need to make this into a game. Surprisingly. I can't just make... Yes, it kind of does stuff, but it's like... There's nothing to play, if that makes sense. My engine is facilitating some stuff, but it's... I don't think I need this, to be honest. I'm going to remove asteroids. This was never, like, necessary. Let's close these. They basically had nothing in them. So... And it just slowed down allocation because I was allocating like 4 bytes 4,444 times. So it just made like load time take a good amount of time longer. Because I was doing heap allocation. Where's the source game? There it is. Oh yeah, okay, so deletion. We shall clean that up. Alright, so what I'm going to do is try and get rid of this crash on close and then try and commit this. Because it's kind of rubbish to have a crash on close and then just leave it, you know. So, yes, that's the next thing. Okay, asteroid does not appear, that's fine. So, we have a crash on close right now, which we're going to get rid of. Not crash and close, it's failed to delete on close, so oh dear. There's now an AI button. Fantastic. Man, this is so cocked, this program. Okay, so physics shut down. Oh, hang on. Why was the breakpoint not triggered? I have a feeling that we're not. Where's physics? This might be a really simple fix then. Yeah, I'll delete it here maybe. After this, physics. What's the physics called? Hang on. The physics has got to be here somewhere. Oh, hang on. Yeah, of course. In instance shut down. Let's see if this works. Yep, get rid of this. A couple of things that I don't need. So yeah, there's a... My engine has got quite convoluted, so I might end up moving some things around and trying to like simplify things before we do anything else. I don't know yet, so... but yes, removing some unused variables is a good idea before we commit. Right, so let's see. Yes, that's good. Cool. Now let's do that properly. Nice. That was good. That was just an annoying bug. Now I can actually press the X button without feeling fear. Alright, good status. Again, this project is in the description of the video. It's currently in the scene space branch. To see these changes, I'm in the Japanese keyboard. Alright. Added a spotlight, point light, and directional light. Began work on deleting objects. Oh, you know what I'm going to do actually before I finish committing? I am going to get the player up and running again. Because I need to see that player move. So if I go to game, what I want to see is where are we? I think I had it in here, didn't I? Player. Oh no, this. Bum, 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 bum. Update. Let's make sure this is never ran anywhere else. Oh, it already is. Alright, let's not do that then. So I'm going to play updated and there. And that means, yep. So we want to do this, and we should now hopefully get the player doing its own thing. Yep. Okay. So, whoa, 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 whoa! It's a bit sensitive for some reason. Oh wow, this is weird. I wonder what's happening here. I think there's more going on behind the scenes. It might be, oh, you might be updating too much, I don't know. No, it should happen every single frame. The other thing I might do is take out... Yeah, so I think I'm going to commit this. And then the first thing I'm going to try and do is fix the player movement a bit. Because it's a bit all over the place. So let's just check the physics works just real quick. I didn't... Oh, no, we already did that. We already did that, so that doesn't need to be done. Yes, okay, so... we have some player stuff here. Oh, yeah. I guess I'll push this as well. Fixed. You know what? I won't do that. I think I've got a better idea. So guts. That is too big. Commit, and what we're going to do is, yes, say we added a spotlight, point light, and directional light. Also began work on adding a way to delete things from the scene at runtime. Alright, so yes. Lots of code change there. Okay. So I'm going to take 5 minutes. Well, not 5 minutes. I don't know how long it is, but considering we're not working on this anymore, I want to split this up into little notes before we continue, because we did do a bunch of work on this morning. So let's change this to okay. So that wasn't study. No, whatever. It's fine. I really should have been on the other one. So measuring. Light, unit, measuring, basics. Okay, so we do this. Light theory, it's fine. So I think I've pretty much gone over these enough that I don't need to be that careful. So what I need is to get rid of this, graphics theory. Okay, so that still needs to be written. Okay. So I'm going to add my notes. So filament, lighting PVR, and we have lighting unit basics. That definitely needs to be connected. I think it already is. But oops, wrong way around. So yeah, I'm just going to take a break from lighting. Right, let's connect. So what I'm doing here is just making sure my notes are all easily findable and connected to each other. And I'm not oh dear, I've implemented this twice. Light unit basics, lighting basics. Okay, so it's referring to it. So I'm going to delete this. I didn't know I had done this. Yeah, so yeah, get rid of this. Okay. Punctual lights. Oh, okay. So I'm going to change this to... Oh, I should have done the other round. Where was it? Ah. Okay. Cool. Fantastic. Let's connect these together. Or write them in. Punctuates. So this needs to have the... No. Graphics theory and light theory and this needs likely definitely this. All my light theory needs these because they're flipping annoying to remember. And filament materials. Alright, so this is going to have a load of connections in it. I think what I'm going to do here is do this type of thing. I'm going to spread them out for now, but then yeah, because there's lots to do. Point light theory. Because there's more eventually I'm going to add to this outside of just the two basic lights I've got. Point lights. Literally just that, because I don't really know what else to call it. And I'm going to not use that anymore. I'm going to use my version, which is here. Okay. And then we're going to connect that to the thing we just did. And the filament thing. Now I think this is light. We need the light units in here as well. Yeah. Alright. And you certainly need to be... Oh, I haven't done this bit yet. Need to be able to find it in the future. Light theory. Let's throw this in here. Graphics theory. And... Okay. And that's fine. Next is... Feels like I did more of this. I feel... This is more than... I need to write a note to myself here. So we... Yes. I expand this a little bit, actually. Because I discovered something while editing the source code. To... correctly... Could split this up a little bit. I'll have to see anyway. Work with spotlights. You need to surround your point spotlight in a point light. Hence the sphere of influence. Cool. Which is found in the attunement. Yeah, I'm going to change the music after this. Attenuation function. Oh, what is wrong with the YouTube today? It's very much repeating the playlist extremely often. Okay, so spotlight. So we have spotlight. It's not really theory. Is this a note that exists? Oh, I see. I'll change this in a minute. Because we do have... I mean, we could separate out the source code, but... if I'm going to read this theory, I might as well just have the... it's not that long. It's just under the recommended amount of 500 words. Well, limit yourself to 500 words. Oh, I'm an idiot. This would be point lights. There we go. That fixes that. So we need light, unit basics, point lights, and what else? Some point lights. Yeah, oh yeah, punctual light, of course. Do-do-do-do. Okay, so filaments. Lighting. Attenuation function is after this. Graphics theory. Light theory. Cool. Go. Next is this. Done. Then we need the attenuation function, which is just a sphere of influence, effectively. No. Light theory. And then we need the filaments. Whoops. Grab that. Put that in here. We getting better. Okay. So you need the... oh no. You don't need that. We need spotlights to connect to attenuation function. What I'm going to do is change this a little bit. Where do I put this? I've forgotten. Oops. Bar like that. Yep. It's after. And you need to have spotlights. Just change this to not theory. Changes to the... I like that better. The point lights. Punctuation light, punctual theory and light unit basics. Nope. Yes. All right. Get this. This is done, right? It's in there already. Yep. Alright, so you need spotlight, the spotlight, and you need this fella. And you need all of them. So you're referenced everywhere. The point light, the spotlight, done. Yep. Okay. Sorry, I haven't changed them. Why is it going back to this again? We've had Evil Destroy. Move on. Okay, so what else we got? When we are working with, yeah, I just need the punctual light theory here. No. Where is that? Oh, I don't think I have directional lights, do I? Boo. So the directional light. Yeah, still not done. Gotta split this up if we're taking a break. Unfortunately, it's just how it has to be. Whoops. In fact, I'm gonna make the other one as well because the other one is needed. The basic ideas in general of direct lighting. Oof, come on. Okay, I'll just copy that as well. Oh. I will say theory though, because this is theory. Pure. Okay, so make this baby because it's new. And light theory and filament lighting and okay, so measurements. You can find it very easily by this thing. And I'm going to link you directly to this thing I'm writing. The thing that I don't quite understand about this rendering equation function, which I found in the offline, when I was studying offline ray tracing, is we have kind of two functions here that do seemingly two different things, but both handle specular light. The BSDF, this thing, and the light incidence function. And light emitted radius is what I'm confused with is what if I was to map this onto ray tracing? Sorry, not ray tracing, but onto point lights and specular lights. Which function? Which of these two? So this one, LE, or this one, LI. Which one of these two? Which one of these two is like actually don't know. I will just leave it here as like a loose connection to like, because I want to move on, because I'm not entirely. I need to do a bit of research on this and stretch my legs. Oh my goodness, I don't know what it is around this time of day. I get very tired very quickly. I'm gonna say warning. Incomplete. That connection needs to be there, and I don't know how to make it yet. So I'm gonna throw this in kind of like, oops. Kind of like here. Kind of like, just so I don't lose it. And yeah. Alright. So let's get this one all hooked up to things. Direct lighting. Oh, I did it again, spelled lighting wrong. So obviously you connect to here. And yeah, you connect to this. No, actually you don't. You don't connect to this. You got no light units in you. Oh no, you do. I just realised. E is luminance power, right? Yeah, illuminance. Yeah, so we need to do something a bit more in my wheelhouse for a bit. Otherwise I'll go around in circles for a while. Anyway, so we want direct light theory, not directional light. Nope. The directional lights, which is the easiest light to write. This just needs to be connected to things, which is fine. You definitely need to be connected to directional lighting. The direction, yes, the spotlights, the point lights, and the direction, not direction light. Directional light, alright. Light theory, okay. Okay. I'll just push over to the point light so it's just easy to get to somewhere else from here. Although it's not exactly related 100%. Cool. Done that. Directional lights, direct lights in theory. Let's just see actually. Do I have these in? Direct lights, directional lights, punctual light theory. The spotlights. Oh, and the attain. Oh dear, what's this? Oh, a bad link somewhere. Attune. Cool. So I'll keep them separate now, but because I think there's going to be more of these direct lights. Yeah, what I think I might categorize them all under is direct lights, but maybe for now I'll leave them kind of in a pseudo group. The directional lights. Okay. Okay, it looks good. Good. Let's just see we got everything. So we got direct lights, directional lights. Did I get that there? Oh, direct lighting theory. Yeah, directional light. Punctual lights theory, point lights, spotlights. Okay, fantastic. Okay, so the reason I wanted to do that is because I can push up this and say, you know, all my work that we did earlier on today is now on the internet. So we have added all the super basic lighting. I did it again. Types. Right, that was nice. Push. So for some people who are interested in my notes, I guess I should kind of keep this up to date and stuff. And right, okay, next is, so we did that. We pushed everything up. What's next? Oh yeah, so we got to fix the player next. So let's just see how this like looks. Now obviously the duck is not going to be the final thing. Oh no, a rock. Yeah, you have plenty of time to move out the way. But I think what might F you up is if you do something like this. Kind of like go, or berm. But you know, it's not the end of the world. Do we have a memory leak? Why is it allocating stuff? Oh dear. Yeah, we just allocated some stuff on collision. What the heck? What are we allocating as well? It's like random. Whoa, that's pretty big. Oh, okay. Okay. Something has been added to a array / vector here. I don't know what it is. Right, okay, so we're trying to... I know what that is, okay. Okay, that's the thing we're going to be working on in a minute. We're actually going to get this queue to do something. Because as of right now, at least... Just make sure we're still good. Yep. As of right now, at least... yeah, we need to be able to do something. We need to fix the player's movement. So let's write this down in our list of things that we have. So go to streamer stuff. So fix player's movement. This is less important. So maybe less important than UI. 2D renderer. Alright, I'm just going to head to the loo again. Apologies. So yeah, we're going to work on deleting stuff or having a loss condition, basically, when we crash, without destroying the physics engine. The physics engine is multi-threaded, so we've got to be careful of that. Oh, hello. Oh my goodness. I did not notice the chat. I'm so sorry, guys. I just noticed that the chat wasn't in How's it going, guys? Sorry, I completely missed. I thought I thought no one was talking to me. I was like, what is going on? I apologize, guys. Emmanuel, Mieng, CM, Matt, game file, Kalia. So okay, so I missed everyone up to. Man, have a nice session. Sorry about that, guys. Hello. Sorry, what ended up happening is I refreshed the browser and I only went in top chat, right? If I go into top chat, I don't see everyone's chat, and I've just missed a bunch of people. So I do apologize for missing you. That's my fault. I didn't realize the chat was. I thought I literally thought the chat was a. What lighting model do you use if in my game it can be cartoony? You've improved it. Oh, thanks, Matt. Thanks you for being nice and saying I improved it. Yeah, I apologize. I apologize for. Hey, man. E Drift. How you doing, dude? Yeah. So I apologize for messing up the chat there and having it. Yeah, I was wondering. I'm not a big streamer, so I'm not used to the. I sometimes expect the chat not to move. That's why I was like, oh, okay, maybe it's fine. But then I realized it was on top chat, so I do apologize for that, guys. So I am going to pause that for a minute, and so yes, do a missive at the end. Let's do that. Ratchet has pointed out something in chat, which was nice. My bad. So you're right. That is an obvious oversight there. I just realised I made a mistake on. I don't need to do a missive twice. I can literally just add it here. Yes, that is a better move instead of gets rid of an addition. And it is a missive 3, vec 3. Okay, that's fine. Okay, so okay, if this is going to be happening, then this unfortunately. Okay, so this is a bit convoluted, so I'm going to pull this out. We might do a quick push again just to deal with this briefly. So vec 3 final color. Yeah, again, I feel pretty bad for not noticing my chat was not moving. It's all fixed now. But I might be too late, too little, too late. Who knows? Let's throw this into here, and syntax error. Where? 342. What is wrong with this? Oh, too many of these. That's why. That's what it is. Okay. So that should hopefully. Yep. Okay. We still have lighting. Turn off the lighting. We have a spotlight, so you can actually see where you're going. If you're going towards a dark area. Well, you can see very clearly that way, but you can't really see clearly this way. So, yep, that's good. That's good. Okay. Yeah, I'll just type in the chat, just in case people have got me on mute. Sorry, guys. I
lost the chat and I didn't realize. Right, so it is back now. Okay, cool. Don't need to say anything else. Cool. Nice. Okay. Done that. We will deal with the rest later. Let's do a quick push because yes, that emissive does not need to be added multiple times. And that was a bit of an oversight there. Right. Git status. Git add. I stopped adding emissive twice. Okay. Quick push. And kind of made it a bit more clear as well. But that's generally what we want to do. Okay, so I'm going to actually go to the loo like I said I would. So, BRB guys, appreciate you all. Thank you for sticking with me, even despite me forgetting about the chat. But yeah, I'll be right back for more coding. All right. Okay, yep, 10 off ages ago. Fantastic. Okay, cool. Alrighty, we're back. For real this time. Right, let's see. Okay, let's drink some water. And let's have a think. Okay, yeah, just sorting something else out. Real good. Okay, fantastic. Right. Okay. What are we gonna do? So we have this. Now we need to work on the next step, which was I couldn't commit this to master or start testing this on Linux, despite all the graphics updates, I guess. There's one major issue, which I've been neglecting since I wanted to do the lighting next, because it was that to me was more important, because if you can't see what you're doing, it doesn't matter what the game is doing, you know. But at the very least now we can see what we're doing, which is good. Again, it's not ideal. There's a lot of things that I could fix when it comes to lighting and all that kind of stuff, but what am I doing? I want to go to game. Oh, excuse me. Okay. We have what are we doing? Okay, so we have a deletion function at the bottom of here, which never gets triggered. And that's the first thing I need to fix. Along with maybe deletion of textures or something like that. So if the size is greater than 1, but this apparently is never true. And it might be because of singleton. Sorry. Okay, so in theory it should fill up as we add something to this. Yeah, okay, so there's a lot of additions adding to the engine there. But for some reason this queue is not the same as the one I'm accessing in the physics engine, I think. So I think it's just an object thing where there's some kind of issue with the objectness. Okay. So I put a breakpoint here and a breakpoint here. We definitely trigger this. Good. Okay. So that's the first thing that happens. This definitely gets appended. So this has a size of 1. And if I go to my game here and then allow this to continue to here. Oh, interesting. Disable. No, that's fine. This is uninitialized and it doesn't. Okay, so we're not referring to the same thing at all. Let's have a look. Let's have a look at different. Oops. Nope. Still want to see that. Thank you. Right. So we have game. Yeah, a bunch of stuff in here. And yeah, we have shutdown, we have initialize. So I think we're supposed to be using the same thing. There's the definition at least. But definition, no, we're not accessing the same thing. I think what's getting happened is we're getting a copy in each translation unit. I think that's generally how this works. I don't know why I did this at the time. Oh my goodness, excuse me. Considering if I just want a global state, I could literally just we could just literally write a deletion function within the physics here, right? We'll have to see if it's the same object still. I think it is if it's in the same. Yeah, if it's in here. Let's put this back. I think this is just a problem of bad global data, right? So what I'm going to do is take this out because I don't really see the point of it being in here anyway. And hang on. See where everything's defined. Where are you defined? You're in scene. Yeah, I like I said, I don't. If I can get away with putting this into physics, then this like solves like lots of problems. So what I'm gonna do is throw it in. I'm a bit paranoid about the chat now. If let me know if it's the chat's still working, guys. If anyone's watching who's just you know, who's willing to let me know, just let me know if it's working or not. If not, like pester me on Discord, and I'll try and fix it. I think it's working, but I just want to make sure for sure. Let's see what's missing. We don't want game, obviously. I won't put this in the header file because Yeah. Okay, so we don't have scene, which is easily... We don't have elements. And... Ah, right, the positional buffer. Yeah, okay, so... That's the reason we did this, because we need to delete something out of that positional buffer at the right time, because we recreate the buffer. Okay, that's not too hard to fix. That's just going to be separating these things out into two different functions and returning true every time we delete it. Yep, okay, so if... Okay, so we return true here. Or return false. And I'm going to set into Boolean. What we're going to do is, for the physics engine, every time we delete something, we are going to go into game, right? And every time we see this guy, we're not going to do that anymore. I want to say, well, we are, but I might change this into a function call. I'm starting to get sick of typing this out, to be honest. I might start might break my own, like, to delete. Ah, right, okay, so yes, that does need to, okay, well, Q. Okay, so I'll write a different function, like, is empty. Then do a equal to false. And then we want to do this. There. Alright. Oh, not instance. Whoops. Ah! Go back. Okay, there we go. Now we just need to implement that, which is quite easy to do. In fact, we don't need this anymore. This can be void. Simplify the function, I guess. So we get rid of these and this, and what we're going to do is just say bool is empty if const return if 2 delete q size is greater than 0. If it's greater than 0, then no, other way around. If size is less than or equal to 0, then it is true, then it is empty. Else, it is not empty. Okay, so now we need... I really hope that this is going to cause... scene might cause an issue. So, I don't want this here anymore. I want this in... the physics... Oh, hang on. God dang it. It needs to be in 2 classes. Fantastic. How annoying. Okay, so it's not too important that this be actually in physics, really. If I just have a way of accessing contact listener, my contact listener, which is going to be different, then we can make a different function, right? So this has a to delete q, which is an array. Array What was even in it? I think it was an entity. Or is it a uint 32? I think it was uint 32. Oh, poop. I don't have the music playing either. Alright, cool. Yes. Let's go live chat on here. Cool. Let me check. Hi Ratchet. Are you letting me check about the... Thank you for checking my... seeing if my chat's working. Thank you. Sorry about that. Junker is behind you. Oh no. Validation error. A life validation error. Damn. Well, you probably heard what I did wrong. I messed up the... I was on top chats, not live chat. And that somehow means that I can't see anyone's chat. And that's the default as well. It's very strange. Anyway. I also fixed... Heisenberg. Sure. Heisenberg, I'll run that... I just came back to the stream, lol. No, I appreciate you. I fixed the emissive thing that you told me about prior. And yes, I will show Heisenberg where we're up to, lighting-wise. So you're going to have to excuse the play of the movement. Sorry, the player's movement being a bit weird and funky, so... Oh, I shouldn't... To delete... Alright, so how do I just not get anything? Alright, let's get rid of this. Oh, cool, thank you. Thank you very much. I look forward to reading that. I will... Why is this complaining? Sorry, Heisenberg, I am trying to get it to run just for you. In fact, I wonder if it works without me trying to fix any of the compilation issues that I'm currently in the middle of doing something. This might be faster. Could not load a model. Okay. Bear with me, bear with me. Models. What did I copy? I can't even remember. Yes, okay. That's what I wanted. Okay, so I think we have a... No, okay, hang on. Bear with me just a bit longer. I haven't copied over the shaders, which have been changed. I just want to make sure that you can see this. I think it's going to be faster doing it this way. Sorry, I was right in the middle of doing a big change. So, but you know, I will oblige anyone who's interested in seeing what I've done. Sometimes you might have to wait a little longer than you would like. Right. So. Okay, let's see. That's better. Okay, so you've seen this before likely, but now we have a what is it called? A point light. That's it. Finally, here we go. So look, we can see things getting brighter as we get closer. So, and you can probably see it much better like this. And like this, you know. So yes, the lighting is like getting better, and you can see it even if you go in the dark area. You can see stuff. Okay. Despite that, there are issues. So I am still working on stuff. So yeah, thank you for asking what I've been doing. Yes, Ratchet has got some notes for me on my shader, so I look forward to those. So maybe we'll get even better. Obviously, that dock is, if you have never seen it before, that dock is not going to be... that's why I started to complain. That dock is going to be a spaceship, and you're going to be able to fly around and stuff, and I'm going to fix the player movement and things like that. So, right now, Ratchet, I definitely go back to... Let's just see what you've written. If it's some quick notes, I might be able to fix it real quick. At the end of the new shader, so this is my Discord server. If you're interested in joining, feel free. Material color plus emissive. You're only supposed to add emissive at the end. And only multiply the occlusion factor with the ambience. So that would be fantastic. And then, okay, yeah, that's a very good. Now you're working with proper units. You need to add tone map step to brighten things. Ah, okay, things are washed out. Thank you. Thank you, Ratchet. I will fix that right now. Thank you. I'll copy this out. I've done that. My scuffed. But let's fix our shaders even more. I will get this running in here again. I think I know why everything was going crazy before. And it's pretty straightforward. If I just... Yes. Now, if I go to game, I'm just going to disable this. Okay, so this might cause issues if I crash into anything. Alright. Nice work. Oh yeah, thank you, Heisenberg. I really much appreciate you being so enthusiastic. I'm glad you're enjoying the progress. We will be getting hopefully more progress soon for you to enjoy. See you soon, dude. Have a good rest of the day, whatever you're up to. Okay, so what am I doing? I'm going to my shaders, and nope, not that one. I'm pasting in the fix, which just is going to fix things. Okay, light outputs. Let's see what he's done. Okay, so we got that, and that's occlusion multiplied by base, ambient plus emissive. I see, so they're all in the sRGB. Sorry, before the encode. Fantastic. I will take that up. Hopefully you don't mind me just... That looks exactly what I want to do, so I'm going to... So light output, ambient, emissive. So illuminance. So we get rid of this. Let me just check everything's good. Material color. Alright, I don't think we need that. Let's have a look. Hello, Mabdo. Oh, okay, it's compiling all the shaders. How you doing, dude? Good to see you again. As usual, always a pleasure. Yes, I might... Right, so yes, we're just going to get rid of this and this, just so we can see what we're doing. Again, it might crash if I collide into something, so be wary. It's going to return this because of this. The pleasure is ours. I appreciate that. Okay, so. Okay, here we go. Let's see how that looks. Oh, yes. Very nice, very nice. So this is where we're up to. We got the spotlight working, by the way. Don't know if you're here for it, but I'm just going to avoid stuff because I think... Okay, it's fine. I wasn't quite sure what would happen. I think it's... Let's travel towards the black and see what we got. Do 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 do. Yeah, thank you, Mabdo. Unfortunately, we're going to be working on a lot more boring things for now. Okay, there's nothing in front of us at all. We're going to be working on gameplay, woo, instead of lighting. Okay, yeah, we can see stuff. We can see stuff. And obviously, we need to kind of put the light in front of the camera. Morning, Mika. How you doing, dude? Yeah, I've been doing some heavy, boring stuff all day. Yeah, oh, with fixing stuff in the Unreal Engine. Yeah, I can imagine. Right. Fantastic. All right, I'm happy with this so far. And like Ratchet said in the chat, we need to do tone mapping to like make the colors less washed out. And I think, do I want to make this longer? Yeah, okay. So in the future, we will I don't know, do something. Obviously, I hate the way this the player likes jumping around, which is going to be kind of tricky to solve. That's going to be the physics engine. But yeah, that is good. Thank you, Ratchet, for that. Alright, so let's go back to what we were trying to do earlier, which was delete stuff. And I think we're going to do it via our contact listener because it's just going to be the simplest. Or at least make some kind of entity handler class which is going to stabilize which is going to have a stable ID system and all that kind of stuff but it's going to inherit the contact listener because it's so intrinsic to handling entities that I think it's going to, in object-oriented world, the entity handler is going to be a contact listener, just because they're so coupled. It would make sense if it has a contact listener, but the way this function works is it's directly overridden, and I can't say it has a what is it called? A contact listener. So I will push up that change as well. Why not? I will. So I'm just going to push up the. What is it called? The core shader. Okay, so this may not be a great idea pushing this often, but whatever. I just want everyone to have the most up-to-date code if they want to look at my space branch. Oh, I'm glad you got the lighting stuff figured out. I appreciate that, dude. So, yeah. So, if anyone else wants to have a look, it'll at least be a little less poopy. Ratchet helped with making the final part of the fragment shader work with the occlusion and what else we do in the shader. We moved the emissive addition to the within the HDR part of the fragment shader. Morning, the Fonk channel. How you doing, dude? I haven't seen you in a minute. Hope you're doing good. Alright, so that's pushed up there so people can see the full... although it's not like the greatest push ever, but whatever. I think I would have got a groan if I was at my old company. Like, why did you push it? You should have done other. You should have just combined all your commits into one, because the Git history is all messy now. We have to go back 3 commits if we want to roll back. Ugh. Whatever. Got exams, yo. That's why you haven't seen me. I see. Well, I hope they're going well, dude. Yeah, my younger brothers and sisters have got exams too, and they're often very busy as well. So I hope all is going well on your end with the exams, and you're not worrying too much about them. Right. Okay. So is delete. Got maths 20 out of 20. That's what I can tell. Wow, fantastic. That's really impressive. I don't think I ever got a single exam to that level. All right, so we have a little bit of an issue here. How does this run? We have a instance just on the physics thing. So I believe if we do something like this, body went to sleep, indeed. Well, that's important. Bodies need to go to sleep. That just means, if you don't know, because not everyone's like a programmer. Well, aspiring programmers might not also know this, which is fine. A body goes to sleep in a physics engine when it hasn't been updated in a long time. So you can see that in the Souls games when, let's just say, you smash a bunch of barrels, or I think even like some Zelda games, I don't know. But in the Souls games, like Soulsborne, whatever, take your pick. If you smash a bunch of boxes or barrels, like you can smash all the, you can move all the what is it called? All the debris around for a small amount of time, and then it all freezes. That's called things going to sleep. So those rigid bodies that you've generated from destroying things have to be stop eventually updating. And yeah, it was in my code. I know what I was typing. I see. Okay. In your code. Wow, there we go. So you're doing physics too. Nice. I got most of the problems solved in my dreams. I see. Well, hopefully they material in reality. Right. Okay. So, what do we want to do? Where are we up to? I'm kind of pseudo distracted now because I was yapping about my old work. Okay. Yeah. So scene doesn't exist. We need to get scene in here. And what I'm going to do is pull out the my contact listener and kind of generate this. It's going to be a bit of a massive class, I think. I'm going to pull this out into its own file and say entity manager, because this is like so important. I don't know where to put this, to be honest. Currently scene is the entity manager, but let me think. So we have a scene class, right? Let me show you. And this just has a bunch of arrays in it. It's not really that complicated. And then I just kind of do whatever I want with those arrays wherever. It's just a convenient way to encapsulate the data in a way that stops things like threading getting all weird, right? By stuff being in allocated. I solve my problems in the shower or on a walk. Yes, I remember you saying. Yeah, I'm not. I don't. I have to bang my head against the wall for 7 hours straight. I wish I was so lucky. Maybe I should go for more walks. That's my problem. I don't go for enough walks. We can deviate from this. Yeah. All right. So what I'm going to do is I'm going to move this out into its own class, and here we're going to have some deletion code run. I've got to be careful here. It's still within the physics system. So, yeah, okay, so let me type this out. So I need to solve this problem before we start. Well, not solve it completely, but at least get the broad strokes. So what was this for? Huh. That might be useful, so I'm going to comment it out. I can't remember exactly what we were doing here. What was this for? Oh, yeah, I was trying to combine... what was it? Sorry, let me think. We were doing something with models, right? Combining data. I was going to combine two things together, I think. That was the thing I was trying to do. And I was doing that because... Ah, right, yeah, I remember now. That was before Ratchet told me about the adjunct matrix way of calculating a normal matrix. Yes, okay, so we are successfully calculating the adjunct matrix to get a normal matrix from the regular matrix. I was trying to figure out how to do it on the CPU, but for now, it being on the vertex shader with multiple vector cross products isn't as expensive as doing an inverse transpose every single vertex. You know, adjunct calculation every single vertex isn't ideal. Obviously, you want to do it per instance, but it's better than what it was, and I don't think there's that much of a slowdown yet. So I'm not that worried. That's what we were doing here. We were trying to figure out how to combine them, because right now the position and the model are very separate. They're very separate concepts. They're just instant rendered at the right time. So yeah, let's pick a different song. Okay. Right, so I might... No, I don't know if I just should use this. I'll have to go for now, escape points. Need to study for this Vulkan RHI stuff. We'll catch you on the Discord later. If the shader compiles, see if it's uniform. I think there will be some optimization. Okay. Yeah, good luck with your shader compilation and the Unreal Engine Vulkan shenanigans. So I'll leave this here for now. I just wanted to make sure that wasn't gonna... Anyway, so it's not too much of a big deal. So what I'm gonna try and do is... I'm gonna keep this, actually. Because I'm gonna keep all that. And write another main. And steal a bunch of setup code, I think. And just change it to the way I currently use it. See if this is... Ah, okay, yeah. That was for the comment on the pair shader vertex information matrix stuff mentioned. Oh, I see. If the shader compiles, sees if it's a dynamic uniform. I think that also will be some optimizations on it. Okay, cool. Yes, you're right. I could just compile and profile and make it actually see if it's an actual issue. Regardless, mathematically speaking, an adjunct matrix's calculation is a lot less than an inverse calculation. Regardless, yes, I should profile. That's and do exactly what you said there, kind of. Right. Let's get into the next point. So we are... What have we got here? We've got a model type, model index. I don't want this. This was never useful. We have a position, we have a model. Okay, so... And yeah, everything's fine. I'm not trying to delete anything. So what I need to basically be able to do is, based on a class, we need to be able to access this stuff. So currently this is all in scene, so what I'm going to do is throw this into scene. This builds up everything, so this actually does the so that's there, and void intit, that's going to take in setup like this. Okay, so intit, and then we want to draw, I guess, in main. And how we do this is that we take something like, we have a scene, scene, intit. This is how it kind of works in my engine, almost. And then we go, okay, scene, entities, scene models. Okay, and, oh, yes, no, we're not going to do that. Scene models type, and no entity index, I guess. I don't really know what's going on here. And if we do that, we get kind of like a update fake draw thing. That's because... Right, okay, so... Alright, that's not too important for now. Yeah, I'll just kind of comment this out. No, I'll try and get it to work. It's not that difficult. Bit more water. Certainly heating up right now in the UK. Oh. Soon my brain will overheat. It's always hottest right now in the UK. I don't know why. It's always like the afternoon, late afternoon. It's never like actually on 12 o'clock. I think it's just because the sun's been out for X amount of time. Alright, so I'm just going to kind of throw this in there and just kind of forget dealing with that, actually. I changed my mind. Yeah, whatever. We have lots of stuff. Cool. The way we're iterating through that loop is bad. That's all. Okay, so the reason I have this all here is because I need to be able to do something quite simple. It's quite easy. If I throw this in here, obviously it's not going to work, but we're going to have like a... What I want to do is at least get the idea down. So so yeah. So here we're going to delete something, but so I'm going to leave this here for a minute. The rest I'm going to yes, okay, so true. So as far as I can tell, if I put this in a different file, we can do const scene, and then oops, a to delete queue can be, yeah, so we need like a second vector here. And this is a class, no, it's all public, good. To delete. Throw this in here. Okay, fantastic. No, okay, that's not going to work. Excuse me. Oh, jeez. That caught me off guard. And I'm on the Japanese keyboard again. There we go. Okay. Right. So I'm going to get rid of this because it's going to make my life easier. And when I'm actually messing around with this, what am I doing? So I'm going to go with model type is stand-in. Oops. We're going to get out a... Okay, so we're going to have to fake this a little bit. Yeah, so the fake is that we get let's just say 33 and I'm gonna kind of fake this a little bit and so we're not doing this cast that we're doing in our code, this reinterpret cast. Don't think it matters, but okay, it really doesn't matter, it's just an int in our case. And okay, so here we are throw this in here like this, and same deal with just an entity dot. Okay, so what I'm faking here is a collision detection, and we're going to delete something out of the scene based on that. Okay, so a lot of this is just fake. So we're faking the collision detection doing something, and we're just going to get some arbitrary data out. And I'm going to hope that one of these is a rock. One of these won't be, but that's kind of realistic. Because we're not going to collapse. The rocks are never going to touch each other in the same way. So 34. So I never have to worry about that. So we have current entity twice. So I'm just going to put like let's see. I don't really need to be worried about this. I don't think so. I think I can do another assignment. Get rid of the if statement. Okay. So as far as I can tell, that is going to simulate us deleting something and pushing back an entity to an index. Then let's get rid of this. Actually, don't know what that would do. Probably just a syntax error. Then the goal is, how do I then delete something from here? So my idea was, basically, okay. So we obviously have to do this kind of like in the update loop. So what I might do actually is, give me a minute, build a infinite loop. While, God, I love it. 1, and use standard in as a way to not go insane. Oh, standard IO, sorry. And this is just going to make me so I can just... Is that right? I've forgotten how to do this. No, you read out into a variable, don't you? Character. Alright. And what we're going to do is we're just going to simulate kind of like if character is equal to 1, then do a deletion, and that would be via a contact listener object. So contact, and then what we want to do is take that and do that with scene. Nope, lowercase. And okay, so that's going to take it in. It's going to push back something to the array, and then after that, I can remember to just check. I can even write the function in there, but it's fine. Contact dot whoops is to delete q other stuff happens here. Oh no, wrong. Empty. EMT. You got a false. Then what we're going to do is try to delete something out of the thingamajig, which is in, where is it? It's here. Okay, so we've got to be careful here because we are popping out of a here, so I don't think we need to increase this by 1 because we're popping out. The array is going to move. So yeah, we don't need this. We already checked that. This, delete this. Next is loop through all the. I am going to take you. Do that there. And okay. Let's see, size. Elements. What would be elements here? Oh. On contact added, I believe, does happen in a separate thread. You need to accommodate for that. On contact added. Yeah, I actually don't know how to deal with this at the moment. Oh, this thing? Yeah, and I assume this thing as well. Okay. So, I'll do Looks like we might need a mutex. Unless there's something in what is it? Oh, in the Jolt physics engine. I don't know. I'm trying to remember the acronym for the thing. Alright, so let's just do it single threaded. And see, Mika, if you if you happen to spot some like shenanigans that I'm doing, like I just complete waffle. Code waffle, if you know what I mean. Feel free to throw them my way and then let me know what I'm doing wrong. So I'm just gonna say we don't care about this for a minute. Next is remove the body from the scene. Okay, we can't really fake that at the moment. What else can we do? Instance count -1, sure. Because what I need to be able to do, Mika, by the way, is just like remove something from the scene on collision. Something like that anyway. I haven't done that before. I don't mind, I just don't know how to do the multi-threaded part of the Jolt physics. That's what I am on at the moment. Okay, so erase. No, basically it's not single threaded. I'm just kind of like playing. This is my toy toy project. This is my toy like figure stuff out project where I just kind of like type out all the code directly and then figure out without any of the it's like how I figure out the architecture. So what I'm trying to figure out is like how to do this in a way that makes sense. So yeah, that's what I'm trying to target right now. You might want you might want to somehow signal back to the main thread if you manage entities. Seems like putting entities behind a mutex might slow it down. I was thinking the deletion queue is probably the only issue, but maybe yeah. Let's see. Let me think for a minute. Because okay. Okay. Jolt physics engine is relatively mature, right? We should be able to figure out relatively quickly. Okay, so how do you remove an object from Jolt physics after a collision? Right? It's a pretty common thing. Did I spell something wrong? I know she's getting itchy. Ooh. Yeah, that's not useful. I can remove body by ID. That's fine. I think it should be okay. Yes, remove body seems to be okay. Okay. Yeah, roll with me for a bit, and we'll see if we get anywhere. What's more important for me is honestly figuring out this cruddy architecture problem. Ah, thank you. That's exactly what I thought it was. Mika. That's my code. I'm sure. Yes, fantastic. Yeah, she goes through the body interface and you use the IDs. Okay, so that's like that handles the threading in the background. I don't have to worry about threading. You need both. I see. Okay, so I wasn't doing both. Yeah, I'll do both. Thank you. Now I need to do the other half, which is the rendering half. Okay, so we figured that out. Still, it's a good idea to do the toy. Okay, right, what I want to do is then print F, size of entities is control D. This is the render, right? Size, no, seed dot entities size. All right. Next is the last. What is it called? Instance index is yeah, I'm gonna figure out the architecture as we go. Oh, I think I've said the same thing twice. Let's go to that. Do 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 do. Oops, wrong way. Come on, go back. Yeah, one less nest. Early returns help deep nesting. Yeah. What we could do then is actually move this out. To help with nesting. Yeah, we don't need to do that, and then we do this. Make this global. Well, not global, but outside, so it sees both. Like this. So you've got a -1 otherwise, so it just errors out immediately. And oh, I did Control S, not Control D. And there we go. Instead of a deletion queue, would your entity architecture prevent you from deleting? Instead of a deletion queue, would your entity architecture prevent you from deleting an entity index at X, and just instead swap it with the last entity? Let me think about that one. The problem is for me, I have this entity index. You see that? Yeah, my entity index code is probably like the worst part of the engine. I really need to think about this. This is what we're doing today. Fab. Hopefully you don't mind coming called Fab. Is what I'm setting myself a problem. Swap and part. Yeah, let's go. Yeah, exactly. So, TT is joking about this part. Deleting entities from a queue has been like a pain in the neck. It's taken forever. But I needed a reason to delete something, if that makes sense. It never happened in a real context, so I never actually needed to do what I wanted. So right now what I'm trying to do is set up a environment for this actually to happen. so it's actually, you know, doable. Sorry, I can actually test this in anger, my solutions, because I've got like solutions, but I don't know if they worked. IIFE got normalized in my team. I was pushing for that a long time ago. That helped have multiple layers. Immediate invoke function call expression. What is that? I'll have to Google that in a minute. Hey, I just got to the stream. How are you guys doing with your tasks? Yeah, thank you for joining in, Dimitri. Yeah, I think we're doing pretty good. The crappiest part is the fact that as far as I've set things up, this is definitely like an architectural issue. Let me just type this in before I forget what I was doing, and I'll explain why. Like, what's my biggest issue is my entity code when it comes to handling things, because I've made things like really complicated by accident. Effectively, these indices that index into other arrays, these things here, this like entity index, that's literally what it is. It's just an index into another array. If I delete something from an array of them, right? Let's just can I use paint? This is going to be easy if I just have a not because it's like too hard to explain, just because I've made it complicated, so I don't want to confuse anyone unnecessarily, right? And you might go, okay, it'll just make more sense. So I have where's my paintbrush? There it is. Let's make it large. So I have like an array of entities, and this isn't like a true component system, by the way. So now these have an index into them, like say 0, 7, 8, 22, 1, 6, 40. They're all unique. 9. I don't know. 2, 3. Just make sure I haven't got any twice. And the problem is when I do a delete, these refer to like another array, right? So just make this red. And it's the same deal, right? Where it's like these have data in, and blah, 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 blah. It goes on and on and on and on and on. This might be way longer, by the way, so it's like, I don't know why I'm trying to match them one to one. Yeah, it goes on and on and on. I'll just go a bit faster, be a bit sloppier. And if I go to white again, like this refers to here, and what I do is I loop through, and obviously it goes like 1, 0, 1, 2, da, da, da. This refers to like here, and so on and so on and so forth. Now when I delete something from here, like say I want to delete this guy, then it's like, alright, so we have one less. I have to delete something from here as well. Maybe I don't actually. So, and basically, the highest index, let's say 22 is the last one, can end up referring to something that's already been deleted. So it can like, so pretend this is like 22, and this is like now freed memory. So this is like, I don't know, this is like freed memory. Because number 1 was deleted, everything was shuffled up one. Sorry. Everything was moved. Like, let's just do it like a general arrow, right? Everything was shuffled across. Then like 22 goes, alright, yeah, let's access this exact one here, because I still have the number 22. And what ends up happening, obviously, it just accesses bad memory. It goes, what are you doing? Crash. Or it just goes, you know, vector out of range or whatever. the equivalent error is. So what I do, which is my crappy solution, which is the worst thing in the code, honestly, is I find every value above 7, or above 1 in this case, actually, and then I subtract 1 from it. So if I take this, and it's like, okay, so now this is now, 21. This is now 8. This is now 7, etc. The list goes on and on and on. So that's what I've trying to... It's like a really crappy way of managing things. This is so that instead of this going to here now, it correctly goes to... let's just do a green arrow for correction. It kind of goes to here, which is now the next new thing. Sorry, this is like where whatever 21 was shuffled over to. So if this is 22 now, this is 21. This is now 22 in theory. Now it's 21. So 22 becomes 21, and now this needs to be match up. Anyway, so TLDR. So that's my crappy code. If you have any questions about it, I can ask. I'm just going to read what Mika said. TLDR. The lambda. TLDR, you make the lambda call. You make a lambda and call it immediately. Inside the lambda, as soon as you figure out something, you return from that lambda. Okay. You can do tombstones. Also, you can swap with the last and remove and the last. In this case, you would only need to update 2 indices. But if you iterate over an unordered array, you wouldn't need to rearrange the ordered array. Couldn't you just leave the space open and add an index into the last open index and reuse them? I tried that. I know what you're saying. Basically, you instead of deleting it, like actually deleting it, you just fill it in with something else, right? So I don't know. So if I wanted to delete number 1, which is this guy, so this will be this, I guess. We do a delete swap on it. Well, we do a swap, so this goes over there, and then we fill it in with something else, right? So then we do like a, I don't know. Okay, so that filling with something else is called a tombstone. Oh, I see. Yes. Okay, I didn't know that was the technical term. So yes, we'll do tombstone or something. What I'm thinking, guys, is yes, you might be onto something, but I need to think about how I do my instance counting. I think this is a big problem of mine, where instance rendering wise, how about I try and solve this problem first instead of deleting something? It's a bit trickier than you think. I do understand what you're saying, guys. It's not. So it's hard to explain. Let me. The second issue that I have with this, which kind of makes it complicated. Now I would do that. And by the way, thank you for suggesting things. By the way, it's always welcome. Yo, how you doing? Joel JO0101. Okay, so so here's the issue with what we've currently got at the moment. We have a variable that counts the instances, right? Yeah, thank you for joining us, by the way. I hope you have a good rest of the day. With whatever you've been up to. Okay. So this isn't like set in stone, but effectively I have this value which counts how many instances of an object we have based on the model itself. So we have to be very careful here where we have to remove one from the instance. We have to decrease by 1 every time we do this for every single. So like, let's just say that this is a separate array. There's only 2 in this. There's actually only 3. There's only 3. There's one in here and three models in here. Okay. Yeah, I really need to plan this properly, otherwise, because what I need to do is rewrite a lot of this. It's not gone well. So it's not like I'm trying to say I don't want to try your ideas or anything. It's just that I've written myself, code-wise, I've written myself into a corner, if that makes sense. I've backed myself into a corner. So for each model, there is like an instance count. And that instance count corresponds to a model. And that model counts how many instances there are. And I have to subtract 1 from that instance each time. But I also need to go into... so on top of that, after I've deleted something, I currently, which isn't ideal right now, but lazily, I delete my positional buffer, which is a buffer that contains all the positions of each instance. So we can do instance rendering. And I need to figure out where in that array do we delete something out of. Otherwise, if we just put like a dummy value in this buffer, the instance renderer is gonna pick it up, I think. It might not actually. I haven't thought about this. But instead of deleting something, how about we try this, right? Instead of deleting the buffer, how about we do a delete swap, or do a swap, right? And then we do some silly value, or it doesn't make any sense, that no one would want. And then, let me think. We don't have to recreate this buffer from scratch. Would you be okay with using an off-the-shelf ECS like Ent? Or do you want to figure out an ECS for myself? I don't want to use an ECS, but I was, in theory, trying to make this simpler, but I've kind of overcomplicated it because I wanted to use a data-oriented design approach for some reason. Instead of like trying to think about what was the simplest thing to do. So that was like a mistake I made earlier on. So I basically made a mistake that's caused an issue. It's more architectural than is anything else, which I'm fine with admitting. Okay, so the first thing I might try to do is, instead of deleting stuff out of the array, how about we just do one thing at a time? There's multiple moving parts here, and maybe I can simplify everything down by first dealing with reducing an instance from the scene. Okay, so I need to make the demo scene again. So that's the first thing I'm going to do. So instead of doing this collision detection stuff, what I'm going to try and do is not delete the buffer from scratch and recreate it. What I'm going to do is do a tombstone on that buffer, which is fine as long as I don't read from it. I'm allowed to write to it, but I'm not allowed to read from it. So I can't know what the value is, but I'm allowed to write to a buffer. Oh, that makes it harder though. Because how do you do a swap on something? AKA move the beginning with the end. No, it's not going to work. Nah, it's not going to work. I usually wrap it in... so I'll read that in a minute, but effectively that's one issue that I've got to deal with. That I could improve on. The next issue, hopefully you guys are with me still, is the dealing with the CPU at GPU. So the way this currently is working, which is just one issue, is yes, we have this array of things, but this is a buffer, right? This is actually a buffer, not a... So this is a buffer. Buff. I was to say that buff, right? And it has positional data in. So it has positional stuff in. And I'm not going to write all the lines like I did last time, but you can imagine it has X, you know, Y, and Z, right? X, Y, Z stuff in it, etc. All the way to the end. Now, if I just take one of these values and just kind of do a swap with it, oops, that's way too aggressive. Like this, and then, so this is like a valid. This is like the one we're deleting, so we're moving that to the end, and this is one we like. We're moving it here, so this is, and then I don't know. Let's just color this in red, right? This is a tombstone. Okay. Now, if I then do that, the GPU doesn't know what I've done. There is no real way to say that. Oh yeah, this was now once at the end. So this was, let's just say, this is ID. I should pretend instance ID. So this is I don't know, int ID. Hopefully you can bear with me while I type this out terribly. So int ID equals 0 and then 1 and then 2. So this was 0 and now this is still 1. I'm using GL. What is it? Instance ID? Like instance. Ugh, sorry about that. Oops. Now, when I have this instance ID guy, the problem is it's expecting everything in order. So if I do a swap, I think this could be, I could be completely wrong here, by the way. Then another object where its instance 2 is at, right? Instance 1, sorry. So instance 1 has now got a different position because it's a different order in this buffer. Because this has an array of straight positional data. If you do a tombstone, I see. So we just do a stupid value, maybe. Okay. So instead of doing a swap, what we're suggesting here is, let's just say we want to delete 1. We don't do a swap at all. We are going to take. I'm gonna take this. Okay, I'm just gonna redo this for a minute, just for a minute. I'm trying to make this bigger because this is like pathetic. Oh, I know. Let me just I've forgotten, obviously. Solid fill, and this needs to be also black, and then we can just do, nope. Excuse me. Give me a moment. Fill black. Nope. Go black. Why are you being okay? Thank you. Sorry, I'm just trying to figure this out. So yeah, give me give me a minute. Okay, so we're gonna do a tombstone. So we're gonna do a, you know, oops, white, and then yeah. So restoring. That was probably a waste of time, but hey. Okay, so we want to delete 1, but then we're gonna make it silly. We're gonna do some stupid values in it. And we're not gonna actually recreate the buffer at all. We're just gonna completely like junk out the values. So 1 has a silly value now. That means like 2, 3, 4, 5, etc. All have their same values in, including the end one, which is a problem child. All right, I like that. Let's do that then. Okay, so that's the first thing I'm going to do. So I usually... Did I read this? I can't remember. Sorry, I'll read it again if I haven't. I usually wrap it in object-oriented such at a moment... at some point it becomes easier. Yeah, that makes sense. Okay. If you tombstone, you don't need to swap it. You can just... okay, that's what we're doing. If you have a copy to a... This could be a copy command. Let's say you have 100 entities and relates 1 equals 99 entities. You wouldn't read index 0 as it is. You would copy into garbage. New data would be copied into the garbage one as soon as... Oh, that makes sense. In short, leave the old data. Yes. Okay, so I think you're both saying the same. Thank you, Fab, as well. I think we're getting there. Almost as if Paint isn't the optimal... Almost as if Paint isn't the optimal program for drawing. Yeah, it really isn't, is it? I don't really have a... if you guys have a solution, like an actual drawing app that isn't just this, then I'll be happy to use it. But I want to be able to just clear the screen and draw, you know. I don't want to... GIMP is too complicated. Like, GIMP... if I tried to do it in GIMP, it would be like... Alright, how do I make it black? And then... Let's just try it. Where's the paint? Pencil. Nope. Make it smaller. Nope, it's not the right color. Okay, cool. This is great. Okay, so now I want to make a rectangle. How do you make a rectangle in GIMP? There's no like, oh, make a rectangle button. It's like, what do I have to do? Like select an area and then make it. I don't know. Yeah, I think you might be right. What I'm going to do then is... Yeah, what I'm going to do, guys, is for now, let's pretend that we're deleting something. And we're going to remove... all we're going to do is I'm going to just forget about the instance drawing. I'm going to delete, air quotes, delete it. Oops, that's not what I want to do. Fake a delete on a random entity. And we're going to remove it from the buffer by setting it to a junk value. And the instance, the problem is, okay. Does it matter if what we end up drawing to that point is just crazy off the screen? Just use Control Shift Brush. Oh, is that? Because that's basically all I need. I need to be able to. All right, Control Shift. Oh, what? Oh, brush. I'm on pencil. Anyway, I'll look up something. I'll look at what Dimitri said. Krita is cool, but because it's open. Yeah, I'll look at some like normal tool. Anyway, GIMP is complicated. Yes, I think you're right. There is an excellent plugin for Obsidian, I heard. Oh, really? Okay, that might be an option too. Okay, I'll look into both. So Krita, I'll write it down actually, so don't forget. What is it? I might be saying it wrong. and a plugin for Obsidian. Okay, so I think what we're going to do is we're going to fake deleting, and we've got to be able to. No, we're not going to do anything with removing its model. We're not going to do anything with its collision geometry. This is the biggest problem right now, I think. This is the number one issue, where the instance drawing gets in the way of everything. Okay, so let's fake it. Let's put in a random. Okay, so if right, let's just see if this compiles first. Hang on. Let's fix all the compilation issues. Get rid of this. Take this. This is the only thing we're going to need for a minute. Let's do number 0. I don't think I'm doing number 0. Ooh. Scene is under. Oh, okay, hang on. Alright, so I'm not going to do any of this for a minute. This is just not interesting. 2 deletes. Oh, I did it again. It thinks we're in a function now. Alright, so. Right, okay, so. Right, I just wanted to, just make sure it compiles. Does it run? There's nothing silly happening. I haven't written anything stupid, have I? Okay, cool. So we're gonna fake. We're gonna make the demo scene again. So the next step is make the demo scene. The demo scene is just those rocks in a row. If you've probably seen that before, right? So unfortunately, we're going back to that, and that also means we need to remove the. In fact, I'm going to compile this for release just for a minute, just in case anyone wants to see what I've done. I can just click on release for a minute, right? Obviously, this isn't ideal. Actually, I'll move it out because I'm going to break everything for a bit. So yes, I'm going to compile for release, and then this is just for streaming reasons. Occasionally people say like, "What are you working on? How's the game?" etc. It's important that I have like a quick thing for them. So I'm just gonna because they just want to see what we're up to. So yes, we're gonna do that first. Then we're gonna go back to the demo scene where everything's in a row. And we're going to use tombstone values instead of deleting things, and maybe, just maybe, that can simplify everything down without us so yeah, I'm just waiting for what I need to do next is instead of staring at my development thing, I need to throw my shaders in. Whoops, I pasted a shortcut. Let's delete all them. That would be a complete waste of time. Okay, fantastic. Just let this build a bit longer. It's likely building, it's building jolts, so not much I can do about that. I can at least make the assets, make sure the assets are there, so let's get the assets as well. I probably don't need all of them, but I think I'm gonna clean up my assets folder soon. I think it's getting incredibly messy. Yeah, okay, so it was missing some. That's good. Alright, so we just need to wait for this, and what? Yeah, like I said, what I'm going to do is... No, it's not. I keep forgetting to turn it on. And then I'm like, oh yeah, I'll do it next time, and it's like, after a rebuild. Yeah, let's turn it on. How to make Visual Studio build multi-thread. I know it can't do it now, but let's just turn it on for next time. No. Bro. No. That's not useful at all. Okay, so tools, options, build. Okay. So let's just do this. Give me a minute. I'm going to have to save. Go away. Go away. Okay, so tools, options, projects P, build and run. Hopefully it still exists. Only build, start, or projects dependency. Okay. On run when building a dependency. Do not launch. Huh. Where? Okay. Oh, so maximum. Yeah. Oh, you're right. Okay, you're completely right. Brain fart. As soon as I regenerate my project. Okay, I'll do it. Yeah, I don't actually know how to do it in CMake, so we'll leave it for now. It doesn't really matter. Anyway, so let's just see if this works for anyone who wants to ask in the future what my game looks like. Or where we're up to. You're right, I need to do it in CMake. I can't do it in... Okay, so this is... just make sure it's like roughly looking correct. Turn off this. Yeah, that duck is still moving. I crash into it. Oh, okay, I missed it completely. But anyway, go full screen without any... Okay, it goes weird if I do that. Yep. Okay, fantastic. And close. Cool. Right, what I'm going to do is just... Remind me... If someone's on stream and like I'm... So, yeah, what I'm going to do actually is... it's fine. It'll take no time at all. Alright, copy. I'll just stick it here. Yeah, thanks for bearing with us, guys. It's just because we're going to completely change everything in a minute. And so we just need like a... Yes, you can build in parallel using CMake. Yes, you're completely right. I just don't know the CMake commands to make that work. There we go. Now let's just make sure this works, otherwise that'll be embarrassing. Yeah, okay. Cool. Fantastic. Right, now we can change the demo scene and do everything else that we need to. Ah, let me send you my work. Oh, you actually know how to do it. Nice. If you want to help me out, please do. I've worked on my setup for a very long time. I see. If there's like a if you want to share something with me, I'd be very grateful. Okay, so we don't update the player, and that's basically the first step. The next is to go into the scene. And where's the scene at? Oh, yeah, it'll be higher up. The song is so good. Yep, that's what I want. And let's just make sure everything's correct in here. Yeah, let me know if you, yeah, Yeah. Let me if there is some code you want me to share, you want me to look at, yeah, please let me know what it is, and I'll try my best to get it. Okay, so hopefully this should do exactly the same. Although I've moved stuff around a little bit, I don't think it's that different. Oh, I'm in release. Let's that's why I copied things out, hey. Yes. It's a good job I did. Okay. Stop. Why did you build? Okay, so we need to figure out what I did wrong. It's probably something to do with this, because I changed a load of stuff here. And I didn't update the demo scene, so that's going to take a minute. Okay, so... Oh, okay. Yes, if we don't update the player, there's no position. And get body ID. Okay, so we just need to get rid of the player, I think, in every single case. Which is fine, because there's nothing... Oh yeah, because the player doesn't exist. Yeah, let's... Why is this even happening? I'll just comment it all out, it's fine. Okay, so... Let's get rid of this as well. Any other use case? Okay, so we don't press R. And... we're going to handle events. Nothing player related is going to happen. Get some water. Okay. Let's see. Let's see how we're looking. Okay, that sounds good. Yeah, in this case it's good to turn off the lighting. So I'm just going to do that because it's hard to see everything. I don't know why this demo scene is just poorly lit. Even with the directional lighting on. You know? It's like only lit with a... which is strange. It should be lit with the directional light. Okay. Anyway. Regardless, it'll be easier, even if it was directionally lit, to use. It might be all missed in that one direction, which is entirely possible, but anyway. Oops, I'm going to say F, turn off lighting. Okay, so we should have now everything kind of obviously lit. Yeah, just albedo. Alright, cool. So what we're going to do is we're going to delete one of these guys. Nothing in particular. I'm not even going to try and do indirect stuff to it. What I'm going to do is just reduce the instance draw call count by 1. And now we've got this far, we'll be able to see it. Remove a dummy, dummy value or something. So yeah, let's go back and add in a dummy value based on, instead of a good value that's actually used. Okay, so let's see. We have 2 buffers, so we need to do this twice. We need to find a thing that we want to delete. Okay, so the first thing I need to do is use the positional buffers current index, not destroy instance, but yes. So no, wrong. We write to it later. We actually just need to access the actual original pointer. That's going to be written to every single frame. So, yes, that's right. Okay, so I was about to do something very silly then. So buffer, so current frame, and okay. So how do I access individual components again? Oh, that's it. That's actually what I want to do. Wrong. I did it wrong again. I just got a bit confused and I thought I was doing the right thing. There we go. So at entity index, I don't know. As far as I'm aware, let's just look at my scene again. I'll set it to you now as I write this description. Can I send it to you in private? Yes, you can. Please do. You send it any way you want. Okay, so I believe I'm gonna try and delete. 11. I think that's the first rock. So its position is going to be. So let's just see if that's right first. So. The first thing I'm going to do is move it. See GLMs. Mat force. Identity. Why aren't you happy with that? Oh, is that right? C GLM Z mat force. Oh, force identity. I'm just gonna do GLMs. There it is. Okay, cool. That's the first thing we're gonna do. Is just write it to 0, 0. When I press 0. So I think it's going to be this rock here. So it's just going to go boop. Oh, okay. Well, what moved? One of these moved, which is by design, but I just moved the wrong thing. Where's it gone? Oh, there it is. Oh, okay. Oh, I remember now. Let me fix that. That it needs to be not. It needs to be 21. There we go. That should work. Okay. Okay. So. Oh, did I press 0? Huh. What? I'm confused. Let's try 22. I don't know. 22? What is happening? Why did it work before? Maybe, I don't know. Alright, let's just try 1. Okay. So I'm dealing with like raw data, raw buffers here. No, it's, why did it work before? No, it just didn't. Okay, so, a bit confused. Okay, so let's do 21 again. So clearly that did it. No, 11. Ugh, wrong. Build. Okay. Cancel. 11. Alright, so clearly that works. So let's just deal with this. It doesn't really matter, honestly, what we're deleting, as long as it is being deleted. So, okay. So, that went to the... And we saw that this guy got removed. Okay, fine. We are removing a duck from the scene, so what we're going to do then is take scene dot models model types, I think. Model type? No. Entity model. Ah. Oh, that is correct, actually. Instance count -1. Okay, so what I'm going to do now is just go insane wacko mode. Mat falls S. So I'm going to take the deletion. Oh, I need that twice. Deletion matrix, and that's going to be equal to that. And I'm just going to say, because I don't really know how to make like a crazy matrix where the data is completely insane, that we just know it's deleted. So what I'm going to do is because I'm not that sharp on the maths, you know. All I'm going to do is equals to max float or something like that. Float max, is that right? Whatever the max float. Give me a minute. Uint 32. Oops, 32 max. Where is this? And what's the other ones? So int. And we have. Let's move the mic closer to me. Oh, whatever. This will do. This will do. It really doesn't matter. As long as the binary is being set up with some like the number's being sent with some random value, like off to infinity and beyond. Then we say the deletion matrix is equal to this, and instance count is -1. Control D duplicate selected area. You can't just set. Thank you for the numerical limits. I know. That's what I just remembered. FLT max is actually what it is. Yeah, it's FLT for some reason. Anyway, thank you, Dimitri. I saw your comments. Thank you for the sorry, comments, DMs. I haven't opened them yet. I'll open them off stream. But thank you for sending them through. You can't just memset. Also, you can't just memset the whole entity to 0 or 1 or whatever. No, because that would mean that it could be rendered basically in scene. So let's just see how this works, right? So float max. So I press 0 and it's gone. But now I've got to see if it's around, you know. Can I see it? Because that's honestly the biggest problem I'm having right now, is actually removing something from the scene via the, you know, the renderer is the issue, not the... You know, I think in theory I could find it if I went off and like, oh, hang on. Okay, so let's get rid of the instance count reduced by 1. I think that's what happened there. Well, that's the only thing I'm doing now is removing, yes, one thing at a time. The first thing I've got to do is make sure that nothing else breaks when it comes to its positional buffer, right? So 0. Oh. So I've got to make sure like everything's correct. Okay, everything's still correct. So it's still rendering something, but it's been moved off to oblivion. Now obviously this isn't ideal, but I think that's better than what I was doing, which was deleting. Oh, I also realized I need to do this for the other buffer. I'm just going to do this real quick, and then I will... Okay, yeah, so I can't... Yes, I need to do it here too. I almost forgot. So 0, and then we're going to look for that duck again. Yeah, okay, so it's gone. So it's a deleted entity that's been drawn, just moved off somewhere to max, wherever max float is. I've literally no idea where that is. My far planes have definitely culled it off, by the way. And I think it'll be so small, I don't know how long that would take to get to your far plane. X, Y, and Z. But this is definitely an option, I think, for me, for my engine. Oh, you zeroed out the last transform matrix. Rendered at a scale of 0. Not quite. What I did is I took the position. That's actually not a bad idea, actually. I could actually shrink it down as well. I just took the position and said, all right, the X, Y, and Z position of that object is in it's max float for X, Y, and Z. So that is, you know, far away. Yes, you can move pretty fast in this game, but it's like to get to the max float's X, Y, and Z coordinates, you're going to be in you're going to have difficult situations, you know, if you get that far out into infinity. I'll probably block you off from getting that far anyway. I mean, if you set the mat to 0, that's not a bad idea. All right, guys. One more thing. I'm going to share my Discord while everyone's here. Feel free to join. Anyone can join as long any experience level. And I will be working on this, researching this, and fixing my CMake at the very least. Thanks to Dimitri. You could assign an index into a positional buffer index and create a render component. Then you could use the positional buffer and fill up every frame. Yes, I'm going to have to end it here, guys. It is 5 o'clock. I've had a great time, so thank you all for turning up. I apologize again for not realizing the chat had stopped working. But anyway, I hope you had fun. I hope you have a good rest of the day, and I hope you all succeed in whatever endeavors you're in pursuing right now. So yeah, I will all see you soon. All right then. Bye guys. Bye.